I'm so gross. I'm so freaking gross.
Are you doing question 5?
Everybody else is already learning outside.
It's like a team comp.
I bet everybody else already did it.
I think we did it. It's a team
This is the least team comp like attempt at this team comp I can imagine. It's like other members of your team have done it.
This is not. I'm so freaking gross.
Geometry, normal or batch?
Just avoid the face. Wait, that's useless. So close.
He's doing question 4. What are you guys doing?
I'm trying to I have to prove something for feuerbach, and I have to prove something for some theorem.
Oh, okay. See, I could actually, my role could be to just imitate Edwin, as if he was here.
Oh my god, so fun. Real guest.
Some illusion.
Sine illusion. Sine illusion. Sine. Don't worry, once you get the theorem, it's so good. I can beat this with how you feel. Stop counting down. B squared, zero, B squared. B squared. The last one. So, they do something on it. Right? Okay. Right.
Like this. This is just
Oh. Wait, this is what I did.
Yeah.
Oh, nice. Wait.
Yeah.
So you start with this and then go to the back. Yes.
Those are the-
Okay. You write this down. I'll write your own.
Okay. Synthetic.
Yeah, do that after. Once we have one copy now. Yes. Okay, box.
Oh, thanks.
Right. You don't want to make it. we write how many pages do you think will take? I'll be way away. always in time. Or you cancel out the video. Yeah, you cancel out the so it's gonna be let's see the video. Wait, you have like this B and C. B and oh, that's one.
Yeah.
Oh, okay, yeah.
It actually put this.
So only thing mostly you'll be doing by this paper.
Yeah.
Oh, okay. Yeah, okay. After this, right, I guess pages.
Focus. Yes. Focus.
Okay.
We first treat back to prove a theorem. Theorem.
Oh.
And then we code back to prove the question. We first, because it was like the question had a median, and then so it was basically proving that PD was the submedian of the triangle APB. And then so we first showed that the submedian intersect at the two tangents of collinear, and then after that using trig, and then after that we put back to show that they intersected at the same direct point.
Cool. A team of 2, I guess. See fun. Yes. Usually teams of 4 or 5. Stay right. I'll just stay. Okay.
Do we find it?
Oh.
Solve. Wait, let's go small. Introduce.
I'm doing that.
Okay. This is my take for how long.
Yes. Pretty sure I got 7. Pretty sure I got 7.
Ooh. Positive integers.
My tripping, why does this work? So yeah, if A is, if let's use A is greater than 1, right? Is, and then B is greater than A. So you can do this. You know, you expand with AC and A, and then you go, and then you subtract C from both sides. Like this. And then you subtract C from both sides. Like this. And that's just that is see,
As no one's on question.
so then
Okay, shit.
No, this is question 5.
that's
Wait, what's Edmund doing?
Everything's 4. Right? Have you done 4?
Yeah, so
Has he finished?
is Edwin there? So Sean says he got 7.
Good. Has anyone got like question 4 yet?
People are wondering if Edwin's got question 4 yet.
Because like if he got that, then there's no point.
There's no point.
But you what?
There's no point, dude.
I mean, like which questions have been taken? So question 5 is taken. Question 7 is taken. What else? Question 6 I think is also taken.
You can do 4.
4?
You can have 4.
Maybe taken. I'll try.
Maybe take it.
Because I haven't like
Yeah, do 1.
One is hard.
1 is shoot. That is actually really hard.
Oh, there's. It says time for questions 60 minutes.
So you get 6,000.
But you get 5 hours for 4 questions.
It is actually minus 2.
right, yeah.
The people here don't know how to do math. They thought that 4 hours, 4 questions times 60 minutes equals to 5 hours.
Huh?
Yeah.
The people who made this test do not know how to do math. Because they thought that 4 questions, and if each question takes 60 minutes, and
Yeah.
4 times 60 minutes is 5 hours.
Yeah, I guess for you guys, it's like time for questions 60 minutes. Time for just like BS chatter 1 hour. But they were kind enough not to actually write that down.
Oh yeah, true. Because the BS chat is also that.
It's another one of those Europe things where I say the order of the problems does not depend on difficulty.
Yeah, that's sad.
I guess they were nice enough to actually tell you though, as opposed to just scramble and not tell you. Or it'd be weird if like randomly they turned out to depend on difficulty, but it wasn't their intent. Oh, 4 looks like looks familiar. Like one of those things.
Pretty sure it's like something similar, like in a TAT like 2 years ago or 1 year ago. But like you have a bunch of sevens and you have
Yeah, a
to,
bunch of sevens.
Yeah.
I remember that. Freddie got it.
obviously. What time is it?
It's just 12, 20. We're gonna eat soon.
Oh, okay, so same 12:20 in 2 languages, sure. Wonder if anyone can say it in third.
See, if you were gonna leave early, then we would not do these problems for as long. But if you're gonna stay, then we can do it for a little bit longer.
That's weird. No one's working together. This is kind of
They're working together, I guess, it doesn't necessarily just happen automatically. You have to reach out,
weird.
go out of your comfort zone and be like, hey, what's up? What are you doing?
T8?
Oh my god,
I wonder if anyone's on T8.
I don't understand T8 because what's this notation?
I might have an idea what that means.
Too copied.
It's just weird. Actually, screw it. I'm gonna do T8. I want to see if I can do it because I have an idea.
It says progress is slow.
What words?
So which one are you doing, David?
E. I don't know. I'm trying to I have like a small idea of what's going on. I'm just using like the sum of factors thing.
MB positive
Three.
Before I try to
No, it is
the
this
same
one.
word.
Yes.
is equal to product of n times.
Well, what if we expect?
Oh, so this is saying n is a product of Fibonacci numbers.
Okay, sure. And then it has 2 factors. Let me try. 2 prime numbers. Excess. So when I wait, actually told it.
Alright, so Sean got 7. You guys got 5.
You try 6. You can do 6.
6.
Wait, isn't 6 already done?
No, 6
No,
on
five.
5 is done.
Oh.
You can try
6 actually looks pretty hard. I tried to draw a diagram.
Oh.
The 6 is hard as hell. I'm just incapable.
Okay. Then.
Shit. How do we do
Oh,
this?
shit.
Did you guys get the questions on WeChat?
I did one. Like two.
Oh, you got 2 of them.
The ones I said to you were the ones I did.
Yeah, so the first one and the fourth one. Yeah. There was 4 questions, I think. Wasn't
Yeah.
it? Yeah. And then there was a geometry one,
Yeah.
and then there was
There
like
was
2 functional equations, 1 geometry, and 1 like random sets.
Yeah. I did the sets one. Oh, that's over.
And it's 1 grade. It's square.
Yeah.
Yes.
Right. It's only 2 times 13.
Wait. 5, 2, 10.
Wait.
1, 2, 5. Shit. So,
It's somewhere in between.
holy.
You find an example that
It's
works?
something
On
around.
question 8.
It's,
Yes.
it's approximately
10,
the
n equals 10.
I do like suppose like it is a part of 2 times, right? And I got
Yeah.
this. I did some stuff.
Oh, so you proved it for the case that it's approximate 2 primes.
No,
Yeah. Yeah.
I did not. I did prove it. I
Makes
did find an
sense.
example.
Right.
If you like.
That's weird.
Somehow.
I guess if it's approximate 2 primes, then you make these Fibonacci's to be primes.
So if you add and take away.
Wow.
from it's-
I hate to do this, but I might have to. I don't know.
So if you take away
Crap.
this from here, you get this. So if you put this is not the original.
Oh, yes.
And you can probably see that.
Oh, really, yeah.
Because I'll do with that. Probably other cases.
Now do kind of this.
It's pretty much
Okay, nice.
slightly less than replace it with E plus B. Oh, yeah.
You can do 21 but not 17. This question's 4.
You can't do 17. Isn't it just 2 to the 4 plus 4?
You can't use power.
Yeah, but you can do 2
plus
to
2
plus 2 over 2.
in addition to 2 divided.
Okay. How many 2s do you have?
17.
You can
So
use up to 17.
Oh, that's
it's way more than enough for like the first few.
You know, screw it, I'm gonna retry push the keyboard.
Does he mean like the number of 22s for that?
Hmm.
But he can do with 21 2s but not 17 2s.
I want to see if I can do that every number less than 0 equal to 500 less than at most that's 14. 501. So 5 hours is like 18,000 seconds. Right? If we do T4, if we bash every single number, I think we can actually do it. We can bash every single number from 1 to 2015. We will have like more than enough time to do like the rest of the questions. Should we try that? Okay. I'm gonna do it.
Wait, is it 5 hours? But it's like 4. It's like 20 man hours.
You could get like the fast thinking person in a team to bash all the cases.
Isn't that you?
Well,
Alright, let's eat.
It's not equal. Then you extend this. Then you get this. You get this. Then it's easy to like it. It doesn't worry about that. And this is other cases. You can't do it as well. This is other cases. Just need to get that because this is the way it's done.
Oh,
Just get this out.
I still can't get the chat.
Awesome.
Then like the that would be like and like this like I know I'm gonna
因为肉太多了。
Wow, everyone's passionate is so good. I doubt he'll ever do it. I doubt he'll ever do it. He's just gonna use it. He's not going to position to one.
Oh, okay. Everyone thinks he can do it. I think it's the twos.
That looks good. You just have to use
Yeah, no, you don't even need to. You can like for some of them you can go like you don't even need to, you can do like because you can't necessarily do that because otherwise if you go half and you go half, you can't run out of like if you do like what? So you want to get to like 2 to the power of something and then times like and then you can do like different corners of those. 2 to the power of something and then times like 3 to get like 3/4 of it. Yeah, so that's even faster than like I think everything works like just do like plus 50 and then you have just do plus 20. Yeah, it's all just that. This takes like 2 days. And I can 20 5 people. 460. Yeah, that's all. Easy. I'd say it's doable. But people work with it.
Oh god,
Wait, at what point does it become inefficient to go like to there and you just use it as you just add it? I think it's like 4. So you get the multiple like nearest multiple 4. Yeah. Not enough. You just keep and then you just add. You just do that like you can get any multiple of 4 and the other instead. Yeah. You've got 2 nuts. It's stuff like you need 7 or 8 of power. To the something you just go.
没必要吧？
会凉
不要做下来吃就好了。
啊？
要不做下来吃。
Boom. Yeah. For each thing, okay.
Eating people, let's go. How being the maximum amount of T1 is T1. How do you get T1? How do you get T1?
I push 2 out. 650.
You know what's good? I'm only gonna eat these.
Are we gonna go out?
We went 2 days. One day.
Well, I have chopsticks. That's one.
Oh, I just do it.
Really?
I just use it to grab that. No, not that.
Is it I get you like this.
Oh, it's
Oops. My son got.
I very quickly. You can get from me.
almost like
It's like less something. Here's chopsticks at least.
The one that you use, yeah.
Exactly. It's nice.
Yeah.
So I'm just gonna take these transfer fees on that number. That's it. No, 3 chopsticks slice.
Oh, right. Yeah. It's that way.
1. Not 3 strands. I just got 2. 3. That's gonna be my meal for the day.
For the time.
Right,
Grab a
needles,
seat. Some behind you.
the needles are pretty good on that ocean glass. What? The needles taste pretty good on the ocean glass.
Oh, they're cold if you don't put the soup in there.
Yeah, then I like them. I also like to eat needles raw, so yeah.
Okay, maybe say
Does it also have to be open the chest? Wow, they're pretty small. Basically, pig villages in Moldova.
It sounds like mine's.
It is Minecraft. Oh, Minecraft, yeah. The new, now they updated.
Yeah, they're like the
It's like the spirit metal.
Yeah, and then
The diamond.
the healing treatment we call it something like
And it's like this really,
It's
like
what-
this
what
new,
they have.
really red wall, which is like basically an insult.
pickles. Basically they're having new method of work. Like
More.
basically
competing with software light.
so
You can also zombie competing.
they have pickles if you open their chest they don't hold you like it's not very holding on they hold you. Then
So now I'm
if you throw them a golden ingot, they'll give you like a diamond. And the diamonds are pretty trash, but they also have
imagine if you got that derived from
they
the
also they also give you like obsidian and wood.
What about netherite? It's not like this really new OG metal.
Yes.
It's like when you come up with like diamonds or like gold, you make like these really like, cool stuff. It makes diamond and armor look like a wooden pickaxe. Well, except that one is armor, one pickaxe, and they're both trash.
Like if you if wood high enough to win
You split
Mining
it.
is not like movie stuff. You have like, I think, like one ticket is today. You have like one ticket is today. So,
You want to mess it up?
oh, cool.
I want somebody to mess it up. I go up like a day, like, it's just like, not mess it up. No matter what I did, I just can't mess it up because there's less cases and stuff. So,
Oh,
Michael, how do you talk?
I don't know. You don't figure it out.
Okay.
It's just like, it's not even like, I feel like it's not even able to be figured out. It's like I have a screen, there's no choices to make.
You're having to do it.
Yeah. I've actually tried all the buttons.
That's true.
No, I should have tried that one.
Yeah, I really destroyed that.
You probably should just end and make it because that's what worked last time.
Wait, anyone do the live stream? Dude. And he's just watching us eat.
No, it's not even looking at us.
Doesn't see anything.
They should tell it towards us, and we should change the live stream name to watching Asians eat noodles.
David does not represent the views of the group.
High on hit. Okay, no one said that.
Said what?
Imagine just eating noodles.
Because that's meant to be a 2-day problem thing, yeah. It's not a
Yeah.
Most of it, sometimes 10 hours. I guess it would be like 40 man hours.
Shit.
People didn't do questions that were already done by them. They're checking it by redoing. So we spent about 2 hours. I probably won't be able to spend the full 5 hours. I don't know if you do. Huh? Is it just what?
Yeah.
Did five.
Yeah, I think that's second. Has no one done question 1 yet?
What?
I'll get second.
Well, I have an idea that I do have an idea what the Vedas number be.
That's like what the what?
The Vedas value
What's that?
is I have a feeling it's 2.25.
3.25?
2.25. So you know what? You know why? Because like you know like these two pairs right of like factors, they're out of C, right? Think about it. 1 over a squared plus 1 plus 1 over b squared plus 1.
Yeah.
Obviously, the maximum value, if we think about it, should in theory be 2.25. But if we can prove there's a value of that,
Oh, but you have to
Yeah.
prove that it's possible.
Yeah. yeah, we can try that.
What's that minimum? It's like 27 on 16. Yeah, something like that. That's it. Less than 2. Yeah. Less than 2.
The random could be negative, you know. Actually, can it?
No, it's all squares.
Oh crap! Sure. Let me think about it.
Do you want to end the stream? Or
Nah,
whatever.
should be for A. Watching A should be for B.
Yeah, I guess like if you make the question 1 difficult, you probably should say the order is not reflective of difficulty, just so people don't like give up. Like, question 1, I can't even do question 1 of day 1. But where are your teammates? They're meant to be there to encourage you.
Okay, this
But then it's like they all can't do it either.
see.
Practice them.
This cube is hard. But it's not just cube. This cube is hard. But it's not just cube. Pieces.
Oh, I was gonna bring one of those. I had like a triangle one. Like a triangle pyramid one.
Pyramid,
Kind of like a 2x2 one.
for Marcus.
I don't know where it was from. It was like a birthday present.
You should get your Marcus buy a Happy Meal and like they give you like these toys. That's pretty cool.
Someone
I've
gave you a Happy Meal toy for a birthday.
never seen this before, to be honest. If there's any cubing experts out there, please tell me that this thing exists online or competitive Rubik's cubing.
No, competitive Rubik's cubing is so insane.
I know one guy from Junior in AMOC who's like
Yeah,
really
yeah.
insane.
That guy's big. Yeah, that guy's big. 12 seconds.
No, I think it's like 6. Like that white kid.
Quite good. Oh, no, those are the alien things.
There's like a white kid who got like 6 seconds, 6.2. And like I was like, he's like, it's like I tell him he's good, but he's like, nah, bro, I'm just lucky. Don't believe him. How can you solve one in 6.2 seconds? That's actually insane. You have to memorize the like.
Look at it, and then you find you thinking what algorithm you want to do, and then you.
Yeah.
I'm pretty sure that's like one really advanced
You have to
algorithm.
get past all the thoughts of like, why am I here? Why am I here? and then get to the solving. Yeah.
In comparative cubing, there's like one algorithm which has 493 cases, but apparently it's like really efficient and stuff.
Oh, that's cool.
Like, how do you even case batch them in cases in the first place?
A computer.
493 cases.
Try it. I mean, you will tend to play.
Pretty sure the standard algorithm was made before computers, like trying the Rubik's cube. And then there's a standard 56 cases.
Yeah. There's
Only 56
apparently there's a
cases.
comp where you like try to do as little moves as possible to solve it. So then when you like look at it from like they give you the
Pretty sure this
they
that.
give you the scramble, and then you can look at it for like every hour, some time, and then you're trying to figure out the so every cube can be solved in 20 minutes, but
Yeah.
Yeah.
God's number.
there's
You see,
not
that's interesting, but I guess it won't actually viewers because they won't understand what's going on. It's like, well, this guy can do it in 6 seconds. Why are you taking like 18 seconds?
18 hours.
Yeah.
It's like chess.
Yeah.
You take forever to make a move.
Yeah.
It's like chess.
Yeah.
You take forever to make a move.
Have you seen that maths counts challenge? Like, it's like a talk show, but they ask you maths questions and people have to buzz in and answer.
That seems like an interesting concept.
So it's pretty funny. Like the people are clearly very fast. Like it's like if the cam like the thing I watched it on, like, they didn't have the questions on the screen, so it sounded really funny. Like as soon as the guy like he didn't finish the first like 5 words. You don't know what the question is. There's already 2 buzzers, and then they say like 56, and you're like, no, that's so right. And then like it's finished. And I was like, what is the point of this? And sometimes the question gets on board, so you have to pause it to read what the question actually is. Yeah. It actually takes like either they've seen the question before or like it takes, but they can read it ahead of the speaker announcing it.
Yeah. Oh, yeah. So that's
Future's like one for kids in America. Football is cool. Okay. Don't have enough pieces to make a swastika.
That's a shame.
Very shame.
Yeah, sure.
Shit, I forgot to do my phone.
This one
Yep, messed up enough. See. Okay, that's actually something. So that's good.
I didn't buy the BB skin
Oh,
because I didn't have enough chips. So. It looked pretty cool though.
yeah. Why are they like right next to each other?
So the coat and the Frank, I never touched them
Oh, yeah.
since the reset,
Oh,
and the crows just went up and down.
Can't believe it's stupid.
Like, there's an insane number of times where there's just a crow tied out, and they just push me,
yeah, I see.
One who
and that's
Uh,
like,
Oh, yeah.
This thing is really bad turning.
Ow.
Do you have impairments?
Oh,
Do you have
yeah, it's right there.
impairments?
no right, yeah.
I hit him.
Really? What do you mean not right here?
It's like in my parents' house.
Ah, okay. Oh,
I wonder what I'll live in the future.
hang on.
Me and my parents are far away from my parents.
Well, I think there's a high chance you guys will go overseas,
Yeah, true though.
which will inevitably be possible.
When I grow up, I plan to move to. Okay,
I
no,
was
it
thinking
kind
you
of
guys might like want to consider like
pleasant.
maybe even doing undergrad overseas,
what's on the crow?
bachelor's degree,
In America,
like uni.
dude.
Like you have to go to America at some point. Like, I feel like.
I've already been to America once, but it's
Wait,
not for uni.
oh, wait, like, is it juice? There's a juice.
Oh,
Ah.
that's a lot of damage.
Why does the juice last so long? Wait, what? Where do you get the juice?
No, I think they're chasing pictures.
Oh, okay.
Oh, that's okay.
Wait, do you auto aim or do you not aim?
You probably aim for it.
Yeah.
Honestly.
Both sides?
You shot it, yeah.
Yeah, it's so simple, but it's like if they're running in line with you, you auto aim,
Yeah.
and if they're running perpendicular to you, you have to.
If you're feeling
you
lucky,
have to like
auto aim.
you have like if they're slow and you're like strafing, you can auto aim. I think.
Yeah, because
But-
the yeah.
But like you have to aim a little bit.
It depends on what you're playing.
Yeah.
So
I
you should,
reckon, yeah, it's really cool. Like if they're strafing this way, you just go to the bit where they lined up, and then you just spam.
yeah.
Yeah, I want you to mess it up because I'm kind of bored right now. Yeah.
Oh, he's gonna get poisoned. Wait.
Oh, you can't move it like that. What a shame.
Where? Oh no.
You're playing the same thing.
What? Okay.
It does like 0 damage, but also
No.
poisons.
Oh, yeah, okay. That worked. Okay.
I
killed
think
someone. Oh my god.
Finally, able to do something that's not
Wait.
cool.
He's gonna chase you.
Okay.
That's okay. What?
Why?
He didn't mess it up enough. But okay.
That's great.
Oh, I wasn't. Let me
This is like reality TV.
What map is this?
Oh, what?
They point to
Dude.
No, don't know what that is.
yeah.
Looks like a spike head. Hey, look at Shelly. She doesn't want to get poisoned. Ah, fuck. Oh, oh, wait, your team? Sure. Yeah, I feel like you're gonna kill him. Sometimes.
That's why you don't walk.
Exactly. No, fine. I'm just gonna hit you. No. Why?
Stack this
Why,
up.
bro?
And then that's your name. Stack is super.
Bleh. Oh, I missed.
Well,
Uh,
how do you
dead.
think?
Kind of dead. That's a mistake.
So there's been 2 views so far, and then no dislike,
It's
no
been-
likes.
It's Kahi for something.
Yeah, because the stream ended before there was one like.
1 like, wonder why.
Edwin.
Nice.
Now sounds
You
like
know, Dynamite. Hard competition.
really.
You know what?
But like,
Interesting idea.
I just
When I grow up, I'm gonna make a YouTube channel. I'm gonna live stream me
Yeah,
eating food.
I see.
Because apparently people are weird and they're
Crow
interested in this kind of stuff.
I think it's- all
and
my
Leon.
videos have like 5
Yeah,
views.
Leon does.
Okay.
And all sports on the sports category.
And then
I'd rather
the one
buy
video
Leon.
that has like lots of views. It's like the
Yeah,
lamest one ever. It's
Yeah.
like
I feel like
Oh,
Leon's
like-
better at winning.
It's
Like Crow's better at like.
the stream of
Fuck you.
the poker
Why?
machine.
That's how you
Like,
play this game.
Free
Now you're
app
just
game.
chasing back.
Oh, and it's just hitting the machine for 5 minutes.
Please don't kill me, Dan. Like I'm nice.
And like for some reason that
Yeah.
was, like,
You can't run away.
tens of thousands.
Oh, you can kill it.
Wait, what? Let me see.
Ah, fuck.
Dude.
But it's like the most boring video ever.
Yeah, now you
So
win.
recorded.
How many
Yeah.
times?
Wait.
He's gonna die.
Yeah, so there was like this game.
No,
that
he
we were
doesn't 'cause he
playing
got the
with
gems.
before,
Yeah.
And it was a cooking fever where you just like you deliver food to people that come and line up.
Cooking fever. Oh shit.
And like, there was, like in most free games, like to get like the currency, you have to pay something or it
Yes,
comes really
pizza.
slow. So there's like coins and gems. And there's one way to get the gems in the game, and it's basically just to go to the casino and gamble, which is weird, right? For a family game. So I just made
Yeah.
a video of me hitting the casino until it jackpotted. That's the one that has the most views.
Wait, but like, doesn't it cost like a lot to like go to a casino in the game? Or does it?
Oh no, you just click on it. It costs you time. It's like, it's really you pay for this game with your life. That's really
That's
what
like
it
every
is.
game.
It's like don't worry about this $1.
do you beat
Your
all
right?
life. is
This
all-
reminds me of
Oh, I don't beat like 2 people
Oh.
trying to kill. Me.
Oh,
Epic
Epic
Heroes.
Heroes.
Little does he know
yes,
there's a
Epic
crow.
Heroes. You just spam the
Ah,
head
he's
out.
electrified.
No, you don't. What you just
I
don't
still
stop.
have it.
yeah,
open
fuck.
it and, like, sell it.
Yeah, that would have wondered.
You, I mean, it's like it's basically
Go
idle.
die.
You just like
Yes, die.
wait
It
for
is
it to do
idle.
stuff,
No, pussy.
and you gain treasure. And it's basically pointless. I'm like,
Oh, yeah.
it's kind of weird because like sometimes like you can reset yourself, right? Like some other games like added
it's,
capitalist.
Everyone said he's not even watching us right now.
Yeah.
Then
Ooh,
I'll have that one
yeah.
eating, and you should.
And then someone's gonna
Right,
chase
so
you.
we got free time to 2 o'clock. You want to start at 2 o'clock? We can start earlier if you're ready, but
At one time,
it's
1:20
1:20 now.
Wait, show that.
23, yeah.
Oh fuck.
I'm ready to go whenever you are.
You're faster
And
than
start what? Start the next.
Wait, what was that?
Okay.
Hey, come back.
Why did it look black in this live stream? Is it the lighting or am I just black?
What?
Do you guys need to take a break till 2? Or do you want to start the next thing right away?
What's the next thing?
It's like basically we talking about what we're gonna do today, and then executing on it.
Oh, what are we gonna do?
So we're gonna do that.
Oh, so I'm gonna go through the 2 questions. That I'm assuming no one got 2 and 3 in the WeChat questions.
Don't know what that is. Spend too much time on other stuff, not on WeChat.
Just plans, and then go through those 2, and then
Oh,
Oh, no.
inversion, and then a little bit of Pell equation.
How is it? Wait, you mean inversion is like the geometric inversion?
yeah, the one.
How's that useful?
No, it's
It's not useful.
I mean, it's a weird concept. You just invent a concept and
It's
how
a weird
it becomes useful.
Oh, so the part of it, there's actually one app. Like part of it is an application right after.
Really? For inversion?
Yeah.
Weird.
Oh, actually, have you guys? So you've done like, have you done like in circles and X circles? Like, do you know that like the 9-point circle is tangent to the in circle
That's epic.
and all the X circles?
I wonder why. Wait, so the midpoint of each side of the triangle
I got
lies in one circle.
Yeah.
And
So
then, like,
that's gonna be one of the things we do.
today.
Is that inversion? Yeah. So
wait, tangent to the in circle.
I know what the circle is.
Well,
What do you
how's
even
the
do with
tangent
mesh?
to in-circle?
Just that one
line
point.
circle. Or
What do you mean?
circle into a line.
Really?
Yeah.
Oh, you know a little bit about inversion? I'll write some things up to remind people.
Isn't it like geometric mean or something?
He's camping in the bush and juice.
Seems that.
Oops, it's 500.
It's
now.
500.
Okay, it's not good.
Well, at the live stream.
Commercially.
But aren't you curious where the problems came from? Those 4 problems. Could you guess where they came from?
ABS.
Huh?
Or the problem solving.
That was one of the problems.
Oh,
Oh, I want to see the problem.
that. Oh no.
Good one.
Something.
So can you guess which one it was?
Yeah, it was the geo. What? No, I'm pretty sure that was in the thumbnail.
What's in
Oh, what?
You sent the picture.
Nice.
No,
Nice.
wait, no.
Nice.
Oh no, yeah. They're all from
Yeah,
problem
six
solving.
hundred.
I thought you said problem solving tactics.
Oh, okay.
Yeah, I was confused.
I don't want to do There's another mic. What we do with mics is we oh no, this guy's got his fast man. Wait, what's he doing?
It's got terrorist.
Yeah.
It's okay.
It's
The
oh
mountain
my
is
god.
They really care. Yeah, okay, wait, hang on. Did no one take the juice over there? I'll take the juice. Yeah, bush check this first. I kill everyone. Oh
Is
my
juice
god.
the green energy?
It's like a red thing that makes you
It's the
think
purple
of
thing that makes you. Like,
Oh, the milkshake.
Yeah,
Right.
We call it the milkshake. The Australian thing to say.
yeah, okay, now, where is it on? Okay. I would have killed Tom.
So
Oh,
the
look.
milkshake, it gives you a little bit more damage, but it doesn't.
No, it gives you a lot more
Gives
damage.
a lot more damage.
A lot more damage.
Yeah.
No health increase.
But he's bad at the
No,
game.
but it gives you.
He's actually
faster.
bad at the
So you're
game.
faster.
Yeah. But you're like your hitbox is
Your big
faster.
boom.
Oh, is it?
Yeah.
Okay, now we find the last guy and then we chuck the big boom on him. And then we win the game. Alright,
One shot.
Okay.
OTK.
We
I
should
know
live
he's
stream.
God.
Alright, that should this work.
Why
I
did
figured
this-
out how to record my screen on the.
Oh yeah, I know how to. So, you get like the app, and then you can stream it.
You can even just do it on the iPhone, the default.
Oh, but that's
Just
when you
watch
record.
that
I don't
again.
think you stream it.
Oh, the streaming, yeah.
Yeah.
Ah.
Hey. Family friendly content.
Oh, who is this?
I can't
His
watch, I
name?
can't watch the replay because we're not
It's not one.
No, I'm trying to come on the replay.
He's
That's
not
the best game done.
And what does he want to
He's
do with us?
400. Oh,
I remember there was this
That's
guy, I was friends with this guy called Robert, and like, we were just like playing, we were on the bus, and like he dropped his bottle or something, and like we just rolled to the front. Like it was kind of, it's like one of those situations where it's like, oh, if we didn't know him, we wouldn't say anything and just avoid embarrassment.
yeah.
But then, like, because we knew him, it was like, his name is Robert Tang. And then we started saying everything about him really loud. Can't leave on yourself. Yeah, we were young.
Alright, let's still take what else. This is bad.
Oh, those are the things.
But someone's gonna do it.
Alright, so let's say 2 o'clock then, okay?
Sure.
Okay. One of it.
Yeah, sure. Let's go.
There's some of them.
Sounds very good.
Oh,
Someone
God.
has juice.
That's fine. We don't make trouble. Yeah, don't die. Interesting. What? Alright, he has his big shot though. He's dead. He's dead. Thanks. No, that killed me. Zoning. No, I'm good. I wonder who's gonna win this one, dude. Wait, what?
Suicide.
No, but he's winning.
Oh.
Wait, how did he die? He's the pop. Nearly at 400. So yeah, it was brush forward.
Yeah.
Just has weirdly.
So what I cannot kill is I cannot kill 8 bits. Oh, I can kill I can't. Leon's annoying. I can't kill Crow. There's Leon. He's gonna die now. Okay, now we're going on Mr. Tree.
That's
Oh, no, oh god, I forgot about that. Oh, wait.
This thing counts.
Yeah, this thing jumps.
It's pretty cool.
Oh, actually, do you play Brawl Stars as well, Gordon?
No.
What's that? It's free right here.
I don't play any 3 but it's not it.
Iron stick.
Oh, tick is so annoying. It's like
But like,
the most annoying thing in the game is waiting for
okay.
one of those little things to disappear before walking in that direction, right?
Then you miss jump. They
And if
do
you go
damage
too
on
early, you
impact.
just like if you hit it anyhow, it just explodes on you, right?
Yeah.
So I don't get it.
killed
It's like
someone
by the time it's gone, they've reloaded 3 already.
yeah.
So you're just like, what the hell am I doing here?
That's it deals damage on impact as well.
Does it?
Yeah, it does. It's like when they pop, right? When they arrive, it deals damage, and then when they pop, they do more damage.
Wait, they don't deal damage on them.
They do. If they hit.
Wait.
Isn't it just the same as stepping on it?
Oh, is it?
Yep, wait. I don't know where he is. That's okay. That guy's got a lot now. I should not be interested.
Actually, what I'm kind of interested in doing is like doing like one of
Wait.
those boss fight things and trying to
Oh, yeah.
last for ages.
Oh,
Oh, yeah.
I want to try crush and poison.
Yeah, Jordan. So I started playing Brawl Stars because basically it's like this game that our family got into somehow.
Okay.
My 6-year-old son plays it,
Okay.
and like he's gotten us all playing it somehow.
I see.
No, go away.
This game looks funny.
Oh, he's dead.
Like
Wait,
this
he's
reminds
dead,
me
he's
of
dead.
this game where you actually have to add the numbers up to shoot them down.
Oh,
It's
Oh.
just pure spam. Oh, it's
I
subtracting.
I know this
It's subtracting.
You can't let
It's counting backwards.
Oh yeah.
Blue 3 did it.
I mean, back in the day, this would lag like a.
Wait, is this even good on me?
The juice.
Yeah, okay, let's go. Okay, well.
Gets so fun. You can tell
Yep,
the
apparently it's pretty good.
You can tell the brightness.
Hang on. Okay, they fight that.
Hey, do you have anything to hand in?
I'm thinking
No,
about
no, no.
T1. I have nothing to hand in as I gave up a question twice.
He's
I
fast.
was like, wait,
He's
I
fast.
don't think I'm going to. Not one of like a bunch of equal ones, but it's not really like
Yeah. Oh, 10.
Oh my god. Nice. Not good.
I got him. No one will work for me. Professional tip. Go on.
Okay. Yeah, remember how my computer just didn't charge?
Oh yeah.
It's experienced that again.
Oh.
And it's like, out of all the combinations of outlets, this was the one that ended up charging it. Like, if I put the power board on and put it in, it doesn't charge it. If I put it directly in there, it doesn't work.
Like if you do
But
that.
if I do this, huh? They had a poker playing routine.
Yes.
If you want to do that, you have 20 minutes.
Wait, does he? You know how they work it? Yeah. Yeah, exactly.
It's not even 1 day now in this state. I know. Seems not much. He has been exposed to every time possible. This is very much.
So what's Sing's plan is? It's like he gets in the solutions, it's come back at the 1 week early to cram. I guess he could still make intermediate if he like.
But what senior?
I mean, it's possible for year 11s to make intermediate, not junior. I don't think. It's possible for year 12s to make intermediate.
How are you feeling online?
Oh, wait, what did I say in the group chat? I said it very clearly before. Oh, okay, it's not possible for you to talk to
It's expert. So we get a bunch of money. So we get a bunch of money.
哎，你这个没开吧？
也有人，
人就能看我。
没关系，这是 reality TV。
稍微多是你考错。
你吃播是吧？吃直播现场。
对，主要是吃的。
有人在吗
2个人好像。
So everyone's dealt 2 cards face down, and then there's going to be 5 cards on the table.
我也知道他会烦死了，
Or like 3 from them 1, them 1.
别扭。
And then you make bets depending on how good you think your hand is. Your hand is like 5 cards on the thing. And then after hand like
Yeah, like if you want to play pure honest poker, you're
It's
basically
all about
evaluating
numbers.
the price of your hand, and then you're paying that price every time it comes up.
like these are the hand No, I also.
You bet.
But some like because it's not honest poker, there's some hands that are really valuable even though like they're crap. Because they give you certainty.
But what's something?
Well,
Okay, a lot of flushes incredible that day. Four times.
So even in James Bond, it's like a straight flush. Even they don't dare.
Isn't it like the blue gets straight punch and the string one gets straight punch?
The villain always gets like full house or 4 of a kind or something second rate. And then James Bond always slows rolls him. It's just like no question. He always waits and makes him think he's won and then turns the card. It's like horrible etiquette. But he's James Bond. The villain won't survive anyway, so it's like why you gotta be nice to him? Yeah?
Yeah, okay. Wow. Okay, who's dealing?
Thank you.
Are we moving?
Yeah.
No? We're not moving?
I'm not bothered to move. I'm shuffling these guys.
So basically, the two people to the left of the room pay.
So you need
$10 and $10.
It was for $10.
You can fold, check or raise with that. So folding is just giving up. Check is not pressing anything.
And maybe just self-examine.
It's big money. Yeah.
That's like a
So
lot
you
of
could have 10 and
When you put up 10 and 20, so you got it's single.
basically every your life.
It's encouraged not betting.
Does that have to be
Not
like
folding
folding?
immediately.
I love it. Well, what's like, oh yeah, we don't have a cards here. Stop counting Chinese.
I make 2 cards.
You're meant to.
Yeah, so
I can deal with you guys.
so you can either like go
We bet based on our 2 cards. Then we're going to
Yeah, but
And
you
your,
need to
it's like the things that are important in this game is like your position is important. It's acting master. Yeah. Your cards is important. They are used in the game. And like people's sort of perception of your cards and other people's cards are important.
Yeah, it's you put in another 10 to match it, or you feel like the 10,
Oh, right.
your cards are bad.
You know what? Not gonna lie, my cards are okay, so I'm not gonna fold. So just in case.
Alright, it's all good? 3 bucks.
I shit.
oh wait.
I screw up a fold.
Hey, he goes first.
My fold
This
anyways.
is like what you-
Fold anyways.
So those 3 and these 2 make my point.
Yeah,
but
and
it's
then,
gotta be
and
2
then
more
you
cards.
can get 2 more cards,
Yeah,
and
2
then
more
you
cards.
can use the best one.
Okay.
So it's like, what do you think will be best?
Well, I
So
believe
they follow
version is
it.
in China, the home brand.
How much?
Version.
How much
Kind
cards?
of like everyone has
How much do you want?
You guys,
As much as
I
I-
protest.
as much as
If
I
you
want.
know if you know you're gonna win, raise 2,000. Yeah, 2,000.
Yeah, because
Do
then
it, do it. You would.
How much time do we have?
As much as you want, I guess.
No.
In this game, the winning
It's
strategy
16
is to simply make it unsustainable. You make the people you think you have good hands.
I lose all my money in 16 minutes. I don't think so.
You
I'm
don't
a bet high.
So you
I
just
suck
put
at
it, so you
folding.
put it outside the
This is
system.
like side raise. Okay.
I suck at folding. Lol.
Okay.
That's my hand shit.
I know.
Jesus Christ.
The white.
You know you don't have to pay, right? You could have just said like
Yeah,
check. You could have just said check.
Isn't Jackie or simple time?
check is you don't.
Track is you match whatever is there already. So not just
Which one's
okay.
Next card.
Well, thank God I folded.
Now it's flush as possible. There's 3 spades.
Oh yeah, baby.
Oh.
Yeah. Money's
Can I check? Yeah. Okay, I'll check.
small.
I don't know.
There's a king.
he's a newbie. So whenever he has a kids,
just act erratic about people.
I'm pretty sure one of the previous winning strategies is that you bet like a shit ton of money and then you trick people into folding because they think you have a good hand, right? Pretty sure like this, like Michael wants to bet like $500.
Next time,
Yeah.
do I have to do something else?
Or just match this, or you can call them higher.
Oh,
Like you can call even higher.
you can raise.
A pro tip, just raise it to 3,000. Yeah, no one's gonna contest with you.
Oh, right. But when they do, what's that 3,000?
Honestly, we found actually good, which I think it might be good. Okay, 300. That's actually quite a lot.
10.
Whoa!
300.
Oh, yeah, it has to be double. It has to be double.
Yeah, raise at least
Double. Okay, I don't think I'll double. That was like the cheapest show of strength ever. You made him scared of him without even raising him.
Last one.
3, 2, 1. You.
Oh,
Oh,
nice.
shit.
So there's this much action with no one having the nuts.
Oh shit.
Full time.
That's insane. Wait, the streams are still going on. It's just almost like
All right.
Do you have one?
if you have a space, you're pretty much set. If you have a space or any of these 5 cards, you're pretty much set. So good luck. Raise by 3,000 people.
Wait, can I see the fingers?
Oh yeah.
What's all this about spades?
So it's
If
pretty
you
high.
have 5 spades, is that good or something?
Yeah, it's pretty good.
So basically, if you have the king of spades, you have a good hand. The best possible hand. Oh, actually, no. You have 2 and 4 of spades. That's the best. I'm gonna.
Oh, yeah, because you check.
I'm gonna slash. Yeah. Back how much? Wait.
Check.
Check. On check.
Raise.
You better
You can't all have those best hands.
High means attempt to use intimidation.
Oh no. You just.
What? At least that's something to do. I don't know, I'm waiting for.
I can't believe this cannot be correct for everyone. Check this. Oh my god.
That's so good.
Well, see, high means using intimidation, but there could also be a chance that he might not be bluffing, and he might actually have like an amazing hand.
Oh, super.
Say nice and lefty.
Yes.
Yeah, 6 of spades.
Oh,
You had some good money and also a damn hand.
you did have a king then.
Also had a hand.
Yes, he had a king. He had a king. But like for this.
Thank you.
See?
I like this. So when you first start playing poker, it just feels like it's kind of stupid that everyone's bluffing and you just win. Eventually, bluffing does become actually like you'll start worrying, like you'll lose enough hands that you'll be like, oh, maybe I don't have the best hand all the time.
Perfect swastika. Give me 10 to 100. Let's see.
Like what?
100. I want to make a proper swastika.
I don't even think he has 10 out of 3. Yeah.
Can I make fun of this? Yeah, so the game I was playing was kind of funny. Like it's almost designed for people who don't trust anyone else. There was just like this game. You get your 2 cards, okay? But you pick it up yourself. No one deals. You just grab your own cards, right? And then you have like one of them face up, and you have 2 of them face down, okay? And you every time you deal is you grab that card, right? And instead of having like 3 cards in common, you have like 1 card that's exposed every time. So like, and then finally you have 3 exposed cards and 2 cards. That's the final. Like you don't share this with anyone.
Oh, wait, but that's good. No, it's still the same.
Actually,
It's just really hard to catch up. Like if you're behind,
So
you
anyone
can't really catch up.
Anyone trade
But-
100.
I managed to lose somehow with 3 2s. I started with 3 2s. I had a 2 showing and 2 2s here.
Guys, anyone want to trade 500?
Thanks.
What? But how many 500s left? Why would you do that?
Because I know that.
It's not the same value. Except having more 500s give you more flexing power.
You also know those people.
Yeah. You're small.
Need small mind.
Yes.
What's my phone? Where's my hand? Okay, so use this next round. Oh, pocket ace, pocket ace, pocket ace, pocket ace, pocket ace, pocket ace, pocket ace. So I did, yeah, sure. I'll start at 10 because I don't want to do anything stupid for now.
Who attempted the possible?
Sure, guess I have to, yeah. You better not raise. That's what you got. 3, 2, 1, go. Okay, not bad, not bad. Me check. It's not. Oh shit. Holy shit.
Yes, right.
I can't avoid this one.
Oh,
300.
double, right? Yeah, okay.
Whatever.
Whatever.
Yeah.
I keep my swastika. I'm willing not to. I'm not willing to sacrifice this piece of art. Although this is only $900, it is worth $5,000 to me just because it's a piece of art.
You card?
Yeah. Need to. On second hand, my mind is also a skill set, but check.
The aim is small, right?
Wait, so is it my turn? Yeah. Then she generates.
So many.
He's going against his own free will.
What if I bet higher than someone can match?
Oh, then they just go, oh, and then this.
What are you thinking of now?
What? You do some splitting thing.
You want me to destroy my swastika?
Like you can't like force people. It's not like the Wild West where on their cards and call you bet. But like, yeah, they can always have a chance to win with whatever they have.
My hands actually not as good as I thought. So I might as well just fold. After benefiting on $10.
Well,
And they meant that, so
I
I can make this my last statement.
Yes.
Unsustainable.
So what now? What's fun?
Oh shit, should I fold them?
You're changing that last guy.
Shit, I should have folded. I had a king. Shit, I'm folding.
Go first.
Well, now you're first.
Oh,
I found it.
What's gonna happen now?
Oh, no.
So what happens if I do like bet higher than?
We set up ways to hold that.
I don't know. No, we don't. Well, maybe. No, we don't.
This
What's this folding thing? Oh, splitting thing.
Oh, so oh, he goes all in now. Or you fold.
I'm pretty sure I go.
Oh, wow.
That's one.
I have.
You better do it.
I just really worked last year.
No, now he's one already.
Spending.
Anyway, that's
That's the latest school stick has.
hey, let's go. Let's go. That's just $20.
Well, you have enough for that?
Yeah.
Wait, what? Why don't I have enough?
Because you expect it. Well, you better.
Well, I put the same as you, right?
You better send
Hang
You
on.
bet 2,000.
Okay. So, wait, hang on. What's it? 850, 950. Yeah. Okay. Yep. Alright. There we go.
Yeah.
Alright.
Wait, We hope you're not lying. But
Yeah.
So,
Yeah.
showdown.
Oh my god.
I have two pair again.
I'm flush.
I have the punch. I had the punch.
I didn't look as bad as I thought. Yes, let's go.
How do we get two
I'm so
questions in
alive.
one go?
Still alive. Still alive.
Alright.
Wait, normally I also straight, I think.
What's on your big five?
You just close your most level-headed people.
You take my money. We're not three.
Ah, you haven't.
I have three.
Now that two of the most level-headed people in this room are out of the game, I guess I have a chance of winning.
He got another like straight. One.
Oh wow.
He has the jack.
Worth flex. You know, I'll take 5%. I'm actually glad I folded.
I hope I don't run out of batteries.
Actually, what is this Q something for watching?
Hello.
This is a live stream for that.
Let's go.
Holy crap, you for next 3 months, dude. That was motivation today's plan.
What the hell is motivation? The concept of motivation.
Motivation is dead. Growth mindset is also dead.
You know about these things, you just reject them.
Okay.
Please have a seat.
Oh, no, so fine. There's no C because I just broke them.
Okay.
Alright, where's Hygiene? Alright.
I really wish Zing
So there used to be seats. Okay.
until
No.
some random fat kid came in and broke on them. And that fat kid proceeded to take this a stick leg and beat the shit out of another kid.
Oh, so the story has been told for me now. So he basically took this thing and tried to kill someone with it. Yeah. Okay.
That's the only reason we don't have this
This is
chat.
fine.
Dude. I can't be the only factor in like this solution of chairs.
And we vacuumed this carpet 3 times today to get it clean. 3 times. So if it's still dirty, we're gonna have to get a new vacuum clean. Okay, that's the bottom line.
Okay. Oops. Yeah.
Wait, so Steve's not here, why?
Oh my God! His motivation comes at the very last minute.
Where's Zing? Where
Edwin's sick.
they keep me entertained. Because I eat it.
Edwin's in.
So
Alright.
Because apparently I eat it because I messaging me.
Okay. Alright, let's do it. Alright, guys. So we just did the AM move, right? Yeah. And yeah, there's interesting things ahead. So let's not forget our goals. Yeah, the goals it's still to learn maths. Okay, it's not to do exams. Yes, learn maths, enjoy maths, and do maths. Yeah.
Yes.
Okay. So, and some motivation for this, mostly, hopefully, is intrinsic by now. Yeah. Does that make sense? You just enjoy doing it. You like doing it, and you want to better yourself and that kind of stuff. Yeah.
Yeah.
And if that wasn't enough, we have like this source of over motivation. Well, the fact that the AMO just happened makes you feel like, oh, there's no motivation, right? But then like selection school is in April.
Yeah.
So APMO is in March, yeah? Okay. Yeah, but see, like you might, yeah. See, like in your calendar, like in your goal, sort of step by step calendar thing, you may actually be doing APMO, right? Maybe not this year, but in one of the years. Yeah. Okay, so and that's right away. Okay, and then selection school gives you the TST, the team selection test. Well, I don't know how they're doing it this year, but like the one I observed was like in 2017, they had three days back to back tests. Yeah, is that what they did last time?
Yeah.
Which is kind of different from other countries. Because I'm looking at because you know the AOPS has all the they're like some of them have like 3 exams 2 days each. So like they go for ages. So it's almost like you have enough questions to test like every area. You can try to really pick out people's weaknesses and stuff. And then in Australia, it's kind of weird. You have 3 over 3 days. It's not that many, but it's more than all the other tests up to that point, right? And there's like I don't know if the schedule's changed, but when I saw it, there were these warm-up practice exams on days before the actual test, and like courses. So maybe they've changed that because I can't imagine anyone really learning anything with that kind of pressure ahead. And it'd be kind of weird. Like, would you hold back in the practice exam because you don't want to be tired for the real exam? Yeah, so it's kind of interesting. Yeah, and so I guess, yeah, and sort of looking ahead, that's kind of where I got this week's problem. Yeah. So apart from having him from out of problem solving, so it was so the geometry, so the functional equation question was Moldova, 2015. It was the first exam, on the first question of the first exam. Okay. And the geometry one was China.
China.
2019 is the one question. Yeah. Okay.
Chinese teams.
Yeah. Yeah. I mean, a lot of these things, you know, like it's not just like the smart people always do better than the people who are less smart. Yeah. There's lots of randomness and variance involved. Like, for example, there's one guy from China. He didn't get into the team selection test. So there was 30 people, and he missed out by like 2 ranks or something. Yeah. But then he proceeded to get back-to-back perfect scores in the IMO. And yeah, it's stuff like this happens. Yeah, and apparently he did it in hard years. It wasn't like easy year.
Right. He got the team.
He didn't even get up to the team selection test.
30 people all.
And then he got it.
Yeah.
Right, so how do you do that?
So either he did it another year, or they kind of let him in anyway. I don't know what happened. But that's kind of, you know, the process you're dealing with. It's not like so hopefully that'll make you feel better if stuff doesn't go your way. But like, yeah, and I think you should know about selection school next week. Actually, not really. Yeah. What do you mean? Because last year we knew by February 20th. Yeah. So. Yeah. But I mean, think about it though. Like, if you're really going to prepare for all this stuff, you will know as soon as you can as well, right? It's a big difference being a senior and doing a TST than kind of just still learning stuff. So and maybe they make you do APMO as well. You know, that's kind of like, I mean, that's something you need to prepare for. Okay.
What about just like more prestigious APMO or IMO?
Prestigious, yeah, it's IMO.
But the APMO, like, it's like, you know, like this is like the
But not even.
selection like narrower, right? It's like there's only like 7 countries which don't participate.
Yeah, but
Like
each-
these countries are small, like China, Korea, and stuff.
Well, China didn't participate last year. I mean, like, it was 10. It's 10 people per country as well. Like IMO is only 6.
Yeah, true.
Yeah.
Asia Pacific for Asians.
Okay, and then some of the goals we have for today. Oh yeah, so the other problems. One of them was like PST question 6, problem solving tactics. The question 6 in the functional equation section. So you solved that, so I didn't think to go over it. Maybe we will get the solution off you. And then the first one was APMO question 1. So PST question 6. Yeah, and the sets one was APMO 2004 question 1. Okay.
I don't think that was.
Yeah, so APMO, the first questions are usually harder than a lot of first questions. So then, I mean, so for that question, what that is, that was like a chase. So if you can chase for that long, that's a very good sign. I would almost think of it as a prerequisite now that we up to this point. Yeah. So chase is kind of you follow your nose until you get somewhere, and that's like a kind of extended version of that. Yeah. Okay, so those 2 questions I'm not going to go over. And another thing that's interesting about 2004 is like they had no answers for 2004 in the previous. Yeah, and they were looking for contributions. And so there's another thing I was going to say. Maybe you should all get accounts for problem solving. Yeah, I mean a lot of the stuff you can just read without being registered, but I think we should maybe contribute a little bit too. Like maybe if we can post the questions for the Australian Olympiad for 2020. Yeah. And that'll be like our contribution, and then we can learn from other people. Okay. And looking at some of these questions, like I'm generally doing them, okay, and solving them. But looking ahead, I feel like I may have to break my rule of not looking at solutions. It's just not going to be enough time. So if I need to find a question that's particularly good for this moment, I might have to. I can't just do them. I have to actually just look and see what kind of solutions some of the questions have. Yeah. Okay. Right. So, and then for today, so what I really want to do today is, I want to make inversion something that we've learned, okay, and ready to go, okay. So we can use it to solve problems. We learned it, okay, and then obviously we have like a hit list of looking for actually a problem we can solve by inversion, okay. Pell's equation. I feel like we're trying to get to that stage with Pell's equation, but we probably won't have time to get all the way. Like we won't get to like the complete proof, but we'll have some more insight.
The only question is like x squared minus dy squared.
Yeah, it's like this x squared minus dy squared.
Pretty sure we got something similar like in the AMO, like question 4 day 1. Yeah, something similar, like. Well, it's like similar. Something like it's just like it's really fancy.
Yeah. I mean, kind of like if you know about it, at least, you know, even if you can't solve it, you can at least relate the problem to it, you know, which, as far as I'm concerned, is basically what problem solving is. But it'll feel more comfortable to relate it to something if you know it well. Yeah. So that's for today. Yeah, and I guess complex batch. Complex batch. We'll do that part of it. Didn't the China geometry question look like a complex batch a little bit? Well, that's what inspired me to just put it on straight away. Did you look at the question?
I saw it like.
Yeah, there was just like a ton of stuff, and I was like,
Random points.
wait a minute, it's China, and we just learned complex batch, and it looks kind of like this. I'm determined to complex batch it.
Well, not complex batch. It's like the y-axis is like imaginary number. The x-axis is real numbers. If it's such an abstract concept, why does it work so well?
Because it lets you
I mean, the coordinate plane is obviously abstract.
Yeah, I mean, like the fact that like you
Not
have all
that
these
abstract.
operations that correspond to all the geometry operations is basically a converting geometry to algebra.
But imaginary numbers don't really exist, do they? It's not like the coordinate plane, which actually makes some sense.
They're pretty real.
What numbers that exist?
Well, they kind of do.
Okay, have I missed anything? Do you have any questions about this? This kind of like,
Well, about inversions, how are they used for? What type of questions?
That's what we're going to do today, right?
we have to know what it is first. I think you should just appreciate that it's kind of like nice,
It's like circle circle.
and you'll kind of be happy when you know it might not come up very often at all. You know, maybe the best way to do these tests is just to chord complex back everything. Okay, maybe. But like, but what would you get out of it in the end? You know, you get a reputation. That's what it is. Well, I mean, at some point you have to think about the maths. Okay. All right. So let's do the Moldova one.
Was
this one the functional version?
Yeah.
I did look at these.
So this requires interactions. Okay. This is just not me telling you the answers, because I've often, like, if I told them to you early in the week, I've forgotten it by today. So okay, so the question was f from z positive to z positive, right? So not including 0. And it's f of m, f of n equals n plus f of 2015 m, right? So if you can't be bothered to write 2015, maybe like 5 would do. I don't think the actual 2015 is that important. So what did you guys get the hints?
I did not get the hints. One said the proof.
Did you ever look at this one?
It's injected. Yes. Wait.
Oh yeah, injected. So that's good. Is that clear?
Wait, I didn't do it.
It's
It seems injected, but I can't be sure.
because the n kind of comes out, yeah.
Yeah, but you still have the M, so you don't.
Oh wait, I'm pretty sure this is.
I know where you fix M. Yeah. Wait, it's injected for everything above 20. Well, no, it's a straight up injection.
So you mean like the image of 2015? Well,
yeah.
it just doesn't have anything to work.
F both of n is equal to m plus f of 2015. What?
Why? You said f of a equals f of b. That's something like that.
Right. So f of a equals f of b, right?
Yeah.
And then you have f of m, f of a
Equals f of
equals to a plus f of 2015 m, right? And then this is the same when you put b there.
Oh,
That's the same, right?
okay.
Yeah. So then a equals b.
A equals b, f equals b.
Yeah. So anytime this n kind of is in all the way in there, it comes out. Yeah. It's like injected.
And it's also because you have M outside.
Yeah. It's subjective past, like, because it's always increasing, right? So it's because it's positive. It's subjective past anything, any image, anything in the image of like a multiple of 2015, right? If whatever that is, it's you can get everything past that. Yeah. All right. Okay, so I guess the image of 2015 might be important. Let's C equals 2015. Yeah. All right, what did I say about this question? I said key observations. F is injective. Everything past C is in the range. Factors and multiples of 2015 can't be in the range.
So do we do m equals 1 and n equals 2 of 2015?
Huh?
M equals 1 and n equals 2015.
M equals 1 n equals. Oh, actually, m equals 1 is already something interesting, right? M equals 1 gives you f of n equals
M plus constant.
n plus c, yeah?
M plus constant.
n plus c, yeah?
That's certainly interesting.
Yeah, I mean, so this is like, oh, f of n equals n plus c. So if c is even, maybe f is like n plus c on 2. Yeah. But that doesn't work. You try that? It doesn't work. Did you guys find any solutions that work? Maybe that's the peculiar thing about this problem. Because we usually always find like a trivial one, right? And then that's the only, and then we just basically assume that's the only one.
F of c is equal to c plus 2015.
Yeah.
That's.
So I guess that's one difference between natural maths and competition maths. It's like once you found that one, you can't find any more. You just assume there's no more, right? And then you try to prove it. Whereas it might actually take quite a while to just realize there's no more from the competitions. So can you see F cannot output 2015? Because if F outputs 2015, right, then you put 2015 here, then this cancels with that.
Okay,
Oh
if you can
yeah.
output 2015, you solve f of n equals 2015.
That's interesting.
And then you have f of 2015 equals n plus f of 2015.
Oh
yeah.
So you can't output.
Oh, because you can't.
It was like f of 002 that, but like 0 is on half of the thing.
Yeah.
Wow.
So that's actually kind of crazy if you think about it.
Insane.
Because
then any multiple of it also doesn't work, right? Because if you let f of n be the f of n still be 2015, but you have n be whatever multiple.
did people see this? So I think this observation leads to 2015 can't come out.
Any multiple.
It's
Any
functions
multiple of
increase.
2015 can't come out.
Yeah.
And any factor of 2015 can't come out.
But knowing that this function is strictly increasing, therefore it has to break until 2015.
We don't know what factor.
That's
Yeah,
the
any,
right
so,
Because just don't let n be one. Let n be something.
Wait, what? So, yeah.
F of n equals 2015, yeah?
Well, didn't we just say can't output that?
I guess we're not up to that yet.
Oh,
Okay, I guess right now we have 2015, and we kind of don't know how to move the stuff around yet.
Yeah.
Okay.
Oh, so if f of n is a factor of 2015,
You can increase m, I guess. But then the other one changes a little bit too. So that's the problem.
Yeah.
So that's, I guess that's maybe the motivation for kind of looking into what happens with multiples 2015. Yeah. No. Okay. You can't. And that means C has to be bigger than 2015, right?
Yeah. Wait, why can it?
So that's one of the things.
Oh, why can't it be small?
Because the n will make it go up to 2015.
Okay.
That makes sense?
Yeah. Or like because we know f can't output 2015, right?
Yeah.
So C is smaller than 2015 at the end.
So C is bigger than 2015.
Yeah.
But like, if this function is increasing, right?
Or greater than or equal to.
This function is increasing, right? So C is bigger than 2015.
Yeah.
But like, if this function is increasing, right?
Or or greater than or equal to.
This function is increasing, right? It's greater than 2015. Pretty sure it is.
Well, if it's increasing, I think we're almost done. Aren't we?
If it's increasing, that means it breaks 2015.
Was that one of the hints? C is greater than 2015. Oh, maybe it should have been the first hint.
The first set was 2015. No, it was proof.
Oh,
No, you have 3 hits.
um. Okay, so maybe we want to figure. So now we're trying to figure out what happens to multiples of 2015. Yeah. Can you see that? I can erase this injective stuff now. Basically. So f of MC, we can kind of figure out f of MC in 2 different ways. So like one way of doing it is just putting 2015 for n, right? Yeah. Oh, by the way, I'm also assuming people have subbed in lots of value to that and stuff and all that. Due diligence already. So this should give you 2015 plus f of 2015 n, right? Yep. Okay. What's another way to figure out m of 2c? M of 2c, for example. You just put m as 2. Yeah, so that's the first way, yeah? So f of 2c would be, in this case, yeah. Yeah. Okay. Can you see that? Another way is to do f of c plus c, you know? On the right hand side. Oh, okay. Yeah, so this one you put m is 2, right? This one you put n is 2. N is c. So one of these. Maybe you can try the second one. Second one. Yeah. So you put n is c, right? Yeah. And so it's f of the right hand side, yeah?
Yeah.
So then you get triple f c. Just blocking.
You take the F off here.
Oh yeah, because we got an f on the outside. Yeah. So lots of f's.
But we don't take the theory outside. Where no, but we're equating like f of 2c, like yeah. So you have f of c is equal to 2015 plus f of 2 times 2015. You know that f of c is equal to 2015 plus f.
Oh. Yes, so f of c is equal to. Let me write that somewhere. Triple f. What? So f of c is equal to 2015, right? Plus c.
Let's see,
Yeah.
Therefore, f of c is equal to 2015 plus f of 2015.
Yeah.
Oh, and then you have f of 2015 plus c is equal to 2015 plus 2c. Because f of n is equal to f of c.
Mm-hmm.
So then 2015 plus c plus 2c is equal to 2015 plus f of 2 plus 2015.
So you're saying this is equal to
Yeah, so you-
2015 plus 2c, right?
Yeah.
Because the triple f you can think of as just a double f.
Yeah.
But the n is now f of c.
Oh, okay.
I'm just reminding my own office, and that's it. There's a live stream, so
Yes.
you can share my own.
Maybe they're only watching for you. It's true. No, I don't know. I don't know if it's like I clicked made for children.
No, we unplugged it.
Right, okay, so we have
It was made for children, but it was destroyed by Dave.
so f of 2 times 2015 is equal to f of is equal to 2 times f of 2c.
Oh yeah. So you got that. You can equate these two now, right?
Yeah.
So then f of 2 times 2015 is equal to 2c. Yeah.
Wait, why is it?
Okay, so for this one with the triple f, right?
Yeah.
We're using this thing, the
Yeah.
double f thing, with n equals the middle, the last f.
Yeah.
So then it's f of c plus c, right?
Yeah.
But then,
Actually, yeah.
yeah, so I guess a little bit of this is like, I don't know how people, I really don't have this kind of competition experience to pass on, but like a lot of this is kind of feel like how comfortable you feel with just doing stuff, not even knowing what you're like. Maybe this is the problem. Like most of the time, you have to prove it's the identity, and you kind of feel comfortable. But here it's like, what are we even proving? We're just making observations. Yeah. So is it too far a leap now to say f of MC, f of 2015 M is equal to MC?
You try.
Sub it in.
What? MC.
That was the hint, right?
Yeah.
I mean, like psychologically, right? Like I saw that this was question 1, and I was like, so is this actually not easy, or is it like I'm dumb? Like you're thinking this kind of stuff, right? And it's like, oh wait, no, but my brain's doing something. So usually when that happens, it's like not me being dumb. It's kind of like the question actually does require some extra thought.
But what brain cell is experiencing
Well,
some
like-
activity.
Yeah. I mean, at some point you just have to accept your brain is at some level, right? But you still want it to be at its best, not at its worst, right? Oh, so can you see before you even do that? Like at this point here, we can't output 2 times 2015 now, I think. Oh, actually, maybe it's not. Yeah. Okay, we're not there yet. Sorry.
Why is it F for 2015? Because MC.
Oh, okay. So when m equals 2, right?
Yeah.
That's just this, isn't it?
Mm.
Yeah. So I guess we just need we have this result already, yeah. So we just need like a more than 2 version of this. We need like MCs here, yeah. So to get 3c, for example, you'll just add c plus 2c, yeah? And you know what happens to 2c, yeah? So basically, you just need to make this result work for any multiple of c.
Any number of c.
Yeah, I think it can be helpful.
Yeah.
Yeah. My brain's like, at one point I was experiencing activity. It's thinking about the multiple of 20.
You got this one?
I entirely saw the name that as well.
Let's hope it's not because standard of proof is lower.
Maybe. So then assume that z also means 0.
Assume the answer.
Assume that 0 is part of the name.
If f of n is equal to n plus c,
yeah,
then if we have 2c is equal to 20,
yeah. So you know,
if we take right now we have f of 2 times 2015 is equal to 2c, and then if we take f on both sides, we have the 2 times 2015 plus I tried because when you try and adopt it, we have f of
so f of so let's just do 3, yeah. So it's like c plus 2c, yeah.
Yeah.
And then you get f of triple f again plus 2c, yeah.
And then if you change the f of 2c,
yeah. So then now using this, yeah.
Yeah.
So you got f of 2c is 2015 plus 2c, yeah.
f of 2c.
And then it's outside of it's inside of 2f, so it's that plus another c, yeah.
But it also we have the we have 2015 f of 2 times 2015 is 2c.
Yeah.
And then if we take f of that, we have f of c is equal to 2 times 2015 plus c. F of 2c.
Oh.
Yeah, f of 2c is equal to.
Oh, you were saying.
Yeah.
So you got it another way?
It gives you something different. It gives you 2 times 2015 plus 2c is equal to.
Wait, what did you say? We had f of 2c was equal to?
Oh, you take f of fifth side. F of 45. F of 2c. I think that's something different. When that contradicts what you. Yeah. Like, because if you have this, yeah, you have it, and then f of something. Yeah, you should have it, and then you have f of something. That is show them the f of 2c.
No, this is interesting.
Maybe show them how do you
But can you say what you're saying? F of 2c is equal to 2 times 2015
plus C.
2 times 2015 plus C.
Yeah.
Oh, that's interesting.
If you do it like this, you have the division is f3C.
That might be a shortcut then, if that works.
Yeah. So you
Is this true?
oh, that's the thing. Yes. Okay. Yeah. And then you put it into the yeah. And then you have 2C. Then you have f of f1 and then you put the f of c. Yeah, so f of 2C is equal to 2C plus c. Yeah. So then you take f of this. You have f of triple f of 2C. Yeah. So this. Yeah. Right. Yeah. So you put the f of 2C. Yeah. So this is okay.
So how did you get this? Because if you can get this will finish the proof.
You take f of both sides of
This one. That one here?
yeah. If you take f of that.
Okay, so you take f of both sides here, yeah? So then you get 2 times 2015 plus c, yeah? Equals f of 2c, which is what we had before, yeah? Plus 2c. Oh no, but the 2015 cancels, huh? Right.
Well, now you have that c.
Oh, you already have that?
Well, from that you do it.
Oh, so you didn't show this, you
Well,
just
wait,
direct.
you get that. Well, you get that from the. You have.
Oh, okay, I see what you're saying. Yeah. Oh, so if you didn't know what f of 2c was, it'd be equal to this. But it's actually equal to this, right?
F of 2c is equal to f of 2c equals to 40.
Oh, so it's equal to 2 different things which force c to be equal to 2015.
Wait, where's the other? Yeah.
Oh, didn't we get that before?
Not really. Let's just say. Oh, yeah, f of 2c is equal to yeah. So f of, yeah, f of 2c is equal to 2015 times 2015 plus 2c, and it's also equal to 2 times 2015 plus 2. Okay, that's equal to
Yeah.
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 Oh.
That's pretty good.
So.
Don't forget to close the door. Just don't forget to close the door. For children. This video is meant for children. Check out community line for more details.
Yes, I think this may work, yeah?
Yeah,
There are 2 different ways of getting 2c, right? We can't have c equals 2015, right? Because how can we? We can't output 2015, right? So this c is strictly 0.
there's no solution.
I guess that's kind of like the every problem has something like it's like, oh, they don't expect there to be no solution. So let's make it no solution. But how can you keep that up though?
Yeah.
You're gonna eventually run out of ideas like that.
Because I was trying to inductive using the triple F thing. And then I realized that since you had an F and 2 there were you could run it the other way, and then that way I was able to use to remove the single thing. So I did it the other way first, and then be like, this would work.
Okay. Actually, we weren't far off from the other way. Do you see how what would have happened? So once you got that, okay. So now you have a proof to write up even, right? So it's like C equals 2015. This contradicts F not output in 2015, right? Yeah. So yeah. But if we kind of just so if you had like F of 2015 M equals MC, right?
Yeah.
Then like this is a direct simplification of the equation. Yeah. Because now your equation becomes equals M plus MC.
Yeah.
Yeah?
Yeah.
And I think now you know it can't output any multiple or factor of 2015. Because you know you can play around with M to make this of this form. Yeah. So let's see. Like if you make it like 2 times 2015, right? Then you know, let's see what happens. So if F outputs 2 times 2015, yeah, you get F of 2M times 2015 equals M plus MC, yeah?
Yeah.
And then this becomes 2MC, yeah?
Yeah.
By that.
Yeah.
So then you get MC equals N.
Yeah.
Which is weird, right? Because N and M are both arbitrary.
Yeah. Yeah.
So once you've picked M, N should stop being arbitrary.
According if you go out,
yeah. So no, sorry, not N. N is not arbitrary. M is arbitrary. Yeah?
So N and M are like.
So M. So N is what you need to output 2 times 2015.
Now you have a relationship between Wait, what we F of N
Yeah, so N could be lots of things, but it's injective. It can only be one thing, right? Like if you sub an N that outputs 2 times 215, right?
Yeah.
There should only be one thing that does that.
Yeah.
Yeah. But it gets you a conclusion where it could be any M.
Right.
Because this right hand side doesn't change, right? Yeah. The left hand side, you know how to do it because of this. That tells you what F of any multiple is. Yeah, so this will be 2MC minus MC equals N. Yeah.
So you can change F. You can take M F of N.
Yeah. And if it's a factor, you can make M big, like you can cancel out the denominator. You can cancel out.
Yeah, then that.
Yeah. So that'll make it even negative, I think.
Yeah. So then we can't be multiple.
Yeah. So I mean, so I guess like if you want, like for that observation, it has to be very precise, right? If you weren't precise, you could really make it extreme, like 2015 multiples. And but then the thing is, it can. And if you put it like this, it's obvious that it'll output multiples of 2015, right? You just put M as 2015.
Oh.
Yeah.
Oh, okay.
Yes. As 2015.
Oh.
Yeah.
Oh, okay. Yes. Yeah.
So you know.
Oh yeah, no one put 2015 then.
So then you put in a multiple of 2015. Yeah. Like make it n or something, right?
Yeah.
Equals
can't you just do put in multiple of 2015? Can't you just put like 2015 squared in? It's even 2015 C. That's a multiple of 2015.
Yeah, I guess you could do that. We need the arbitrary m though still.
Okay.
I mean, this is more a question of your personal preference now. This is wrong. Yeah. So, like for example, if f of n, right, is a multiple of 2015, yeah.
Yeah.
Okay. Then you put that in. Put n in, right? Then f of 2015 km is equal to n plus mc, yeah.
Yeah.
And then this we know how to deal with. So that's mkc, yeah, equals n plus mc. And unless k is 1, I mean the k can't even be 1 because the n can't be 0, right?
Yeah.
So you're going to be stuck with n equals mc k minus 1.
Yeah.
And it's injective, so like it can't be more than one value.
Oh yeah. K and
The m, yeah, the m hasn't been specialized yet.
Yeah. And the K, like the K.
Yeah, you don't necessarily get a choice for k, but you can make k c, right? Because you can make capital N 2015 squared, as you say, right?
Yeah.
So then you're saying 2015 squared is equal to a whole bunch of different numbers. But I think if you write it out, you could probably extract what you got from this, because you don't need all the m's to contradict. You only need just one, right?
Like if you find a specific
Because you don't need all the m's to contradict. You only need just one, right?
Like if you find a specific case where it doesn't work, it's a where it doesn't work, but it's supposed to work.
Yeah. There's no solutions. Yeah. I guess yeah, it wasn't clear that there was no solutions until the very end.
Yeah.
That's more of a like a. I feel like that's more of a math thing. It's not necessarily a math comp thing. Right? Because if you have a lot of experience, you might just be like, oh, it's a no solutions thing coming up. Or you might take some shortcuts. I don't know. Because like you're expected to be able to do it in how many hours? 1 hour. Like that knowledge changes things. But the goals, keep the goals in mind. So while we're learning it, we do it this way, and then when we close to the competition, maybe we can find another way. Yeah? With the competition way, I'm not exactly the best person to tell you how to do the competition. Alright, so are we good with that one? Yeah. So when you all go to sleep, that's when the next break is. Yeah. So let me talk about that.
Let's use this brand new technique of swastika patch.
What's a back? Some kind of psychological warfare with other members of the group. Alright, just because I've erased these goals doesn't mean they don't exist.
Current goal. Burn as many joules as possible.
Joules.
Joules as in calories.
This is abuse of pronunciation.
Not Jews as in the inferior people, but more like.
So I have to say something. That's just not true. Apparently, on average, they have higher IQ than other populations.
Yeah, we also have one on probably because they bribed them. I mean, if they can bribe the IQ tester, make my IQ high. I mean, if they could do that, if they could
They grab the IQ tester, make my IQ.
I mean, if they could do that, that's pretty good.
So the IQ tester was in debt to them.
The
To
IQ
repay the debt. The
Yeah.
only way.
The
He
IQ
was
tester.
paid money.
The IQ tester was also good.
Alright. What are we doing again?
Complex actually.
Current goal.
Okay, so
X.
you remember what the question was? So let's see. It was.
Cyclic pendulum. AB was the AB.
Oh yes. Yeah. How could I forget? Okay, so you have a circle, yeah?
Yeah.
And then you have like A, B,
Wait, what about the cyclic pendulum? The A, B, C, D, E, A, B, C, D.
I hope this ends up working. Okay, so it's C and D, yeah, and then E. Yeah. Yes, this is why we ended up complex packing.
Draw a mini diagram. Yeah, and then what you
Okay, so the conditions were that this length is equal there, right?
and
This length equals that. Yeah. The same thing, yeah. The chord length. And then we had this other condition with the midpoints of B and C, right? Yeah, so the one of them is I, one of them is J. But I don't think it actually matters. So then there was a G, right? It's like an O somewhere here. And then there's a triangle here. The F is the orthocenter of AEB, yeah? Yeah, G is the centroid of AIJ.
Is the star thing?
Maybe here.
G is the central of the yeah. Or F is also center of AIJ.
This O is the circumference. Oh, that's right. Okay, so we want to how and then an M, right? It was an M, so it was A. Yeah, so F. Oh yeah, that's right. Okay, so E.
At some point.
Yeah, so like
that point is
so here intersects at H, right?
Yeah.
And then H intersects OG, yeah, with FH. So FH. So this is M, right? M is the intersection of OG and FH. Huh? F is the orthocenter of, so F equals the orthocenter of ABE.
See it.
Okay, easy. You put the AM is probably C.
Oh yeah, and the actual question, yeah. So
Yeah.
AM is meant to be perpendicular to CD, yeah.
Yeah.
Alright, so when I saw this question, like, I don't have any experience. I don't pretend to, but when I saw this question, it looked a lot like the stuff that we would complex back in that worksheet, okay? And I was determined to complex batch this, okay? To my disappointment, okay? So what I expected of complex batching was that I labeled all the variables, make all the choices I need to make at the start. Yeah. And then I would just be able to get to the answer without thinking, okay? This was obviously naive, despite of my experience. It's like, yeah, and I realized I probably shouldn't even thought that. So why would, like, even in like routine calculations, lots of like thinking actually helps routine calculations a lot as well. So what I ended up getting was like this hybrid, which started off as a complex batch and ended up as like a trivial geometry.
Oh,
yeah. So it's kind of. No. Oh, you got it?
No, for the other.
Oh, okay. Yeah, so do you ever, like, you feel like every time you do the chord back, I don't know, like, does it feel like you're always more clever than you should have had to be? Like, it's like, oh, I had to be more clever than I never, I just, it's not like, I started. Okay, do you know about complex numbers? Yeah. Okay, so part of it, so one of the things that we know, I don't know if you know that, like, it's like, one of the lemmas we learned was the author center is the sum, like if we make the circle the unit circle, okay, then at the 3 points on the unit circle, the author center is given by like a plus b plus c. Like, it's like in this case, it's a plus b plus e. Oh. That's like a unit circle. The author center is given by like a plus b plus c. Like, it's like in this case, it's a plus b plus e. Oh. That's like a nice result. Do you know it? You want to prove it? Yeah. Okay. So basically, it's basically because A, B, and E they're all unit vectors, right?
What?
Yeah.
Isn't that like the vectors like smaller?
Yeah. This is trivial. Yeah. So you have like, what do you call it? So basically, if you have A plus B plus C, right? Let's just forget that for now. A plus B plus C, and you want to show that that's the author center, right? And the vector that's like AH, right, is equal to this minus A. Yeah? Like the vector AH is, if we're pretending this is H, yeah? No. Okay, basically we're checking that it's the author. We're not really figuring out why it's the author. So like, how you did. Checking that it's the author. We're not really figuring out why it's the author. So like, how you did too. No, we did. So we're basically what we're trying to do, right, is check that AH is perpendicular to BC. Yeah? And then obviously switch around the ABC. Okay? But what AH would be here is it just be B plus C, right? Yeah? And then we're just showing that B plus C is perpendicular to B minus C, right? Because that's what BC is. Yeah? So if you have like 0, this is B, this is C, right? Yeah, this is also C, yeah? This is also B, yeah? So this is B plus C, yeah? This is, which one's B minus C? Like minus tail. That one, right? Yeah, it doesn't matter which way it goes. So the point is, because C and B are the same length, right? That parallelogram is the longest. Yeah? So the point is, because C and B are the same length, right? That parallelogram is the longest. Yeah? Why are B and unit circles? They're on the unit circle, so they're the same length, right? So because it's a parallelogram normally, now it's a rhombus. I don't think it's, you can't say it's a square. You don't know where they are. But there's basically a 90 degrees. Yeah? So that proves that H is the order center, basically. Yeah? Okay. Yeah. So, well, the funny thing was, okay, so we need to figure out not just the author center. On my erase here. It's not just the author center we need, right? We also need the centroid, yeah? Yeah. But what's kind of funny is if you look at it, it looks like, oh, wait a minute, I can't do that here because the centroid is not for a triangle that's on the circle, right? Remember? Remember how we stated the theorem? It was like 3 points on a circle. The units of the centroid. So basically, we're saying F is equal to A plus B plus E, right? Yeah. Yeah. That's the centroid of A, B, E. Oh, and it's I guess it's standard to use little letters to denote the big letters. The complex number, little a, little b, and so on. Yeah. Okay. So the theorem that we had was that the centroid of AJI, right, was a third a plus I plus j. You remember that?
That's not a unit circle.
Huh?
That's not a unit circle.
Yeah, so the theorem only stated it for the unit circle, but it actually works for any triangle. Yeah. So what is it?
Excuse me, I thought that was my one.
Excuse me, I'm unique in every way that I am.
I'm black. I'm black, I'm Soviet, and I'm also Nazi. So essentially just A plus B plus C.
So here's the psychological part of the training. If you get through the math, but if you can't get through it while being trolled, constantly distracted, then you're not good to us.
Oh, it makes sense in the unit circle because we are sin for order center and the center.
They're on the same line. Yeah. The Euler line. Yeah. But I think even without the unit circle, it's still like a third of the vectors.
I think that's how it is for convection. Yeah, because it's like a gravity center.
Yeah, because we had like.
Yeah.
So if you just do it, like I mean, what are you showing? Like if you know that's what you're trying to show, right? Then you're basically kind of showing like, you know, the distance is in the ratio 2 to 1 kind of thing, right? Yeah. That'd be enough. Maybe I'll show you in another way that'll help me do the next thing, okay? So if you have like, oh, I don't like these brackets. Can we go back to ABC? Okay, so we go back to ABC. If we have like A, maybe I should do big A, and then this is the midpoint, right? The equation of that line, right?
What's the midpoint minus?
Is the midpoint minus. So it's A plus a multiple of minus. So it's A plus a multiple of the midpoint minus A. Yeah. Like the vector equation. Yeah. Does that make sense?
Oh,
B plus C over 2 minus A.
Why is it
So
not
this we call this M, right? So this is AM, yeah. And then this is OA, yeah. So I mean, if lambda is 0, then you're at that point, right? If lambda is somewhere in between, all the way up to 1, you get to B plus C on 2, right? So basically, for every real value of lambda, you get a point on the line AM. Yeah. So like, if you take that idea, right, and you have like B plus mu, and it's A plus C on 2, right? A plus C on 2, right? Minus B. That's another median, yeah. C plus mu, yeah.
use B?
So it's A plus B on 2, yeah. Minus C, yeah.
B performing.
So there should be, and then value 1 solution. So if you set lambda, mu, and mu, so basically, if you can set them to one value, like not to the same value, but if there's one value of like that, this, and that, such that all the points give you the same expression, that must be an intersection, right? So I think if you set them all to 2/3, right?
Yeah.
Right. 2/3, you get you get a third. You get a
1/3 of.
You get a third of everything, right?
Yeah.
And that's what the answer is. Okay. So that's the centroid taken care of, and it doesn't have to be unit vectors, as you know with that, right? Okay. So that's something is kind of annoying because you have to figure that out as you do it. Yeah, so you can obviously, like, if you run into this, it'll take you longer to do, right? So like, it's better to have some idea of this before you go into exam. But pure maths, I mean, if you run into a problem, you have to solve it, yeah. And And one of the problems was actually just the presentation of our theorem. Like they're all presented under the same assumption, which doesn't need to be held yet. Okay? Alright. So the thing works. So that's G, yeah? Okay. And also, you might want to notice that it doesn't have to actually be G. Any multiple of G will suffice for our purposes, right? Because we only need the intersection of OG, yeah? We only care about the line OG. Oh, yeah. So we can scale it as much as we like. It doesn't really make a difference. You know? Yeah. So I don't think M even like necessarily goes between O and G. You know? It's 1/3. You don't need 1/3. Yeah, it doesn't have to be 1/3. It could be like 2/3. It could be 1/6. It could be a little bit. Yeah, so that's going to be interesting later on. Yeah. Right. So how could that possibly be interesting? All right. And then, so this is the part where we might have to skip some things. So like, the part that we have to skip some stuff is the formula for the intersection of two lines. Oh, yeah. Remember what that was?
Yes.
So I'm gonna give you an idea how to prove it, but like it's gonna take us too much time, and like it's not quality time. So I'll prove the easy case, and I'll leave the hard case. So maybe not hard, but the long case for your private study.
CD times A plus B minus A.
Okay, so let's try to not. Yeah, like don't use. Let's substitute the letters before they confuse us. Okay. Yeah. So it was. We had two lines.
On the unit.
So it didn't have to be on the unit circle, but when it's on the unit circle, it simplifies a lot.
Yeah.
Oh, you worked it out when it's on the unit circle.
Yeah.
Can you tell us what it is?
CD times A plus B. Minus AB times C plus B.
So let's do it. C, B
Times A plus B.
times A plus B.
Yeah, brackets. CD bracket A plus B.
Maybe do you have the general one? Because if you don't know why it specializes, it might be easier to
Could specialize this first.
because we need to specialize it twice. So we need it for H, right? And we need it for M.
So
Yeah.
A bar minus A bar B minus A B bar.
A bar B minus A B bar. Yeah.
Brackets. Minus. Oh wait,
This is AB intersect BC, yeah?
Yeah.
CB.
minus A minus B. C bar minus C bar D minus C B. On A bar minus B bar times C B. Minus A minus. No. A bar minus B bar minus C minus D minus C.
C minus B, yeah.
Minus A minus
Minus
B.
A minus B, C bar minus B bar, yeah?
Now to find out what we call
What's bar?
Complex conjugate. Yeah.
How do you complex conjugates equal? Other than that, you see that's it.
But how do you get about these results?
Huh?
How do you get about these?
Yeah, so I'll explain it to you, okay? So basically what I want you to do now, okay? Specialize, so like you don't even have to actually sub in what G is, okay? But just pretend like one of them is OG and the other one is, so just use the letters little f, little h, yeah? And 0 and little g, yeah? And sub it into here. Does that make sense? So that's what M will be, right?
You just change the C to like before.
Yeah, C or D. I think D was, yeah, it makes a difference. Maybe we can do D equals 0, right? So what is that?
And we have F hatred.
Yeah. We're just using the letters little f, little h, and little g, yeah? We're not subbing them in, yeah?
F bar.
We're not subbing what they are in, we're subbing the letters in.
F bar H.
F bar H, yeah.
minus FH bar.
Yeah.
Minus F minus H.
Wait a minute, there should be a C minus, is there something here, C minus D?
Yeah, that's actually
There's something missing.
no, that's not.
There's nothing here, no.
There is C minus.
There's something here.
There's C minus D.
C minus D?
Yeah, C minus D.
Yeah, I think it should be symmetrical, right? Because there's no. Okay, so C minus D is just G, right? Yeah.
Yeah, the vector test. Minus. Yeah.
And then these are all zeros, right?
Yeah.
And then this is just
How do you get
F bar
minus
H bar, right?
Yeah.
G minus F minus H G bar, yeah?
Yeah.
I mean, I've done this before, so this does check out, okay?
How do you predict this?
Yeah, so let's just try and prove this directly, yeah? We'll get some idea where the bars come from, yeah? 'Cause that's pretty much one of the main mysteries, yeah? Okay, so consider, so is it obvious to you that M from this formula is on OG? Is that obvious?
It's some scale of G.
Yeah, so because, can you see?
Yeah, it's some
Can you see F bar H is the conjugate of FH bar?
Yeah.
Yeah. So then, if something minus its bar, it's imaginary, right?
Yeah.
Okay. The bottom thing is also something minus its bar, right?
Yeah, so it's also imaginary.
It's also imaginary. So then, when you cancel the i's, it's a real multiple of G. Yeah? So it's actually on OG.
So it's a real scale of
Yeah. Well, to make it less mysterious, and this I think will explain the other formula as well, yeah, is if you just think of what I was doing with the lambdas, remember?
Yeah.
So what else was I doing with the lambda? So you have like lambda, lambda G, right? That's what a multiple of G is, yeah, is equal to, and then we're looking at well, it's either AB or FH, right? So let's do FH. So it'll be like F plus a multiple of F minus H minus F, yeah? Is that okay? Yeah. So that's like the intersection condition, yeah? Okay. So it looks kind of weird because it's got like, you got two variables, right? Lambda and mu.
Yeah.
And you have one equation, right? But in complex numbers, every time you have one equation, it's really two equations.
Yeah.
Because it's imaginary and real, right? So complex numbers have two numbers in them.
Yeah.
Yeah. So, and what is imaginary? What is real, right? Real is just x plus x bar.
Yeah.
Or times half, yeah? And imaginary is x minus x bar. Yeah? That's where the bars are coming from, yeah? So basically you're just solving this equation simultaneously in real and imaginary part.
Yeah.
Does that make sense?
Yeah.
Do you want to go through it? Yeah? Okay. It's actually pretty simple. It's just, it doesn't necessarily translate simply on written. Yeah, so if you take the real part, right? It's real F plus mu real H minus F equals lambda real G, right?
Yeah.
Okay. You take imaginary, yeah? Equals lambda imaginary G, yeah? And now it's just actually two simultaneous equations, right? This is real. Everything's real now. All right, so basically you're just solving for mu and lambda in terms of real F's and everything else in there, right? But if we only want this formula, right, we really just need to So we can target lambda, right? This is going to be lambda. Like m equals lambda g.
Yeah.
So if we find lambda, we don't have to sub back to find mu, yeah? Yeah, so how would you solve your favorite? What's your favorite way of solving a simultaneous equation? I think if we wanted to find the lambda, right, we would try to get these mu's to cancel. I feel awkward even saying this. So, times the first one by that thing.
Yeah.
It's like 2 steps, yeah?
Yeah.
You agree?
Yeah.
Okay. And then after the 2 steps, you just sub in h minus f bar to get the real and the imaginary.
Oh.
Do you want me to go through this?
So,
Okay, I just need to allocate my space here. Okay, so this is real f, imaginary h minus f, yeah? So times the first thing by imaginary h minus f. Okay. So you get plus mu something equals lambda real g imaginary h minus f, yeah? And then you times the second thing by real h minus f. So you get imaginary f real h minus f plus mu. It's the same thing times mu, right? The whole point of doing that. Lambda imaginary g imaginary h minus f, yeah? Yeah. Okay, so then you cancel, yeah? So you get lambda equals, so let's do the second one minus the first one, yeah? Oh, did I do the second one minus the first one? I did the first one minus the second. Alright, so the first one minus the second one, you get real g imaginary h minus f, yeah? Minus imaginary g real h minus f, yeah? And then the other things were real f
Oh, and that's how
imaginary h minus f minus minus, what am I up to? Wait, did I do it the wrong way around? I think so. Imaginary f. I'm doing 1 minus 2, yeah? So it's imaginary, wait, what is 1? 1 is this one. Sorry. Minus imaginary f real h minus f, yeah?
Yeah.
Okay. So, I mean, now we just,
Wait, imaginary. What's the one for?
this one,
Yeah.
imagine, yeah? So, I don't know, maybe we can do this in pieces. So, the bottom thing is, so the denominator, right, is g plus g bar, yeah? We don't have to do the halves because they all cancel anyway, right? They cancel with the top halves and each other. So g plus g bar, and then we have h minus f minus h bar minus f bar, yeah? Minus, this would be like probably better to just do yourself. But anyway, this is g minus g bar h minus f plus h minus f bar, yeah? Maybe this is the kind of thing you need company to do. So I remember we have like in grad school, we had like marking parties where we get together to mark stuff because it was just kind of too boring to do by yourself. Okay, so like the coefficient of g, right, should be f bar minus h bar. Yeah. So here it's where's the thing that cancels? Yeah, the h minus f cancels, right? Because it's h minus f times g, yeah? And it's h minus f times g here.
Yeah.
And they cancel.
Yeah. And then you're left with
Then you're left with
it's minus.
so negative of h bar minus
So
f
that's
bar,
F
right?
bar minus H bar. Yeah.
So it's f bar minus h bar times 2 because there's another one there,
Yeah,
right?
that's it.
But the 2 will cancel eventually.
Yeah, somewhere.
Okay? And then the coefficient of g bar, yeah, it should be f minus h or negative f minus h. Okay, and so here it's this other thing that cancels now, right? Because that's a minus and that's a plus.
Yeah.
Yeah?
Yeah.
So then you get the 2 h minus f's.
Yeah, and that's
The double cancel.
Yeah.
And then it's a line.
Yeah, h minus f is minus f minus h,
Yeah.
right?
Yeah.
Okay, so basically we got 2 times the denominator, yeah?
Yeah, so now we'll probably also get
Oh, actually, we got the halves, actually, don't we? We didn't do the halves, so the half cancels with itself.
So now we just have to
Oh, I'm confused now. It's like a half here, but there's still a half. Okay, so don't worry, it's going to be the same for everything, okay?
Yeah, okay. Yeah. And then this should be fine. The contributes. Yeah. So.
Yeah. So, but the thing is, now you've explained the mystery of the bars, yeah?
Yeah.
Should we go through the top?
No, this is.
Okay, good.
Wait, no,
Thank
you're
you. Huh?
not.
Huh?
Okay, I didn't say anything.
Okay.
Yeah.
You just convinced it'll work.
Yeah.
And it's actually not as hard, okay? I mean, after a test and lunch and stuff, you can do this without looking, yeah?
Oh. Okay.
Like, there's no thinking required. This is the kind of thing I hope the whole problem is going to be.
Ah, okay.
Right?
Okay.
There's no thinking involved in this, yeah?
Yes. Yeah.
It's routine. Like, there's no way, like, you think I would not solve this if I tried. Yeah, that's the kind of impression I want you to have.
Okay.
Otherwise, we might have to do something. Okay, and the same with this, right? Can you see this is just this
Yeah.
like a more chunky version of that, right?
Yeah.
Okay. So as long as you're convinced. So obviously the problem is being convinced doesn't necessarily make this formula as written true, right? Okay. Okay. All right. Okay.
Right, hang on. What happened to the mute?
You cancelled it.
That's the mute.
We'll sub it back in. Yeah. Okay. One more thing is, so even in the notes, it was like this equation is not going to really help you unless you're doing this special case here, or like A, B, C, D are all on the unit cell.
Oh.
Yeah. Okay. So that's the case when you have E.
Yeah.
So what happens when they're all in the unit circle? Well, the point is the B bar turns into B inverse.
Because they multiply to 1.
Because B times B bar is equal to 1, right?
Yeah.
Because it's equal to the absolute value of B squared.
Oh, yeah.
Yeah, and it's on the unit circle.
Yeah.
So then, B bar becomes 1 on B. So then getting rid of all the bars is just like clearing denominators. It just times everything by. So maybe we can write that down.
By A, B, C.
So what are we doing? We're doing E, B. What are we doing? We're doing E. So EC intersect BD, right?
Yeah. EC.
Yeah. So I think, yeah. So EC intersect BD. So I'll write down what it should be from this, and then I'll erase. Yeah. So EC. So EC. So E bar. C. Yeah.
Oh, I have the simpler version for it.
Oh, do you? Okay, we use that to check just in case. EC bar. Yeah. and then B minus D. Should I write this down somewhere? I must have written this down somewhere. Maybe I can just cut to the chase and then you can tell me if it's right, yeah? So I had CE D plus B minus BD
Yep. Everything.
E plus C over, so this is H, yeah? Is equal to CE minus BD. So all I did was put, those letters into here and then cancel out as, like, when you put A as A1 on A,
You cancel.
and then times by, like, make sure all the denominators, times by all the denominators, and then you get some differences of squares and cancels. It's all routine, yeah?
Oh, you good.
With this. That goes down.
It goes down. Okay. I'll trust you. Yeah.
Okay. Well, I'm glad we got past that. Okay.
I'll just stop this lecture.
Yeah, that was the theory part, yeah? So I guess you meant to go into it with that. So,
Yes.
but if you didn't go into it with that, then your first 36 minutes will be about that. But like, it's possible. See, that's kind of like maths. You always get a chance. Okay. Yeah, and you might not take 36 minutes, depending on. Okay. So we're convinced we can kind of find expressions for all the variables now, right? Because what do we have? Intersection, midpoint. Midpoint is obviously just the average, yeah?
Yeah.
And we have, okay, so this is where I got a bit stuck at first. So it's obvious where I'm going to put the circle in this problem, yeah? I pick the origin. I make the scale unit, okay? So the other choice, it wasn't too obvious, like where to put the real axis, yeah? I don't know, where would you put it? Yeah, so the things that I got stuck on, well, I got stuck on putting the real axis somewhere, right? Even though I had like things I could put the real axis there, and then I kind of got stuck on like how to use the condition, like because we haven't done all the conditions yet, right? Because at the moment there's 5 variables. Yeah, like everything comes from 5 variables. So we haven't got the real axis, and we haven't got the conditions. Yeah. So, any ideas? By the way, I was so naive. I was like bashing it before I even did those things. Okay, that's how dumb I was. Yeah, Sean. Yeah, we're looking for the real axis and we're looking for the conditions. Yeah.
DC.
Oh yeah, and then like make it kind of like then you're proving it's just imaginary, right? Yeah. Okay. Probably cool.
Yeah, perfect A was C.
Anyone coming up with ideas like put A, B, or C or something equals to 1? A, B, or C. Oh, yeah, that works.
Put A is equal to 1 and then E and B are
100. Yeah, so basically, if you put A equals 1, you lose 2 variables, right? I mean, you should always lose about the same number of variables. There's some, actually, like, you know that, like, because of these 3 chords being equal, like, this line is, like, parallel to some of the line. Like, AC is parallel to ED.
yeah.
AC, AD is parallel to BC. You know? So, like, I guess I would lean towards making A1 because the others would disrupt that kind of symmetry. Yeah. Okay. And here's the moment where I was like, okay, this problem is complex bashed. Right? This is the moment I was like, it took me so long to realize that once you make A equals 1, right? Then B becomes, so E becomes B bar, right? Okay. And then it's this condition I couldn't use, yeah? Yeah?
Yeah.
But in complex numbers, okay, D is equal to CB.
CB.
If you can internalize this right now, it'll save you a lot of grief.
Why is B equals to C?
Because this length is the same, right? So D is just a rotation by that much.
Yeah.
See, because A is 1, right?
Oh.
A is 1, then B is the number that rotates. You know complex numbers? So complex numbers.
Oh, B is the rotation of that.
So if complex numbers is like if you multiply a complex number by another complex number,
You get
the length is the product of the lengths, and the angle is the sum of the angles.
No.
You know that?
No, you don't. No.
Okay. Okay. So.
Oh yeah, so the angle is the same. So it's CB. CB.
Yeah. Have you seen this notation, like EI theta?
Yeah.
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 So the point of this notation is like E times I theta I, like some other letter, right? Say phi, right?
Yeah.
You get E I theta plus phi. So the angle adds, yeah?
Okay.
So if A is 1, the angle is 0 here, yeah? And the angle here is, like negative whatever, you know?
Yeah.
And so if you times something by B, it'll rotate it by that. It's like, say there's negative 30 degrees, right?
Yeah.
It'll rotate it clockwise by 30 degrees.
Yeah.
Yeah?
Yeah.
So that's what you want to do to C, right?
Yeah.
So then D, so this is this is like a punchline. D equals BC. Yeah. Huh?
What do you rotate by C?
You're rotating C by B. You rotate C by this length. Yeah. It's like. So I went to sleep with this. Yeah, it was a bit overconfident, but like, I mean, there's something like elegant about using all the conditions in the question, and something probably essentially like you can't even do the problem if you don't. So like once you overcome that, it's like oh. So now we only actually have like 2 variables and like a 1. Yeah. Don't have a D anymore. Don't have an E.
Mm-hmm.
And A is 1. Yeah.
Yeah. So we only have B and C now, technically. Yeah. So and then you can find stuff.
And you can't really get rid of C because C can really be anywhere.
C can be anywhere.
So now we just actually the conditions.
Yeah, and I was kind of disappointed that it didn't work for me. It just, but along the way, you can pick up little bits and pieces that solve the problem. And those little bits and pieces are not necessarily easy to see on their own. Does that make sense? So for example, yeah, let's see. So I was always a bit unhappy with G, yeah?
Yeah.
G is like this random centroid thing that makes me like have to think about the conditions of the theorem. Yeah. So what was G? G is a third A plus B minus C. B plus, yeah, I mean, it's the sum of the things on two, right?
It isn't the where what is
So define
E
that.
plus D is J, right?
E plus D
On 2 is J.
And E plus
And B plus D, yeah? Okay. So you might notice from here, if you make this on 6, since we don't care about the scale, right? You can make this on 6 and you get this 2A, right? Oh, actually, maybe you just keep it on 2 anyway. But like, what am I doing? No, maybe it was the same before. Anyway, like if you look at it like this, right?
Yeah.
Okay, what could that remind you of? Well, we know that the orthocenter, right, is the sum of the 3 things, yeah?
Yeah.
Can you see that this is the sum of 6 things?
Yeah. Oh, A, B, C. Oh,
It's A, B, C, and A, D, E, right?
Yeah.
So that's kind of key. Or A, D, C, right?
A, B, C, yeah.
And A, B, E.
Yeah. Oh, and that's one C.
Yeah, so that's
one F and the other one.
yeah. So the reason, like I don't know if you're meant to see that or whatever, but like if you do see that, okay, then you immediately kind of know that something interesting is coming from this, because the orthocenter of ADC is a key character in this problem.
Yeah.
Because for A to be perpendicular to DC, it has to pass through the orthocenter.
Yeah.
Yeah?
Yeah.
So wherever it is, it's probably it has to be like in line, right?
Yeah.
ADC. Okay. So maybe we do want to take it on 2, right? And think of it as the midpoint of the 2 orthocenters. Does that make sense?
Yeah.
Because that's actually a thing. I mean, if you add them, it's not really a thing. I don't know. Maybe if you knew what adding them meant, then you could think about adding them. But I understand midpoints, so I think about the midpoint. And things like that, it doesn't matter how you scale it. You can just take it off, right? So half midpoint of so you can basically pick G to be the midpoint of F and the orthocenter, the 2 orthocenters. Yeah. Okay.
Yeah.
So G equals midpoint of H, A, B, C, and F. Yeah. Okay. Okay. Oh, by the way, there's obviously lots of stuff to do as well, right? Because I mean, E shouldn't be in there, D shouldn't be in there.
Yeah.
A shouldn't. Well, A is not in there. Because at this point, you just want me to do it, right?
Yeah.
Okay. Well, let's see if I just write you the answer for what happens when you simplify that. Well, oh yeah, this also helps actually. Like if you simplify this, okay, you get this equals B outside of C plus BC plus 1 on 1 plus B plus B squared. So this is what you get if you put. Huh?
Oh. Yeah. Oh.
Okay, do you want to go through it? It's about 6 lines.
It's like minus BC.
I mean, if you're doing it yourself, you wouldn't really think twice. Maybe it's important to notice that. But the only thing you had to notice was that, like, there was sort of like a factor of b minus 1 in the numerator.
Yeah.
And it cancelled out with b cubed minus 1 in the denominator. Okay? And you get that, okay? And this is part of this whole thing, because what is 1 plus c plus bc, right?
It's A, B, C. The center of A, B.
Yeah, so maybe that'll explain. Yeah, so this D is BC, right?
Yeah.
Yeah.
C is
and C is C.
The
C is C.
center of A.
And 1 is A, right? So that is the orthocenter of
That's the
A,
orthocenter.
BC, yeah? Okay. And what's this other term here? If you think of it upside down, right? That's just 1 plus B bar. Yeah?
Oh,
Because
so it's one of that.
so 1 plus B bar.
It's just
Why is it 1 plus B plus B?
the reciprocal.
It's 1 over that, but like
Oh.
the point is there's 2 points, I guess. One of the points is that that's just F, okay? Yeah. 1 plus B bar is F, yeah?
Yeah.
All right. Yeah. It's 1 on F. So it's the.
This is 1 plus B bar, yeah? Okay, and one other thing to notice is it's real, yes? Because it's something plus B bar.
B plus B bar.
1 is real, B plus B bar is real, yeah?
Yep.
So what that's saying is
It's
this
it's
is a multiple of the orthocenter,
wow.
yeah? So this is collinear.
So, what, yeah, A F.
Yeah?
Yeah.
Okay.
Uh,
That's collinear.
when F is real, so
F is real, 1 on F is real as well, yeah?
Yeah.
So
Oh, yeah.
so the H is real times OH, yeah?
Yeah.
So it's just the scalar of
okay, yeah.
so they have to be collinear.
Yeah.
Yeah. Okay. I mean, another thing that's I don't know if it's to be expected, but it's kind of it's symmetry. It's symmetry because OAF is collinear, right?
Yeah.
Is that obvious?
Yeah. Well, the A and F are both real.
Yeah, that's true. And an orthocenter, and it's like symmetric, so it's in the middle, right?
Yeah.
Okay. All right. I think we might need another diagram.
What happens to H and the other H?
Yeah. And
right.
yeah. And we kind of want to join the F and the H together, like to make a triangle, yeah? And then the midpoint of that triangle is G. Like the midpoint of the base of that triangle is G. Is that the diagram I want to draw?
Oh.
This is what productivity drops off. Yeah. So that's like, oh, chocolate, good idea.
Yes. It's not dark.
I think
No.
Wait,
This is dark chocolate. Like, non-dark chocolate gives you more energy.
more sugar.
It's also trash.
Come on, it's like 1 hour off.
Sometimes it's the idea that's the important thing.
Oh my
The
God.
execution is trivial.
Whoa.
Hold on, we have a choice here: hazelnut,
Hazelnut.
dark,
Dark.
or dark.
Hazelnut.
Oh wait, there's dark salted caramel.
Hazelnut.
Just
Just dark.
Alright, hazelnut plus dark.
Dark.
Okay, cool.
Hell is this?
You can do this one. I'll take this one. Fine. I'm out of here. 72%. That's decent. Not 96. Bonk. Okay. What's your goal?
Alright, try to prevent. Okay, so one of your goals is to minimize carpet chocolate. Okay.
Alright, yeah. So the break inside. Right. That's all right. Yeah. What that?
Stop. No. No, that's wrong.
$1. Oh, we're getting inside. Just literally. Yeah, just other way, other side. What? Which side are right? I don't get. Oh, that's just the wrapping. Yeah.
When you menu back like this.
That's the wrapping of the wrapping.
Exactly. And you use this as to your advantage.
Oh, he's on. He's on that. No. Oh,
It's not great.
Hazelnut's good. Nuts are generally good,
not as good as dark.
Nah,
but it could be
I'll
dark
take
hazelnut.
that hazelnut.
Dark hazelnut.
Dude, what the hell happens?
Yeah. Well, I always wonder, like, is it like better to get because like obviously one of the ingredients is cheaper, so when they put them together, something's. But then the combination is more than the sum of the parts.
Sorry for sleeping. I only slept for like 2 hours last night. So
Ah, I see.
2 hours last night. Don't mind me. I don't even know how I woke up this morning.
You know, like instead of having these lessons, you could actually just put a video recording of me while you sleep. It's pretty much the same. All right. Okay. So the diagram I'm referring to looks something like this. Okay. You have a triangle. Yes. Yeah. This is the origin. This is the orthocenter of ATC. Yeah. And this is F. Yeah. A goes somewhere here, and H goes somewhere here. Yeah.
Yeah.
Yes.
Yeah.
And we can join that up. Do I want to join that up? Well, the midpoint is G. Yeah. Okay. So what are we even trying to show here? So F. Okay, so F is trying to. So F goes to H, it gives you M, right? Yeah.
Yep.
And you want to show that A going through the same point is the HADC. That would conclude the problem.
Yeah.
Okay.
Is this a difficult one?
So this, I must admit, is probably a top step. And so I had a little bit of a hint for this, okay? And can you see that? So if I'd drawn the diagram better, I probably wouldn't have needed the hint. If you drew the diagram well, you might be able to see that AH is parallel to FH, ADC. Okay, so first of all, can you see that if it was parallel, right? Okay.
Yeah.
So if this was parallel to this, yeah? Can you see then that that would have to go to, that would have to work if it was parallel?
The intersections are OG, yeah.
Right. So basically what I'm saying is, if they're parallel, right?
Yeah.
And A goes through the intersection where F intersected OG, yeah? It would have to go meet at the other orthocenter. Okay. The point is, because this, if they're parallel, then this is the midpoint. That's the midpoint too, right? And there's like lots of similar triangles in there, yeah.
Yeah.
So basically, it meets somewhere, right? But you can show that that length has to equal that length. See what I'm saying?
Oh, yeah. Yeah.
So, and I think that's kind of like a common kind of problem. You have the two parallel lines.
Yeah.
Like cross, yeah. Oh.
Yeah. Here's another.
Okay.
I'll grab some water.
Oh, good idea.
And for more convenience purposes,
Oh my god, it's an optimization of chocolate carpet. No, I'm just doubting you, sorry.
what?
No, he said reduce chocolate carpet. Which are briefly different.
Do not understand.
Carpet chocolate.
Don't put the chocolate on the carpet.
I use the wrapper to my advantage. And so yeah, we're both doing this thing. Hazelnut's amazing. Why does everyone prefer dark? But I don't know, maybe it's
Hazelnut's
just
like-
personality.
Like it tastes better, but dark is probably better for you. That one.
Yeah.
Well, it actually tastes better.
That's true.
More because that's the dark. Maybe like when you're used to eating healthy food, healthier stuff just tastes better. I know for a fact that if you don't eat healthy food very often, like I do, your bar like you can't like eat in certain foods. Like your bar for like fat and stuff is at a certain point. Like when I was like playing lots of sport, I was trying to eat healthy, so I was like I could eat anything and it would kind of taste good. But then sometimes like after you don't do anything for a while and you kind of let yourself go a little bit, it's like for example, before when I was eating dark chocolate, right? I was like, oh wow, this is so sweet and tasty and stuff. And then after I like started eating all this other junk food, it's like I'm eating this and I'm like, oh, it's not enough. I need like higher fat content, higher sugar content.
Apparently the person who lived the longest ate like a 1 piece of dark chocolate a day.
Okay.
Dark chocolate is actually good for you.
So I guess one thing to take from this, right, is that proving it's parallel is actually trivial in the complex batch setting. Okay? So how would you prove it's parallel? Okay, you just go H minus A. Yeah?
You're seriously using it.
So you basically just got to calculate H minus A, yeah? Does that make sense?
Yeah.
Can I erase some stuff?
Yeah, you have to.
Probably like one.
Yeah.
Lambda.
Okay.
So the refugee and the refugee. The lambda thing.
Algebra genuinely takes that for you. Yes. Maybe we just get back to the person. Because I would just get to read like Star Trek, not like
Alright.
maybe I can teach myself to get used to that.
Okay. What are we doing again? Oh,
AA parallel to it.
alright, let's do it. If we get stuck, we can look at what I read before. So what is H minus A, yeah?
H minus one.
Yeah, H minus, it's already, yeah, H minus 1.
Oh yeah, H one.
Yeah, that's like a simple.
H is that all of
There's a formula for H, isn't it?
Yeah, we have this, yeah, that's this.
Oh, that's H. That's H. Oh, it is for H. Yeah.
So BC plus B squared C plus B, right? On all this minus 1 minus B squared, yeah?
Mm-hmm. Yeah.
Alright. Does anything cancel?
The B.
No.
Please.
Oh, it's something.
That's like literally it.
No, hold on. There's a 1 plus B, like, it's 0.
They see like 3 and 1.
Hmm.
If we can somehow get off the C.
What are we trying to show? It's equal to F minus HADC, right?
Yeah.
What is F minus HADC?
It's 1 plus B bar. Let's take ABC.
And what's H? That's, what do you say? 1 minus 1 minus. Well, that's 1 plus B bar minus.
No, HADC is just A plus. It's just A plus B plus C.
Oh no, the H is not the sum. It's just what
Isn't it the opposite?
Yeah. So it's the other center. It's this thing here. So it's A plus the H we had. What we have? Oh, it's just the other center. It's not the midpoint.
Yeah, so it's A plus D plus C.
A plus C plus D.
Or A plus C
Isn't it
plus
just-
B.
And then B is just
It should be just B plus E, isn't it? Oh no, B plus E minus. No. B plus E, B plus B bar minus C minus D.
Yeah.
Yeah.
But
So the ones cancel, yeah.
The
That's ones cancel, and then you get the B plus E
and the B cancels with the
minus the C minus CD. Yeah.
Yeah.
That's what
Wait, CD.
CP. Yeah.
you can provide the
Okay.
you can
Mhm.
Wow. Apparently it takes what is way more.
Nice.
I assume you're gonna take this course off. Truly, I think it's super hard. No, I think it's super hard. You should just watch it feel hard.
Like you put it in your mouth, it's still like solid for like pages.
All right, so this is B squared plus 1, right? Minus BC minus B squared C on B. Huh?
Yeah.
See that? So just treating B bar as 1 over B, and then putting everything over B.
Why is this look a bit familiar?
Because it's the same as the top.
Hmm.
So look at the top, okay?
The denominator
Okay,
is the same.
so the denominators are not the same, but the numerators are like negatives of each other, right?
Yeah, true.
So BC minus BC, B squared C minus B squared C, minus 1, 1, minus B squared B squared,
I
right?
try to prove that once and multiple double.
Yeah. But look what the multiple is. It's F, right?
Oh,
Or 1 on F or whatever it is. It's
one something F.
because you times it by this over B, right?
Oh,
and you
yeah.
get that. Negative that over B.
Mm.
Yeah? And that's what F is, right?
Yeah, it's B plus B bar plus 1. Yeah. Yeah, because 1 plus B plus B squared divided by 3.
Oh yeah.
Okay. Yeah? So that shows it's parallel.
Yeah.
Okay? And that would solve the problem. Okay? Yeah, and I didn't stop here because like I was still being dumb and trying to bash the thing, I was still bash. Like,
once it goes parallel, it's done.
Oh yeah, okay. So if they're parallel, right? So you know that like this is the midpoint of the two red lines, the two, yeah. And then like this line goes and makes like a similar triangle there. And so the ratio of this, whatever the length is here to that has to be the ratio like this to that, which is that to that, right?
Okay, yeah.
So then it's equal. So then the point it intersects is just like, yeah. So yeah, it's kind of nice actually. It's a little bit disappointing that there was actually some geometry in there, but like not disappointing from the point of view of the truth. But yeah, but there's other ways to continue the bash. So I want to kind of explain. There's another way to kind of continue the bash, right? So the point I want to make before my phone dies, is so one way to continue the bash, okay, is to show like it's much easier to figure out what M would have to be. Like it's much easier to figure out the intersection of OG and A orthocenter. Yeah. So for some reason, when I did it, okay, so like, because M is the intersection of FH and OG, right? Yeah. But it has to, like, for it to be true, it has to also be the intersection of A to the orthocenter and the OG. Yeah. So to find the point where the orthocenter line intersects OG is much easier. Okay. So I could actually do it. All right. So it was like, what was the formula? It was something like this. BC squared. And you'll also find, like, sometimes you just want to look at the answers on the other problem solvers, but they don't, no one does it by a complex fact. So you're just like, oh. It's like, even when you admit defeat, it's like, you can't. It's like, B squared minus 1 plus CB minus C. Oh, wait, no, this is the second last one. B squared minus 1 plus B plus C.
You have to take a photo. Because
B plus 1.
I'd say it counts
Okay. So that will tell you what M has to be, okay? And so that kind of saves you from, because if you were doing it normally, right, what would you be normally doing? You'd be finding, you know, A, M, something, and then taking like the conjugate to show it's imaginary. You know what I mean? Because it's something perpendicular. So that's why, like, if something's perpendicular, it's that times by I, right? Yeah. Because it rotates by 90 degrees. Yeah, that's what I does. So to show that something is another thing times I, like you could take the ratio and it's equal to I or something, right? And then take the conjugate, but then it has to be negative. I just goes to negative I. So I don't know, it turns out kind of messy, but it's kind of easy to get a point like this. So I never quite tried this completely. I kind of didn't really have time. But if you put this as your M prime and try to show that M equals that, you at least get to the point where like you have lots of powers of B in two sides and you're saying they're the same as each other. Okay? So I think that would be a promising way to go if you wanted to keep backing it. Alright? But I still like, even though I wanted to do it thoughtlessly, I think it's still more elegant to use actual geometry to solve the problem, right? Yeah. So it's just like, so if you do it like that, it's kind of like anytime you actually need something, it's there, right? You get the pieces minus it, you don't get the whole thing minus. I don't know. I might stop that there. Husky.
Oh, I should have got over it.
It's like 2 hours ago. Can you tilt the screen down? Can you tilt the screen down again? It's after like 40 minutes. Yeah. Yes, I hope I did.
You didn't say it yet, okay.
Yeah.
You say what you mean, I know.
Alright, so how are we feeling?
Oh my god, what crap.
Let me just put this on the tripod wallet.
This one.
Oh, like one. Oh.
I don't even know what's wrong.
Like that's kind of like, you know, we introduced complex batch. Now it's kind of like repeating complex. Yeah. I guess are we ready to start inversion, or do we need a break?
Yeah.
I love these.
I'm pretty sure the James May wants these to actually do like
Well, yeah.
Is that like the joke? Is that the new meta now for the joke? Actually, if someone has like the phone number for James Payne, we can maybe get him to like.
Is it legal? I think legal.
Yeah.
Is it really good to private? Yeah.
Yeah.
Do you have a private sector with James Payne?
Is it true? Yeah, it's actually at your school.
I don't know.
Because especially when it gets closer to the exam, like, it might be nice to just have him tell you what he knows about the exam. Like, yeah, so when you see geometry, that's 0 to confidence.
They usually geometry. That's a wonder.
What do you even do with conjugates? I'm actually confused.
Oh, who does software development?
I'm like, is there any properties of conjugates?
Huh? The conjugate is basically it respects all operations.
Even multiplication.
Yeah, it respects all algebraic operations. Because the point is you can't tell the difference in I and minus I.
What about powers?
Like normally when you square root stuff, one's positive, one's negative, right?
No,
But what's the difference between I and minus I?
You just see minus.
There's no difference.
Oh, yeah.
So you just replace I by minus I. That's what conjugation is, right?
Because like if you can multiply these two, you can get over the door.
Right? And all the things are totally symmetric under that operation. Because you don't know which one it is.
Sucker. Look at it. Oh, bitch.
You have a translator like this.
Halfway. No, I'm fine.
Essentially symmetric.
Why do you get one v one by how does that work? What is this? Like it doesn't seem like it could. Yeah. Until you get a good difference. Yeah, and then for some reason you just have to actually go.
And it's so hard.
Yeah.
Yeah, I swear if I was young, we'd just like, let's go. And then we'd like go until we all like die. But then we didn't die. That's why. Oh, this battery's gonna die. So we have some technical difficulties. I wonder if this works. Oh, wait. Please work. Oh.
Oh, that guy, you don't feel that again. He heals.
Oh, we're back in action.
What? Wait, what? How did you die? I get 12.
Yeah. Alright, anyone want to help clean the board? Okay.
Oh no, that's this thing. Yes. Working.
Well, look at it.
It's a live stream on feed.
Yeah. So hopefully we'll get some new technology soon.
Technology.
Yeah, my dad said there was like a way to get like maybe like a tablet that sort of projects. I don't know.
Oh, so you're here, that's like this.
It's kind of like you can just do it on a TV. So I get like a TV screen, and I can just kind of like write on the computer screen.
Good geometry. Diagrams.
Everyone just says my diagram is bad.
No, not bad.
That's
We
true.
can just use like a dedicated tool.
Well, you don't have to say they're not bad. It's about the truth here.
Wow.
I'm making videos in Comic Con. I kind of style. It's not
On the blackboard.
yeah, except it's like
And then like the
awesome.
yeah, I thought we were And then like we were just running around the bush. We were running around the tree. And then I went this way. Do that. Get on it with it, right? Yeah. And put it. There's an active picture. Oh god. I can't accept that. Very good. Yeah. You think this person? Yeah. Alright. You think? Right, right up. Where are you? No. He did not see that one coming. Oh god. Take the photo. Alright, you know what? No. We put it in, and then we can very wonderful way to okay. Okay.
I need some paper.
Oh,
Hazel that went past me wrong.
yeah.
Three people on the top, and one person on the head.
I want to do it.
Oh, really?
Yeah, I
Really?
because
I just want to do it.
I can't read that. Like that, if I didn't take the juice, and I still killed the guy out of the one, because I did that.
Alright, make a piece of chocolate appear.
Oh.
You can take your share.
What? What's this?
David, it's not that big a deal.
Wait, how do you spell it? It's not.
Wait, what?
B-L-O-C-K. Are you sure that's how you spell it as well?
B-L-O-C-K's block. It's on that block. Block.
Huh.
Oh.
Oh, thank you. Let's stick on the other ball.
Oh, wait, this. Hang on. I haven't even thought about this.
It's like the offer.
Oh, it was the bucket.
From now on, I'll eat dark chocolate every day, so I've lived here 120 years.
Alright, let's go. Inversion time.
Some French woman lived here 122 years, so if I eat dark chocolate every day.
You have a teenager. Maybe you'll become curious.
5.3.
Oh, I hit it.
5.4.
Wow, this is in
Yeah. So we're doing from so this is called orthogonal. Orthogonality.
That guy's not.
So this is under inversion
Is it over? I mean,
and georevision.
Ortho.
Yeah.
Gonality.
wait, am I right?
So I mean, if you missed all the stuff on inversion, I'm trying to give you a few properties that will help you.
That's just geometry. Like, you have a point that's, and then you join it to the center of the circle, and then like there's a kind of just like the inversion ones like that.
Yeah. So what it is, it's like a function, right?
Function of
That takes like the plane, right? Minus a point. That's yeah. Minus a point to the plane minus the point. Yeah, it's the same point, and it's an involution. Okay.
Oh yeah.
So that's what inversion is trying to be. Yeah. And how it does that is you take a circle, right? You have to fix a circle.
Yeah.
So the radius is r, right? Yeah. And if you want to have like a point P, right?
Okay. You define P by
Or f of p in this case. If it's outside the circle, f of p will be inside the circle, right?
okay.
And if it's inside the circle, then f of p will be outside the circle. And the definition is like f of p times p equals r squared, yeah?
That's the
So it's symmetric for these 2 points. There's actually an involution. The p goes to p prime, p goes to f of p goes to p. So f squared of p, or f squared is equal to f. Yeah? Alright. Excellent. So some properties that we had was like, for this definition, it's kind of obvious that rays go to rays. Like this line without the origin is fixed. Like the set is fixed, yeah? So the lines, so that's O, O. I shouldn't start with that. Fixed. Or preserve. If the points are not individually fixed, the lines are fixed, yeah? Alright. Then we have circles. So it's obvious that the defining circle is actually pointwise fixed, right? Like this point, it's f of this point q is equal to q. Yeah, it's on the circle. And circles. So the theorem that we learned just before this, okay, the key theorem was that circles not passing O, right? Circles that don't pass through O, this origin, go to circles not through O, yeah? Okay. And then we have like some easier things was like straight lines. So we dealt with lines through O. Lines that are not through O go to circles through O, yeah? Yeah. And we also know stuff like, I don't know if we'll need it today, but like, you know, if you have a circle through O, then the line that it passes, the line that it turns into is the radical axis would be inverting circle.
But it's not just like an infinity bar circle. It's like if you, because like, you have like 3 points, right? Because it passes through the center of the other circle. It's inverted.
Yeah, so like if you think of the lines, if you think of the 2 endpoints, the endpoints of the line is meeting at the same point really far away.
But that point,
That's where O would go, yeah?
if you show somebody like once made a good point, then like the number line is like 8 bars. Like you use that like say that's a good point.
I mean, if you think it, you can kind of think it's like,
oh yeah, man, this sounds amazing.
Alright, what was it?
It's like it's all insane match channel actually.
You did it, you did that with the lights.
Yeah,
It was brutally some identity.
exactly.
Yeah, so I mean, if it's the other point of the sphere, we're on the bottom of the sphere, right? Yeah. So we can think of the lines as kind of going in the North Pole. Anyway, so that's kind of the background, yeah? Yeah. And I feel like I've already forgotten what I was going to start with, but oh yeah, it's orthogonality, yeah?
Why do lines not go over the circle sphere?
Say again.
Is that okay?
Why the what?
Lines not go over the circle sphere.
Oh.
That, like, the circle through become like. Circle through become like.
Yeah, I think that's something to easily verify, I think. It should be anyway. Yeah, I guess that you have to kind of convince yourself if it's a straight line or not.
F takes R squared to R squared. Wait, what?
You know, 2 points on it. It's like the intersection
Oh,
of
because
the circle with the
there's
figure,
like
right?
similarity. Yeah. The diagonal. This is the line. Yeah, and then it goes to a circle. Yeah, you're going this. Yeah. Oh.
But we can
And
assume
here
this
they
for
are.
now.
So this goes to G and we find the A.
Yeah, we can kind of.
Yeah, it's by similar.
Oh. But we recorded this at some point, so today we just assume this actually is good enough. Yeah, the details are not too hard, but you can just pick them up. Yeah. But yeah, I guess if you're convinced of it, then it is the right axis, right? Because if it goes through O, the circle has to intersect the circle, and then the points of intersection are fixed. Yeah. So then, if it's a line, it has to be a line through those two. Anyway, so orthogonality. Okay, so when you think of how you might define if two circles are intersecting like this, yeah. You think of how you might define the angle of intersection.
Maybe because you join like one percentage of that is like a
Oh, okay. Like that.
Yeah. Because then that's not even like somewhere. These are bigger choose.
Yeah, that makes some sense.
Or maybe it's something to do with tangent. Draw one tangent, draw the other tangent, and you can't tangent.
Oh yeah, so that's how they define it.
What a guess.
But I think this is kind of related as well. I mean, it's the same when they're orthogonal.
Yeah. But then the radius is kind of
Okay, so I guess this is what a natural definition is. It's one that you can kind of guess, yeah. It's a kind of one of the only things available. So you take the tangents, right? And you look at the angle. I think it's the one. I don't know if it's. I think it's this one. Maybe it's this one.
And like the
Yeah. Is there an issue of well-defined here? Or is there an issue of this definition making sense?
Yeah, first of all, they have to accept the
Well, I guess if they don't intersect, you wouldn't know. Yeah.
Then it also comes like circle and circle. That's just.
It's not intersecting.
What if it was like intended? Like one circle inside the other circle.
If they're tangent, then it's 180 degrees, right? Or 0 degrees.
You should have just like intended passing over the
Is that a 0 or 1? Yeah. The one thing is, I mean, like, we made a choice. Whenever you make a choice, there's an issue of well-defined, right? So we made a choice of the point of intersection. This point also is a point of intersection, right? It should all, like, for this definition to be kind of nice, it should be the same angle. Right?
Yes.
And it is, yeah? Okay, cool. That's good. Okay. Now, I guess the first claim is inversion preserves this angle. Okay? So I guess the book always says it like backwards. You don't necessarily know what it's getting at. But yeah, so it's basically trying to say inversion preserves this angle. Okay? So for that to make sense, we need to define like the angle, like, see, I guess it's nice because the angle, like if it's a straight line already, then you already have the angle with the tangent. Right? What is essentially the angle between two straight lines? Yeah.
What the hell is that?
So let's take.
Yeah,
Can I erase this now?
Any one of the circles have to be like central, or is it just general system?
Which one?
Like
The properties.
inversion, yeah.
What was this, the second property?
Yeah, but like inversion circles.
you mean this? If you're inverting a circle that passes through O?
Yeah.
Or what happens when you invert circle to center O?
No, the circles need to be center of it to be precise.
Oh no.
Because
They just all circles that don't pass through O.
Oh,
Okay. All right. So basically, like one of the cases we can consider, right, is like just two lines, yeah, and make an angle theta. Yeah. Now, if we invert these two lines, we get two circles, provided these two lines don't go through O. Yeah.
How do you invert?
Let me see if I can. Should I draw the diagram? Let me draw that diagram. So the circle maybe looks like this. Yeah. That's like the inverted circle. Over here. Oh, okay. Well, do you know where it has to invert to, right? It has to invert to the circle that passes through O and these 2 points, yeah? Alright, let me use another color. So this is actually not too hard. So this is kind of an anticlimax. Oh, and then it's going through like that, yeah?
I know we draw tangents, right?
Yeah, tangents. That should be fair, yeah?
Okay, that's interesting. In theory, that should be fair. I want to angle match this, but that's kind of stupid.
So I think the observation that makes this kind of nice is that the original line is parallel to the tangent line. So what would happen if it intersected again? So we're keeping up with the book so far. So it's not too bad. Actually, sorry, I made this harder for you by drawing a diagram like that.
Yeah, sure.
Because it seems trivial, but it's actually this angle. I'm saying it's parallel to this angle. And it actually makes kind of sense because these are lines through like these are lines through O. Yeah. Yeah, so I guess the notes I had was if you just think about the intersection, because parallel is where the intersection.
Triangle match.
So think about where the intersection goes. And I can't remember where that went. So,
Oh yeah.
like in the book, it just says we covered it previously. Okay. In my notes, it says think about the intersection. Those intersection points. They should preserve parallel.
They don't mean the circle and the line. So the tangent and the circle don't mean because O doesn't exist. So, like if you invert the circle, it should think it was the line and the
So
like if you think of O as a point,
okay. So if you invert the line, right? It goes through Earth, yeah? The circle goes through Earth.
Yeah.
Okay. Circle can also go through.
I have a slight idea.
It was actually in my mental notes. It was like really obvious once you realize to consider where the intersection point would go. Okay. So the original line, yeah.
if you go parallel with the
If it does meet that intersection point, we now map onto the circle, right?
but it's on O, isn't it?
Yeah. Okay. Yeah. So if they do meet, right? The intersection point, okay, because if the intersection point will be on both lines, yeah. Yeah. If you think of it as being on that line, right? It should map to this circle. Okay. Does that make sense?
Yeah.
And if you think of it being in this line, right? It was mapped to the same line, right? If the line through O maps to itself, yeah. The circle and the so then it would have to map to an intersection of the circle and the line, right?
Yeah.
But it's tangent. So it's only at that point.
Okay. Yeah.
That makes sense? So that would be like there's no other. This can't go anywhere.
Oh,
Does that make sense?
yeah.
So if they intersect, right? The intersection point being on this.
I got it. That's so good. After the using angle chase. Oh, it's kind of weird. I didn't know what I'm gonna probably find out.
Actually, yeah. Never mind sitting there to a private school. Send him to a Catholic school. That would be the most fun.
What? No. I'm pledged my allegiance to Islam. I can't go to Catholic school because I practice Islam.
Okay.
I read the Quran.
So this point is on this circle, yeah?
Yeah.
So this line, so this point, because it's on this line, maps to this circle, yeah? This point, because it's on this line also, maps to this line, yeah? So therefore it maps to the intersection of this line and this circle, right? So therefore it maps to O, yeah?
Yeah.
And nothing maps to O.
The intersection maps to
I was thinking like the tangent and the circle that O doesn't exist.
Also, yeah, so the tangent, like, yeah, if you include O, then the tangent is at O. So the only point where this line meets the circle is O, right?
But if you don't include O, then it's like the circle
Yeah, so if you don't include O, they don't meet at all,
I
right?
don't mean at all.
So that three images means must not meet at all as well. So that's a proof without saying contradiction. So without O, they don't meet, right? So the images on the inversion must not meet.
Yeah. Because if you think of O,
then O is not inverted. Because obviously inversion preserves intersection.
why can't I just use simple angles?
yeah, what's the angle case for me?
Also, if you join the intersecting points of the two red circles and then you join them down, right? You split theta into alpha and beta. Use the angle ultimate segment theorem a few times, and then you prove back like this like small angle like you would do theta or something like that.
Probably works, huh? All right. Does that make sense?
Yeah.
So now the angle is preserved then. Because if they're parallel, they make the same angle, right? Okay. Oh, right. Yeah. So those two lines are parallel to these lines.
Yeah.
So they must intersect
Yeah.
at the same angle. Yeah. So it's kind of like a cool way to see it, right? Yeah. Like angle change, you see it, but it maybe not be cool.
So they're parallel because they can't animate it. They don't need it.
Yeah. Yeah. They're parallel because their images are parallel. Yeah. Okay. Well, yeah. So the two lines don't intersect because the images of two lines don't intersect. Yeah. Yeah. Okay. So I guess so. This is one of the cases out there, right? I guess being aware of the other cases is more or less the hard part, yeah. So like the worst thing we could do is like, oh, we proved the whole thing now. Yeah. Okay. Maybe the second worst thing would be to actually prove all the other things, depending on. But you kind of be aware of like there's a case where you start with the case where you start with the circles throw may already be done. You just do it backwards. There's all these other cases, right? Like you don't have to start with the line and go to the two circles. You can start with a circle and a line. Two lines that go through well. You know what I mean?
Yeah.
There's all those cases because of all the cases. But you're not really afraid of them, right? As long as you know about them. Because we kind of did this one. And we can't imagine the others would be that much harder. You know? The reader can easily see what changes are needed if A or B happen to pass through O.
Easily see.
Yeah, I mean, if they both pass through O, then they're just the same lines, right? When we invert them.
Yeah.
Okay.
Yeah.
Any two circles through P. I mean, I guess if you have the circles to begin with, I think you just have to reverse it to go back to the lines.
Wait, what?
So, yeah. So the claim is the angle is preserved under inversion. Okay. So maybe an important case is that when you actually have two circles that don't go through it. Yeah. What happens in that case?
What happens when you invert? What happens when you invert the circle?
Yeah. Good question.
With the other side, just entirely inside the area.
Yeah, like if it's totally outside, it'll go totally inside. Yeah, of the inverting stuff. Oh.
I read down the book somewhere, a circle passing through, not passing through, inverts another circle passing through. But I'm not sure that's a Python or
Yeah, it's another circle not passing through it.
yeah, okay. Then there's a bunch of
Because a whole circle outside of O has to have a whole image outside of O. If yeah, I guess like if you have two circles that don't intersect at O, right? They don't go through O. It's like if their tangent lines just map to something easy. If their tangent lines are still kind of something tangent to them, right? Then that'll be nice. Like if their tangent lines map to straight lines that are still tangent to the images, then you're done. Yeah. Because the tangent lines themselves falls on this case, yeah? The tangent lines are more likely to map into circles, right? But maybe the circles are also tangents. Like if you have two circles, right? Like if you have a circle and a tangent line, right? Yeah. That should map to two circles that are tangent to each other. Does that make sense? Yeah. Well, they have to touch each other, but they can't touch each other twice. Could be tangent, right? So that means the angle between the tangent circles should be the same as the angle between the tangent lines, right?
Yeah.
And the angles between the tangent circles should be the same as the angles between the original circles because they're tangent to the circles, so their tangent lines are the same, right? Yeah. There's a common tangent. So the angles are the same. I don't know. This is maybe a little bit hand wavy if we're all thinking about this differently. Does that make sense? Yeah.
wait, why is A prime equals R squared A to 1
Oh, we don't need that right now.
But I don't understand.
I think it was we just wrote down the definition and answered stuff.
Yeah. It's like,
The good thing is it's all recorded.
I forgot why we should separate something.
Oh, okay. Well, the good thing about that is like, it's kind of like, I mean, it was important too, but like the thing that you really want to remember out of that is the circles go to the circles. That's what it all led up to.
Yeah.
So like lemmas are the ones you want to know if you actually want to do something in that area. The theorems are the things you remember you want to use it for. The theorems are like the take-home message. The lemmas are like the proof, basically. Okay. Is that convincing?
Yeah.
So you have circles that don't go through it. Yeah. They're tangent lines. So they go to circles. Yeah. Their tangent lines intersect at their point of intersection, when you invert them, they become circles that intersect at both O and where the new circles intersect, right? So then the intersection at O has nothing to do with what's going on. You just draw it. So maybe you can imagine two circles, yeah? And these are the tangent lines, yeah? Okay? And they map to two other circles, yeah? Yeah. Okay. Tangent lines have now changed into something else. They've changed into these. So these two tangent lines have now turned into like, okay, I guess it depends what O is, okay?
Why is the inversion?
Somewhere. Maybe it should be outside.
Make it more clear.
Okay, maybe make O here, okay? And then these become like tangent circles that. Oh, maybe O is like here, so like this.
I'm going to steal the hazy one. I'm not interested in chocolate. I'm tearing this apart so I have to take all the hazy.
So tangent circles like that, yeah? Okay.
Ah, yes.
And then maybe I should draw the tangent circles in blue. The tangent circles like that.
Yeah.
Okay, and then like
They meet.
like that, yeah?
And you guys
And then meet at O, yeah?
Yeah.
Yeah? O is the inverted origin.
Where you're inverting.
The center of the inverting circle.
Oh, that way.
It's the one on the smaller diagram that's actually.
Oh, right.
Okay, so this is before,
So it's the same as.
Yeah.
Okay.
and this is the after, yeah?
Yes. Oh, wow, epic.
So the red circles map to the red circles, yeah?
And the penalized that.
And the tangent line at the top maps to the blue tangent circles.
Yeah.
But the before and after divider is not part of the circle. And then, so they intersect it, they go through O, the circles have to go through it, yeah? We know that. So that's like something not related to what's happening at the tangent, yeah? And then we also know that the angles between these two circles is theta, right? Yeah, from the previous case. Okay. So therefore the angle between the red circles is theta. Yeah. Yeah. Okay, so the angle here, right, is theta, yeah?
Yeah.
The angle here is theta,
Mhm.
yeah? Sorry, I should make this a red theta.
Oh, okay. Oh,
Like,
because
should I make it
intersect.
right here?
They intersect. Oh. Just preserve one thing what we call life.
Yeah. So the angle between the blue circles is the same as the angle between the red circles.
Yeah.
Right? Because the tangent lines are parallel, like the same.
Yeah.
Yeah. And the angle between the blue circles is equal to theta because it's the same as the angle between the red line, the red straight line. Yeah. Because we proved that before.
And like commentary. So
Yeah. So I mean, we haven't covered all the cases, but we're not far. Yeah. I don't think we are going to go through all of them. I think you can actually probably figure that out yourself. Yeah. So like the other cases, what is it? One of the lines goes through it. One of the circles goes through it. A circle and a line. Yeah. But then, like, if you think about it more, maybe some of these cases are really not different cases. Okay, but I think this is actually the one we need, so we probably should have thought about this one. So it actually explicitly states as a theorem, okay? If two circles intersect at an angle theta, then the inverses intersect at the same angle theta. Yeah? Yeah. It doesn't say anything about the inverses being circles. Okay. But we've covered both cases. Well, there's a combination of cases that we maybe not have covered. So what if one of the circles passes through O and the other one doesn't? Yeah. So yeah, as I was saying, like the hard part of these things is to realize that there are these cases. If you don't ever realize, you're never going. You just it's like I hate to use the exam analogy. You lose 3 points. Yeah? But like if you do realize the cases, they're probably simple to deal with. Okay. So here it's just realize there's a ton of cases. Maybe it's nice to realize that the cases all kind of unify somehow as well. There's not that many cases. Okay, and then orthogonal circles is when the theta is 90. Okay. Okay. Yeah. So that's the topic heading. So it's nice to finally define it. If theta is 90, then the tangent of one circle goes through the center of the other circle, right?
It also means perpendicular.
Yeah.
It's like intersection of like there's also like the prefix doesn't mean like perpendicular.
Probably, yeah. Ortho center.
Yeah.
That's ortho.
What do you say?
Ortho. He's asking what ortho means.
Orthodontist.
Orthodontist. What do they do?
Yes.
They make braces? Oh, they make this straight. They make your teeth 90 degrees to the gum.
Oh, right. Okay, sure. I think it makes sense
now.
Orthodox.
Yeah, it's funny. We just made all these things up so that they're all consistent.
I officially switched my allegiance to Orthodox Christianity.
Yeah,
What?
big then.
Okay.
I was Muslim back just like 5 minutes ago.
So by officially, you mean like very casually, insincerely.
I've pledged my beliefs to Scientology. I'll be living in LA in 1 week.
Okay.
That's fun.
Have fun buddy.
It's like you ideally want to say nothing, but it's hard. Or to say something that negates what was originally said, but that's impossible. Alright. Okay, so orthogonal circles invert into orthogonal circles. I guess this might have orthogonal circles invert into orthogonal circles. So before there was a previous chapter, they kind of abused the word circles by adding a point at infinity so that O would be able to invert somewhere. Yeah. And then they said that all circles invert circles. Because the lines now are a big circle.
Yeah, because the lines now meet.
So I don't know if they're just abusing that or they're saying something else. So orthogonal circles invert into orthogonal. I guess they're saying that. Okay. So almost there. Okay. Once we finish orthogonality, we're like ready to activate inversion powers. Okay. Invert our powers. Oh, okay. So this was something that I thought could have been a good reminder for you what the definition was. Like, it's like the power of a point, right? Yeah. So if you have a circle already, okay, and you have this is the center of the inverting circle, right? And you have this circle that happens to go through 2 inverted points. Yeah, like an inversion pair. Okay. Yeah.
We didn't like any circle.
Yeah. So yeah, you can always find a circle that does that. Okay. What's the claim about this? So I guess you have this tangent here, right? And that's a fixed point. Yeah. Then you have another tangent Yeah, right? That's a fixed point as well. So then the circle, right? Yeah. So that should be 9 degrees, yeah?
And the bottom of 9 degrees is cyclic. Hence it's a big circle.
Yeah, so what I'm trying to say is if you can get a circle that passes through 2 points which are pairs, right, the inversion, right? Then that circle is orthogonal to the inverting circle. Is that true? Wait, is that what I'm saying? Yeah, why can't we do that for like every circle?
That's a really sexy circle, if you ask me.
Well, am I saying something wrong here?
Shit, yeah.
Okay, there's some interesting properties of this, okay? So, can you see that circle? Let me call this circle omega, yeah? And then the original circle, what do we normally call the original circle? Do we have any names for that? We like gamma, okay? So omega inverts to itself.
You mean the sensor as like the sensor that like the sensor of the guys are thinking that.
Oh, okay. Yeah, but if it passes through, if it passes through, then like that, yeah, then.
So like think about where every point goes, right?
Every point goes to the other side.
Every point goes to
The other side, and then the tangents go to each other. Well, like it hangs on something.
so any circle that passes through 2 points that like it has an inversion pair on it, then all of them have to be inversion pairs.
Oh,
wait, why? Because of this, right? Because if you draw another, like if you want to find the inversion of this, right? Yeah. You just draw the line, right? And it's a power point, yeah.
Oh, power points is the same.
Yeah.
Oh, right. And that's how it's work.
It makes it complete.
Oh, so it's kind of like going backwards. There's power with the inversion. But now you're doing it like on
With another circle.
Oh, cool, yeah.
It's only something with that.
So OP times OP prime is equal to R squared, right?
And OQ times
OQ times OQ prime must be equal to R squared. Power point.
Yeah.
And, so the same with the tangent, yeah? But this point's fixed, so it must be on the circle, yeah?
Yeah, because
Oh yeah, so that's the point, yeah. Because it's on the circle, right? Yeah, that's the point of intersection where you calculate the angle. Okay. And if you calculate the angle, the tangent line passes through the origin, right? So that means it's orthogonal.
Oh yeah.
Yeah. So the theorem is anytime you have a circle, omega, okay, with one pair of inverted points on it, okay, then the whole circle is fixed by inversion, and it's orthogonal to the inverting circle. Okay. To gamma.
Oh, okay. I see.
Okay. Yeah, I think the converse is also true. What would the converse be?
So if you have a orthogonal circle, then
So if you had an orthogonal circle, yeah.
Orthogonal circle, then you need a pair, right?
No. So if you have the original gamma is inverted circle, right? If you took a circle that was orthogonal to gamma, yeah, then that should invert to itself.
Yeah.
In a tangent passes to the origin of those circles.
Huh?
Oh yeah, something
The claim, yeah. So any circle through 2 distinct points in inverses of each other is its own inverse and it's orthogonal to the inverting circle. Yeah, I think I named the circles wrong. Ignore those names. So I'm gonna get confused. All right. Conversely, every circle orthogonal to omega. Yeah, see, this is the point. Conversely, every circle orthogonal to the inverting circle. I'm just gonna paraphrase. Yeah. Is its own inverse.
Yeah.
Okay. Okay. For if it is intersects at a point, it's explaining that, but we see it already.
Yeah.
Okay. Okay. Moreover, if two circles orthogonal to the inverting circle, I'm gonna call the inverting circle omega. Okay. Alright, so if two circles orthogonal to the inverting circle or omega, then their common points are an inverse pair. So if two circles are orthogonal to omega, then the points at which those two circles intersect are inverse pairs.
He's ready.
So if you had another circle, yeah, these are inverse pairs. I think that's what it's saying.
Well,
Both the circles are orthogonal to the inverting circle.
well, wait, but isn't that just true? What? Isn't it like the fact that the inverse pairs is true because they that's how the circles work.
Okay, so you have three circles now, okay? You have your inverting circle, and then you have the two blue circles.
It's the inverting circle.
Yeah, it's the red omega. Yeah. And
I'm into
I think it's saying that these two points are inverse pairs.
Yeah, but
the point is, if you had any two circles, right?
Yeah.
The points of intersection might not even be in line with those. They have to be in line with those. That's the definition.
Yeah.
So you need it to be orthogonal to line up.
Oh, but then like if we know that orthogonal, don't we just know that?
Yeah, because you know the radical axis is perpendicular to the line joining the center.
Yeah.
It should be the same as what I'm saying.
Yeah.
But anyway, the point is, if they are orthogonal, right? You know that they're inverse pairs.
Yeah.
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 So. Did I even say anything?
Yeah, if they're orthogonal, then if they're like orthogonal, you know they're inverse pairs.
Because it's on the same line to
Yeah, so the tangent line should be parallel to the radical axis. Oh. No, I'm saying something stupid. Okay, but we know that like it has to be orientated correctly so that the radical axis passes through it. Oh, right?
Yeah.
Yeah. For that to happen. It just so happens it's when it's orthogonal. Yeah.
That's all pretty easy to generalize.
Yeah. Yeah. Okay. Okay. So this is the next interesting point. So these remarks enable us to redefine inversion. So this is why I was thinking this might be good for you, because if you didn't really have a definition, you could redefine it so you have a definition. So we can redefine inversion inversively. So we have the inversive definition. So in terms of orthogonality, okay? Yeah. So in terms of orthogonality, okay, this would be what the definition would read, okay? Let me just read it. Any point on omega, on the inverting circle, omega, yeah, is its own inverse, okay? So any point P on omega, then f of P equals P, yeah? The inverse of any other point is the second intersection of any two circles through P orthogonal to omega.
Second.
So if you have P here, right?
Oh yeah.
You need to just draw another circle.
So you pick an orthogonal like thing. You find an orthogonal circle passing through P, and you extend that.
And then you find the intersection, the other intersection, yeah?
Oh, but that's like the second.
Okay. Okay, so the reason this is called like the inversive definition, okay, is because in the same sense why reflection is like an inversive. I guess maybe I don't exactly know what it's trying to say, but maybe it's just trying to say it's an involution. Okay? Yeah. Well, in the same sense as in reflection. So the example they give, okay, is if you imagine that definition applied to, instead of a circle, a straight line. Okay? So we have a straight line. Yeah. And that was your omega, okay? And then you had a point P, right? Yeah. So then what does it mean to have an orthogonal? So what do we say? What was you have two orthogonal circles, yeah? What do we say? We have a circle. What did I say the definition was? The inverse of any point is the second intersection of any two circles through P orthogonal to omega, yeah? So yeah. So what's a circle through P orthogonal to the straight line, yeah?
Right.
It'd be like something tangent here, yeah?
Like tangent there, or is it tangent to it, or is it like perpendicular to it?
It's one.
It's having a sentence on the line.
Yeah, it has to be tangent.
Tangent.
Like,
Wait, what does it mean to be orthogonal to the line?
perpendicular to the line.
That means like a sentence on the surface.
So like if you take a circle, right? Like that, that's an orthogonal circle. Is it?
So it passes through that. Like,
Basically any circle where a sentence on.
Yeah. Does that make sense?
That is actually that's very epic. But what do they make second intersection? I'm confused.
So you take another circle. I mean, this is not the only circle you can have, right?
Yeah.
You can have like a big circle, couldn't you?
A big circle.
That, yeah.
Oh yeah, it looks like a big baby.
Yeah.
Looks like a big baby. That's a big complex.
And so they're saying the reflection would be here, yeah?
See, what? Why do you have to go through all this trouble? You just like
Oh yeah.
Because it's saying reflection and inversion are related, yeah? So if you change the circle to a line, like if the inverting circle becomes a straight line, then inversion is just reflection.
Oh,
That's
pretty good.
yeah. So in some sense, like the circle, you're inverting it, like you're reflecting it out of the circle.
Yeah.
Yeah? It's just the distances are all stuffed up.
Yeah.
It's kind of cool. I guess that's what they mean when they say inversive definition. So they say replacing omega by a line would reduce that reflection in a line may properly be regarded as a special case of inversion in a circle. Okay? It follows from the inversive definition of inversion that a circle and two inverse points inverts to another circle and two inverse points. We can combine inversive and Euclidean ideas in such a way as to discover how inversion affects the center of a circle. We might at first expect the centers to invert to centers, but that would be too simple. I mean, can you see why it's even a question? I mean, like, if you have the center of this blue circle here, right? Like, where does it go? Yeah, I guess the point is, you can't just think the circle doesn't come with the center, right? It's a circle, and the center is just another point that's not on the circle, right?
Yeah.
So it's not like circle plus center goes to circle plus center, right? Circle goes to circle, center, well, yeah. Center is inverted. Center has been inverted. So the claim is, okay, if we think of, so remember there was like a point at infinity?
Yeah.
It's a high.
Sometimes different. It's like a paper.
Oh.
Maybe this could be another exercise. But what's it trying to say? Saying the center of circle that you invert, right? Yeah. Goes to so if you have a circle alpha, okay, it gets inverted into alpha prime. So, yeah. And the center A, okay, where does it go? Well, it says A goes to where O would go if you were inverting with respect to alpha prime. Kind of a little bit complicated. It sounds complicated.
Oh, okay, I see.
So O goes to.
Wait, so that means the two centers, if you invert from either one, you put the same place.
This maybe on this notation.
Wait, so that means, so if you inverted with respect to two different circles, the centers would go to the same place.
Which
like if
so
you
if you
inverted
inverted
the circle,
if you inverted like O prime, A prime with respect to alpha, you mean?
if you like if you inverted,
yeah, they both go to O. Is that what you're saying?
Yeah, if they both go to the same center. The centers go to the same one.
They'll both go to O. Is that what you're saying?
Oh,
because this center. Oh, hold on. This center inverted with respect to the other circle goes to the image of O.
With respect to so circle,
and that center would go to the image of O under this circle.
Wait, so is it like the center of circle, like if you're inverting around circle 1, the center of circle 2 would go to where the center of circle 1 would go if you were inverted by the center of circle 2.
Yeah. Sounds right, yeah.
Yeah, so then like if you invert by either one, those they go to the same place.
I guess this would be like easier to probably just figure out yourself as opposed to trying to follow what you're saying. I mean, the question is very simple. Where does the center of a circle go?
Wait, why?
Why?
It seems that but why?
I guess we're up to the exercises section then. So maybe we can consider this as an exercise. And then we have a few exercises as well that are pretty interesting. Okay, let me just write down the first 3 exercises, and then maybe that could be part of an exercise too, okay? So the first 3 exercises. 1, so given a circle omega and an outside point A, yeah? Yeah. Construct the circle with center A orthogonal to omega. Okay. Question 2. Given a point omega and 2 non-inverse points P and Q, yeah?
Yeah.
P, Q, not inverse, yeah? Construct a circle through P and Q orthogonal to omega. So construct a circle non-inverse. And the circle is orthogonal to omega. Yeah? Okay. 3. Given a point P and 2 circles. Given a point P and 2 circles, omega 1 and omega 2, not passing through P, construct the circle through P orthogonal to both omega 1 and omega 2. 3, we have P. Not passing through P is not in omega 1 and omega 2, yeah? Construct circle through P. So find a circle orthogonal to both, okay? And then P is on it. Okay? Those are 3 questions. Oh, I have to take a little bit of break.
I have to get lost. What? I'm not.
I have a little bit of a headache and it kind of pulses in rhythm to your speech.
Saying the truth, I need a watch.
I feel like I should sue you for medical if I get brain dead.
Okay, sure, that's
Oh, it's going really funny. Oh,
Cool.
why is this so hard to fix?
Because you listen.
But like,
No, like, why you don't get what you're for?
no, but like, I can push with like anything else, but I can't push. Like, I can't push on something. Thank you. That's very hard. Oh God. Let's do it from here. Oh God. Python. Yeah. Yeah. Very nice. He's dead. He's dead. He's dead.
I don't know.
Of course. You're not going to record it.
No, I'm gonna play snacky like this. Hello there.
No continuing.
Hello there.
Oh. He's dead. He's dead.
Kind of. Okay, it's good enough.
Where you going? You want that one?
It doesn't know. But,
Two 60. That's like 4 more Chevys. I wonder
oh
who
shit,
the
no, no. Bye.
Yeah,
I don't feel like
yeah.
it on that.
He doesn't do that. He's not going to try to shoot you. Wow, he did. Wait,
Some water. I'll get water for you. I understand the potential energy.
Wait, that's a lot of damage.
I will pay for your brain.
Why did you do 1,000 at 5? I did 1,000 at 11. I did 1,000 at 11. What is now you know. When you play like 600 rugby, at this point, if you haven't killed anyone, there's still 7 people alive. There was 2 people there. Yeah, 2 boys.
What happened to the green? Like,
For other stuff. Oh yeah, just like the game.
I have a green that limits us to 3 circles. We have like a teal pen. It's just something like that.
How many orthogonal circles?
Infinite orthogonal circles. No.
I see that.
Yeah, but we can't just string a necklace around the circle. But yeah, so basically another word for orthogonal circle is invariance, right? Yeah, like invariance, see, like everything in the book and most things is like backwards, right? Introduce orthogonality, which just seems like some random condition, right?
Yeah.
But what it actually is, it's the thing that realizes the nice idea of invariance.
Yeah. Why would you play that? Why would you play that?
It's another big one.
Yeah, like if you actually did you go backwards, right? You'd be like, are there any invariants? Oh, these circles seem to be invariant.
I didn't characterize it as actually.
It's like, oh,
I see. You have yes. Well, he's talking to right? I see. He doesn't die. Yeah, he didn't die. It's not from actually, not see without the ball.
It's very fascinating.
Right.
That's a technical even the office.
Or did you whatever? Yeah.
The point.
Why would anyone with ball?
Any and that's it. That's it. Anything that's it.
You don't know.
That's it.
Oh yeah. Yeah, but
Technical is good.
but like, boom.
I haven't hit it once.
It's all the whole world.
It's
Well, you can run like well, do you guys have what time is it can do? Yeah, okay. No, how the hell I Rosa? Rosa. No, Rosa, so you have a shield as well. It's so sad for us to be fucking oh, you hit him. You did 100 damage in each shot. If you're dead, you're all you.
Live stream still on. Holy crap, the live stream's going for 6.5 hours. Dude.
I don't like it. Did you get it?
Dude, how long have I been asleep for? Oh, the season's been going on 6.5 hours.
Jordan.
Oh, you got it.
Oh, yes. Yes.
It worked.
Just come at me.
Come at me.
Come at me. Hello.
You can do that. Oh, yeah. There we go. Done. Right. Once you hit one more, you just go.
What are they? Why am I not hitting?
Alright. Just. Oh,
no, we said
hey, kid, this far off.
Oh, it doesn't.
Oh,
You just don't think he died for something. No.
oh, wait, he canceled it. He's genius.
Yes.
Oh, okay. Wait, you get points for it.
Holy, you're so tanky.
Well, okay, you can. Oh, and you can't spin on the. You can't spin on the.
Online.
You can spin on him. You dodge him. You got at him.
Like, you killed the most people so far.
Yeah.
Oh, yes. It's because they all try to
The thing is tanky as hell.
They all try to
The whole left.
You just don't see me die for some reason. How tanky are you?
where I'm the one. Yeah, exactly. So if I die, you're like, this isn't even good.
Right, that's not, yeah, right, that's not, this isn't as fun as you expected. That's
No, it's good.
yeah,
I'm good. Yes, show me, please.
No. You can't body die now, you can stop in combat.
Run.
I'm stupid. Fuck.
Oh.
No.
152, that's pretty good. Wait,
I got 2 points for you on season.
So the enemy spawn.
I think Jesse will be there.
Oh, and then the girl for something would be really like just like down and roll away every. Frank, super.
Ridiculous.
Oh, wait, holy.
It's supposed to be reminding of ridiculous today.
Oh, okay, yeah. It's been a while since I was.
How long do you think? I collect the coins.
So
I missed. I'm surprised the game isn't.
why do you get super? You get super. What's he doing?
I'm so surprised. Like, if the game is like so, there's so much like stuff like this. How is it not?
Okay.
Like, you know, like there's so many things going on at the same time. How does this thing not die?
Oh,
Yeah, again, how does it not? This is basically I magic after this workout. I wasn't doing it. They're both made by Congregate. Yes.
Oh.
Yeah, Congregate. So, you don't stop to I'm like, this game is kind of meaningless because, like, when you think about it, the monsters just keep getting tankier and you just need more damage. It's almost like it just gets weird. I'm pretty sure, like, you can get like 10 to 100. You get? Like the monsters hit points get to like 10 to 100. You do like 10 to 100.
It's already at 460. 460?
What?
My DPS. My DPS is.
Wait,
my tap damage is 7.1. My tap damage is 3.3.
The thing is, I think this game is balanced because like no matter where you are, it's always gonna be like, just as hard. It's like just as hard.
So it's half an hour till dinner. That's like time. Oh, is it enough time to expect? I don't know. Dinner counts as rest.
Alright.
So,
Yes.
I guess in the habits of things, I tend to work before.
Oh no,
Yeah.
400. I don't think that is 7.
When is my last?
You can't buy this guy.
Holy
I need a bit more money to buy that guy.
What do you mean big more money?
It's 4.121 times.
In this game, like scale doesn't matter.
I don't have that much. I only have 1. You only have half that much.
This scale doesn't even matter. This game. Scale just doesn't matter. This game at all.
I mean, what's like the best thing you can buy from the shop with jam?
Oh, yeah. Skins.
No,
I guess you buy. I guess you buy like.
You get like the promotions. When
like, is it better? Like, alright, so
Because I'm just saving up for like in case like before.
Yeah, I'm saying
I have like 150
yeah, like what is the value of buy? What do you want?
I think like the PowerPoint's the best.
I mean, graphics is so
good for it.
Yeah. I just need
Because like you know when you have the purple coins, right?
Oh yeah.
It's like you have the 1500 megabytes for the 500.
That's what it is.
Yeah. And I've always hesitated getting the big one.
Yeah.
It's like I get the megabyte. Like first of all, I never get enough purple tokens to be getting like both boxes every time. Yeah.
I mean, there's a boss every
I think I'm getting just enough to get a mega box.
At least one of
I always push like I can push like around 650. I can push that like 650. I can't be total 100.
Well, that gives you 100.
Like that gives me a bit more than 100, and then
That's fine.
yeah, and then
Wait,
it's like 60. I like.
Oh, that's not true.
I want the quick because you can send. And then like I would pick out of push like cult, and you can also try to get like 3 stars.
Oh, I want Cold to be powered 10 so I can play the boss fight.
Oh,
Boss fight is like my favorite game.
The same as I mentioned.
It's my purpose for playing boss fight.
Well, no, because I play I only play like True now.
It's like
I can't play anything else. Like, I don't like from having like anything else. You have teammates. Yeah, teammates like that, and then the other team also has teammates like that.
Yeah.
So now I only play True now, so I can push like I can push down like 650 on True now. Yeah.
My sister likes to.
I feel like boss fight is like the only truly cooperative side of the game.
Yeah.
Maybe Robo Rumble.
It's nice stuff.
Or like, have you seen the Robo Rumble Twitch? I thought of this, but people actually did it.
Yeah.
So like, if you have a map where there's like a part of the map you can't get to, the robots follow you there, and they can't get you.
Oh, okay.
And then it just gets stuck and you max out.
Oh,
Yeah, and it actually works. So like,
What do you mean?
you can
so
buy
like if there's a map with like a thick wall, for example, like, then because most people just care about the middle of the map, right?
Oh,
If they don't design the outside properly, like if there's a big thick wall, you just like El Primo jump into the middle.
Oh.
And then like the boss, the robots don't know what to do, so they just like
Oh,
yeah. So then you get like
yeah.
But then the sad thing is like it's like you get like 15 minutes or something, and you get like 30 tokens. It's like the same.
You bought one to buy mine and then done it somehow.
Oh yeah.
And then from there you can get more.
Yeah, I think that's probably better because you don't need like as big a.
Yeah.
You can just get a small gap.
Yeah.
But it doesn't break the wall, right?
The explosion.
How far can you jump?
That's like 800. There was a exploit for doing exactly this.
Yeah.
In one of the maps where basically you like two really two things, and then you just run towards a jumping pad.
Yeah.
Because you jump, and then you walk back and you keep jumping. Because in the air you regenerate like 1 tick. And then because in the air you don't take damage, right? So then that counts as the time it takes, and then once you get back, you get time like just like that's the jump flying time is not
It's
basically flat down. So then what you do is you just have two like boys just keep like jumping as well, and then like you can survive 15 seconds between the other your teammate also can also find something.
You never die, basically.
Yeah, so you don't die, and then like everyone else is just in the middle, and then at the end there's like a straight out time, and then there's that one other team in the middle just wondering like where your team is, and they start shooting the bushes and checking where you are, and then they get really confused, and
They end up getting killed by boys.
yeah,
Oh,
and then you don't die anymore.
so they need to face each other.
Oh no, so you keep using the same one.
Dude, like it's not fun anymore. There's no challenge. Whereas the code, the power. This is all about optimization.
It's so annoying.
I don't know.
I mean,
you never
ever get to when I ever get to one like it's how you actually somehow can't take your losses.
Like you can't even say what to do.
I'm not even power 9, so I don't get to start.
Yeah, power. You say that for when you get power.
Okay, for mine, like I got the like I saw a coal in my shop, so I just bought it, and then I passed out and realized it cost me 400 dollars. I didn't realize why. I now realized, oh wait, it just gets me all the way to power 9.
I want that for
Yeah, so I was power 8, and then like it gave me all the way to power 9. So then now like I didn't have enough those to upgrade it, but once I do it, I'll start happening.
Because I feel like Cold does have the highest PPM.
But then the stuff. I think 8 to 9 is higher.
15,000.
Yeah, so it's 8-bit.
I feel like 8-bit plus Cold kills boss so fast.
Yeah.
11,000.
They need to do it.
8-bit is like
Yeah.
30%.
around there.
30%.
Yeah, but it's like
Taking time like
it's
everyone
like
wants to-
But doesn't 8-bit only shoot like, or does it shoot
What
6
level are you
at a
on?
time?
6
8100.
Hey,
So you're gonna get
the Cold shoots 6.
No, I feel like in the Rumble,
you're
you have
gonna learn
400. 8-bit
Yeah.
I think he has the thing.
Oh, wait,
What's the
wait,
highest you played on the robot? I mean, big boss. Boss fight. Oh, no, no, boss fight, like insane. Yeah, like normal hard. We should like try and do something insane because it's like
No, but those you need like the balls. You need like the what do you call that?
you need teamwork.
You need like brawlers that's suitable to that as well. Because
Yeah.
like Jesse, I think he's fine with her, right?
You can Jesse power at 8.
Yeah, but my 8-bit's the power.
Jesse's
I can't
Jesse-
start it.
I don't know. Jesse's good for killing the minions,
Yeah.
but like the turret dies so fast. You need someone like I think in all the ones that we will do, they need one guy running around,
Okay.
like baiting the rockets, baiting everyone.
Yeah. Rico stuff.
So the one that they got up to like insane 16 was like they had a pan.
So it's like an ancient.
I think they had a pool or someone that ran around.
Oh yeah.
And then they had like a car.
I've got to upgrade.
Wait, what's the call?
So the Carl is the one like because Carl when you hit the wall, so it just bounces back. So they like tried to go. They got the boss stuck on the wall,
Oh.
and they just
Yeah,
Yeah, I did
that
that.
takes ages. But you gotta kind of kill it before it goes to God mode. It's like yes, like I mean, angry is okay. Furious, and then like insane. Like when it gets kind of white, that's when it's getting really annoying.
Yeah.
They start doing imbalance things.
The maybe the god somehow is pretty shit.
Oh, is it?
Yeah.
Yeah, but with cold and boss fight, it's purely like how much damage can I do per second problem. It's kind of nice.
Yeah.
Just relaxing. You just shoot and your bullets run out, you don't miss, and then you wait till it recharges.
Like there's no downside to what do you call that? It's healing and then you just fight that for some.
Yeah, so yeah, you gotta either do a lot of damage or you gotta be able to survive.
Yeah.
There's basically the two main.
It's like so annoying when you just
Hey, you know the cold super, right?
I'll show you the next one.
The cold super doesn't like
Yeah, there's one more.
You know how it goes through walls?
Yeah.
The cold super?
Yeah.
But it doesn't go through like if you have like this shit's 12 bullets, right?
Yeah.
I'm sure that 12 bullets don't make it through the wall.
So yeah, because I think breaking
Do you know how many friends you are?
A bullet.
like
Like it takes up a bullet to break a wall.
but I think maybe not one per wall, but
I mean,
But like
like,
those
those
bullets,
yeah.
ironically places.
On a computer.
Oh my god, on Steam or something?
Why?
Because it's unblocked. It's unblocked, right?
Oh my god.
And all my friends face like they're shooting on us.
Download Minecraft or something.
Yeah, it's down my
Oh yeah, a lot of my friends play Minecraft.
Download the VPN and then you access everything.
Everybody uses the
Right,
phone.
that's
I have a Mac, so that's why.
Oh yeah.
I mean, like, I used to have cracked Minecraft, but I kind of got some self-control, not a lot, and I started Minecraft itself. Minecraft, not good.
Yeah, see, you're clearly not playing Minecraft correctly, bro. Not even Minecraft, not even 100,000 cobblestone per hour.
You have this cover for so far, right?
Yeah, 1,000 per hour, 100,000 per hour.
Have you tried Skyblock? Me neither.
Wait, is it? Well, at the beginning, right? Yeah.
And even worse if you accidentally say.
But later, I guess better.
This is fun because
But always, if you want to build, you have to spend like an hour in front of a cobble generator.
Yeah. No, not really.
It's like
Not an
this.
hour.
Oh, you're getting some boxes.
I have heard about it. I have.
You just nice. I'm looking at level 4,000. Dude, you need to get this guy to level 8,000. Okay.
And then probably a lot more. Because it'll be ages before it gets to so
Yeah, exactly.
Wait. What? Oh, I see.
Level 8,000.
That's how we
these guys are let's go up to
Wait.
Oh no, it's 2,000.
I only take
Oh, you took it? Alright,
That is nothing.
Wait, that's 606.
Oh, you want to spin that.
500
Yeah, but you fast. He's fast.
And if you, like, every time you defeat a monster, the monster increases exponentially. I mean, maybe I'll see like much more specific. You need like think about like in terms of like actual money, that's quite a lot, like 10 times. Holy.
Yeah.
Imagine how many plotters in the way go well over time. And just like,
Wow.
you just like half a second.
They
Just
don't
goes, like,
come from
using
this.
like pieces of, like,
There's
minus
two.
one.
They don't see it.
Come on, there's
No, they're finding that.
Oh
yes,
Hello.
It's a crow. Wait, what crow did that work from? Just throw your thing.
No, so why did I say it? You know?
Oh,
Shit.
I've never.
You always got one shot.
But he's like way lower.
Two shot people with
I think
poker.
he's
That in
He's like 460.
Wait, I could do that. That's that bro.
That is not a lot.
Fuck, we're going to
Strats.
Oh, you hear
That is
that?
not cool, man. That's basically what he does.
There's
I don't know.
such up features to buy and have level and then you're set.
Yeah. Or you just get a friend to play.
It should be a click championship. It should be a click heroes championship. Heroes is basically like the #1 no skill game.
Oh god. We got the right game.
To you guys, either games generally in that no skill.
Yeah, idle games is
Well, yeah, that's because they're idle, right?
That's the point. Which is why I don't get why he plays it.
Like some games like the insane like some games like the last one they can be quite like crap tons.
We got a 1v1 potential.
Outside maybe
No!
when you make a game, you can't only make sure that it's not too easy, but you also have to make sure it's not too hard. Because if it's too hard,
I would
say, oh my god, you hacked it.
You understand how no skill this is,
Game
right?
so hard, I would kill you.
I mean, it's like, yeah, it's pretty much impossible not to get started. Oh, and it does that. Okay. So all you have to do is step forward.
Level 9 faster too. You're over 9,000.
Ah, right there, balance.
Well, the time is nearly up.
Good
You'll
idea.
get to level 10, 11,000 basically. Like that.
Yeah,
No one is getting that. Is kind of sad.
no one always likes the sound.
I could also try that. I can get 22 souls from that. Ancient souls.
And I got the
Yeah,
next
very
level one.
fair amount.
Yeah,
Oh,
no.
Do something.
What?
They
The
like
cow
how
is still alive. It's what?
Imagine.
Alright, yeah, alright. He has to die though. Alright, there we go. Okay. We kill these. Oh wait, that's a wall. Ah. Wait, this is pretty okay. What's he doing? Okay, one. Right. Alright, now we don't lose because I'm like. Alright, what I have to do is just get them to leave and get my kill off. Alright. Wow. Now we go. Oh. Well, surely photo with juice is pretty.
Basically, the only games people
I don't
want to
want
play
to
are
play
like all sorts of the full math games. Anything that's like full math games all day.
I play Factory.
What? But then my school's pretty trash, so yeah. I have a friend who plays Minecraft. I have a PD teacher or something against Minecraft because like I'm pretty sure on the first day he's like, hey, do any of you guys here play computer games? And like basically all of us raise our hands. And like he asked, does anyone here play Minecraft? And like no one raised their hands. So like he's like, great, I don't like Minecraft.
Wait, what is this? Bro.
He roasted Minecraft.
What is this? What is this? Hey, that's real.
I'm offended. He roasted Minecraft.
Cannot just roast Minecraft.
He just offended Minecraft.
Bro.
He offended the 9-year-old.
They don't. Okay. He's trying to game.
No. No, every 9-year-old in the
Is it your phone?
world is going, oh,
Do you have your own phone?
My phone. I don't play on my phone. It's bad.
oh, hazelnut.
Bro.
I love hazelnut. I'll only eat hazelnut.
Because I can work.
No.
Tablet? Oh yeah. I can play better on tablet.
No.
Hey, did you guys play that Brawl Stars challenge thing that came up
Challenge.
twice? It came up twice.
But you know what's bad? It's like they force you to play 3v3.
Right.
Oh, because it forced you to play all the game modes.
Yeah, like they force you to go to puzzles.
I think you gotta know.
Wait, why did I not get this?
No, because I think you just gotta organize a team. Like,
But I don't have any friends.
Okay, we're doing damage.
because I think me
I
and
think
Lisa
so.
made a team, but we need still need the third player. It's
Yeah.
crucial.
6 hours 52
I'm still not
minutes.
gonna
Holy crap.
Okay, I'm about to do 1,000.
6 hours and 52
Yep.
minutes.
Alright.
You can now destroy a bomb 6
How long have I stepped for?
See,
Like the complex actually.
Not that long.
Like 30 minutes.
What was the first thing you saw?
Like pretty much like full whiteboard. And like
Was there
about
red on it?
maybe.
Was there like
Yeah.
a blue triangle on it?
No.
Like on the right. Oh,
No.
break 7.
Okay.
Break
so we-
You mentioned something about productivity and I kind of woke up. But like, am I the only one who was asleep? Was it everybody else?
Sean fell asleep at some point.
No,
Beginning,
no,
beginning.
in the functions. Triangle function finds and I will call it the triangle function.
Alright, surely I win this.
I woke I slept at 4 last night, so yeah.
Four.
I remember like it happened.
Yeah, what do you mean last night? This is not the
It's really funny, like,
I mean,
we're
last morning. I
We're
correct
at this
correct
conference,
last morning.
and we had this professor who was like one of the leaders of the conference, and he's like notorious for like he's like he's the guy who actually reads your thesis.
Oh,
Holy.
You know what I mean? Like most
I've
people
seen
just kind of be like, yeah,
some
whatever.
words.
Yeah, it's like, oh, I didn't know.
Like,
Yeah,
and
and he
like
actually reads it. Okay.
20,000 words.
So I sent it to him like maybe 40 times. Okay, and it came back with like typos corrected. Okay. So like,
This guy's OCD.
so someone who does that cannot be sleeping 8 hours a day. This is just impossible. Okay. So he's a little bit OCD. Okay.
It's kind of weird. The longest I've
So at the conference, like suffice to say, he fell asleep.
It's like nothing.
Is it a poker?
And it was kind of funny
No.
because like
He's a poker.
he's
No,
sitting in this position.
Yeah,
and
exactly.
every time he dozes off, he hits his head on the table behind him, and then he falls a bit, and then he goes off again and hits it. It was like I don't know if it was painful, but he just kept doing it for like an hour.
Is he old?
And then I got his jumper and I put it behind his head. And the jumper kind of pushed in his wall.
Oh, yeah, it's all right.
So he still
Don't
kind of
worry.
did it, but like it
We'll make the
didn't
best
make
of
a
it.
sound.
Pretty sure the shortest I've ever slept for was like 2 hours, and like that record was like yesterday.
Oh, you?
Oh.
Yeah, I slept at 4, woke up at like 6 or 7. Wait,
No, I-
It's so late. I mean, I'm guilty of this myself. But
I'm an insane night owl. I don't know why, but like my thing's getting once like every year. Maybe like 2 years ago, like the latest I slept was 2 o'clock. Then like last it was like 3, and now it's like 4.
no.
yeah, so I was like lying in bed, okay, and basically I'm like stuck between thinking about the functional equation problem
Oh, yeah.
and checking coronavirus updates.
Yeah, that's what
the
I
most
do.
depressing thing. And then afterwards, I solved both problems. The coronavirus data is all false. It's just BS.
I know,
You-
right?
you know
a lot of
what?
people
You
are so
know how-
paranoid. Like, even like,
official one.
Yeah,
Yeah, there's no fucking way.
totally BS.
What is it? Like,
Wait,
you know,
wait,
10K,
why-
that's still too little.
Yeah, like they have, the data makes you think it's just like an ordinary flu, and it's like a nice flu.
Yeah.
but people think it's like plague dog.
And then they compare it to SARS, and then you look at the data for SARS, and that's gotta be fabricated. Like, there's no way it's not fabricated. It's like every other country, 17% death rate. China, 6.6% death rate.
There's
And then the final,
This
as
is
average
like
is
entire
10%.
province in China where there's no deaths. But in Hong Kong, there's like 17 cases and
Yeah.
1 death.
Like, they all died before
Yeah.
they even tallied them, you know?
Yeah.
It's basically plague.inc more than 2 or 1. Guys, coronavirus is very bad. Let's all move to green standard. Because what one thing plague.inc told me is like Greenland cannot be infected.
Oh, man. But yeah, like, it was funny because it was almost like people's overreactions are like maybe they know the secret truth, you know? It's like the data should not cause them to react like this, but they're reacting as if like they saw the real data.
But like it's like it is quite exponential because like it used to be like quite
It's
small.
supposed to be
like,
exponential. Like they're saying that the exponential infectious rate is like 4 or something.
Like it's I'm like that's why because it's exponential. That's why we charge 1,000 one day.
But then they guess like
Yeah, we're gonna die.
so originally they were
Oh,
guessing the death
moved
rate
to
was
Madagascar because Madagascar
But
has
now
only
it's
one
like
seaport.
yeah.
Yeah, and I was like,
Guys moved to Madagascar. It only has one seaport called to Lake Bucky. And since and because of that, Madagascar can't be affected. Yeah, they moved to Madagascar.
Try Fine.
Guys, I'm moving to Madagascar. I'll see you guys later. Yeah.
I think if after dinner I'll just talk about exercise too.
Okay. Where like which is non.
Yeah. It's probably the coolest.
I started not killing them, but then I so good again.
So it'd be really cool if we can find a nice problem to solve this.
It's like
Put it
the
on
shoemakers power. That's it.
Inversion.
Yeah, and then we have a complex. We want to. I don't know if fully complex batch is a thing, but that's still on our hit list.
It didn't sing to
Yeah, Singh did a complex batch with that AM.
Oh, he did. Yeah, good try that. Oh, I thought it was good.
No, not this year.
Was it fuck you? Was it the 14-sided?
Oh,
Was that?
Wait, you seen that question?
on 9 degrees.
Wait, no, 3 diamonds. Something like that.
Oh no, he did that one with a nice one. He did the auto center one.
Oh, okay.
Oh, that was pretty cool. But you could.
You can't help that dispassion. So you use the roots of unity. Right? It's like it's a perfect circle, making a new circle, roots of unity.
I do. It's like
But it was
two.
kind of nice because we did regular pen like polygons, and you could just angle change to show that they were perpendicular. And then it's the opposite.
Sure though.
So
Some point messes up.
we'll scratch this one.
Sure.
Hello, come back.
Oh,
Yes. Oh, wait, what? What? Hang on, how's he on the wall?
So he
Yeah,
seems
he's
to have
genius.
pretty good rigor, you know. When he writes for like the solutions, he like actually writes it pretty rigorously once you get good enough. It's just that he doesn't do maths enough. That's the problem. He writes the last second.
Doesn't he like do schoolwork? Yeah, he does schoolwork very well.
But I mean, in some sense, like the schools, like I mean, like if you're like 15, 16 years old, how are you meant to know what? Like you have to trust your school, right?
Yeah.
And the school just stands you.
Yeah.
Yeah. So you're just like,
Oh, 6800.
No,
Just upgrade one more.
Oh, hello, comment.
Just upgrade one more. Then upgrade one more.
I need to upgrade.
You want to upgrade? You want to go past 6900?
Oh yeah.
yes.
So
No,
6900.
Okay, yeah.
Like I was, I'm joking with them now.
Maximum
Oh,
oh, that's a
I
lot.
upgraded
That was one. Calm
6900.
down, calm down, calm down. You do 6K. You do 6K.
I take a screenshot. I take a screenshot. 6 months a second.
Yeah, guys, the ways you can contribute, if I upload this to like YouTube or something unlisted, ways that you can contribute is like if you watch any part of the video and like because there's basically like 4-hour blocks of nothing happening.
Yeah.
So if something interesting happens,
Oh yeah, we can bookmark it.
bookmark it.
Put
So it'll like comment.
I'm like, this live stream is unique. It's basically like a vlog, like a vlog, right?
As a vlog for David's comments.
Yeah, true.
Not vlog.
Most like us eating food.
It's kind of funny, like they do the censorship thing in China, right?
Yeah.
But the news thing here is like it's not the opposite of censorship.
Wait, why is this guy
It's
water?
like the news, the purpose of the news is just to make people angry.
Yeah.
It's like it's the opposite of censorship.
I was like, the media is like trying to make us triggered.
They kill like a doctor who warned people.
Yeah.
Apparently, like,
Wait, so was it the disease that killed him or the people?
Well, they claim it's a disease.
Yeah. It's
Well,
like,
you got possibly.
yeah, it's like if it was the disease, then the disease having like a 2% death rate would have been statistically significant evidence against it being a disease. So then they have to like increase the death rate to make it more plausible.
Why not? You know what? I have to go.
I7.
Is this game playing
You're almost
itself?
at a level 11.
Yeah.
It's actually bad.
It's like passive investing. That's like the best kind of game.
Just gonna play it.
And I was like, when I was in the US, I was like, I used to play all these games. Right? And then I went to the US, I was like, I'm pretty time to start, right? So like, how can I save time? But I have gaming addiction. So like, I'll watch videos of other people playing the games, and I can just fast forward them. So I can get through the whole RPG in like 20 minutes. It's like, you have to care about none of it. Maybe this point, this point, this point.
Walking. Basically, every game is, you know, uplifts like
What is that? A lot of it is just like mindless leveling up.
But if it's like a game with an end, right, you're basically just walking a walk.
When I was young, I was like, wasted so much time playing Pokemon. I don't know if you remember that. In primary school, like year 6, I spent like the whole year playing Pokemon.
What? Are you sure? You said you were year 6, 996.
No, I came to Australia.
What? How? Like,
I was 6 years old.
How many people like? So like what year? So like about 1990. So you're 6 years old. Let's see. You should be 11 years old in year 6. Which means you were year 6 in 1998, and you said you went to very far, right? Wow. Welcome to the Murray from Alu Money Squad.
So that's why he didn't lie around David. He just pieces it together. He's like, sure.
Wait, how did I not pick that?
Those shits show.
It's not good. It's kind of
Welcome to the most
Sometimes
island
it
my
then
school.
drops out, and it's not the drop.
It's on you away. Our school model changed from a great place
Oh,
to
what's
be
it dropped
to
out?
respect responsibility.
Oh yeah,
See,
I
but just not
I
that big to
predicted it
know.
coming, and I just got that run.
Respect responsibility and personal best.
The responsibility as a motto for primary
That guy
schools
did a big
is a bit of a stretch.
Yeah,
I
true.
must admit.
I'm not gonna lie, that's kind of like why? I'm kind of like
The Singapore, they have the civil, it's called respect, responsibility, companionship, camaraderie, or something. It's like boom.
when you want more
Humbleness or honesty or something.
Like together calls we use together.
I don't even
Right,
know
what?
Oh, whatever. So basically, we used to have like this Star Wars the other card thingy, and then the next one like the respect, responsibility, and personal best like cards, right? And you put the
I'm gonna
and you
get
teach you get
No.
you sign your name, you sign that name, you put it in a jar.
Ah,
and every week they like you a draw, right? And like if you got drawn out, you get a.
Why are there so poor people?
Like the gifts or free shit.
I don't know. The
Like usually, I once got a soccer ball, I lost like
the topic.
Yeah, you don't get in the air as well.
told you that the free gifts was shit.
I remember that Murray Farm. I remember like in Christian studies we always have free time and I always play chess against the same guy. It pisses me off so much. Because it always does this opening. He pushes the like you put king pawn, he goes queen pawn. You take the pawn, right? And his queen comes out. And then he loses all the tempo and loses all these pieces. And I'm just on tilt this whole time. And then somehow like you could like end up with a comeback sometimes.
This guy's probably insane.
This is something that
Christian studies. You want
You
to
think with a big-
You want to scripture. You want to
I went to non-scripture and Catholic studies.
I just want to hear
Weird
this
polarized.
Catholic stuff.
I was serious.
When I used to be
And the Catholic studies teacher was also our table tennis in high school.
It was probably preaching messages
You know-
for teaching you God gifted us with table tennis. You should respect table tennis.
Respect this guy.
Oh no, you're up to your tipping point. This is not good.
Oh wait, no, I you're 3/4 of the way there. Huh? 3/4 of the way there.
You're basically up to your tipping point.
I'm about to hit my hit the wall
Oh yeah.
in terms of
Like,
one-shopping the monsters.
yeah,
Yeah.
true. He's got like.
Have you got any stuff tokens left to get there?
Everything's gone.
I'll bring games out. Lately, I've been doing 20 tickets at a time.
Yeah, same.
Because I got a token doubler.
Oh,
So I did the 20 tickets.
my friend, he had like 200 tokens. He had the token doubler, and he had extending. He got like 40 boxes in one night.
40?
Yeah, 40.
Oh. Yeah, get 8 at a time.
Why? Hey, my son. What?
Sorry.
I don't know.
Everyone in the past in my family have been scoring 8 years ago.
Yeah, we had a good year.
It's the
Yeah,
Like, when I was not like, I didn't even know what like less than equals meant.
APSMO. Like,
I didn't join
NPS
the whole
somewhere.
APS.
What's
in primary school, did anyone from my home get like 4 marks?
Pretty sure we had
Well, I know someone who
Yeah.
did that.
My farm was pretty trash. Like, we didn't get one like perfect
Like
score.
when I went to Murray Farm was like the best.
Yeah, when I started, we had one of those years ago. And like, they got like shit somewhere around like, yes, we
What's it even
He thinks he can beat me.
Like,
Right.
even like the softball team was like the state softball team.
And like, for some reason, like, we had this new principal who just really didn't care about our education at all. He basically changed the model from as a great place to be to respect responsibility and personal best.
Right, he does.
I think
Oh,
it's weird.
no.
I was like, really? Why?
Run!
They're like the 3 of the
Run!
best.
No. If I scrap
Like-
it,
I think they're virtues
Oh, wait.
for adults. Like
hang on.
it's because like as kids,
Oh, no.
if you're too worried about one of those things, you kind of stunt.
Oh,
He
really?
didn't fight value.
Even like,
Yeah, but that's what I mean. Like it's like how can you
Yeah,
expect a
one
kid to really be too responsible?
Is
What
it
does
really like,
responsibility even mean? How would you
Oh,
define
yeah.
it?
it's like all my old friends transferred to my school, and you can basically telling me stuff about my old friends, and apparently like more than half of them are starting to do drugs.
That's great.
I don't know, like half of my old primary school friends are only doing drugs.
That's
Oh,
great.
I'm also doing drugs, and you can't outdoors drugs, but
I think you guys are still pretty young. I'm old enough that some of my primary school people and high school have already died.
Pretty sure like some of them
That happens.
Natural
Yeah,
causes. Someone from my primary school passed away like because of car crash.
actually is that.
Yeah, it happens. Like,
That's the case.
Like my classmate.
yeah.
Wait, I'm surprised. No one from my time is anyone in my class is died.
Well, yeah, you gotta let it up.
I think it's not that common. So, like when you get old enough, it just eventually happens.
Well, maybe if you count like technically,
Like if you go another 100 years, they're all dead. You know?
Yeah. And typos.
So this post where
going to primary
the
school, high
grandma-
school, I
she has
basically
this
died on
stuff
the inside
of
or on the
friends.
outside.
and then when they die, she puts it out.
That's like
That's like a hit list.
I'm technically dead on the inside, so I don't know if that counts.
it's as if she's killing.
Yeah,
No, I'm not missing it.
because it's close.
Wow.
Close.
Wait, at least my mom doesn't suck anymore because like we got like this e-house and this piano education and stuff.
Oh,
Do
yeah.
you still really calculate carnival?
Well, I've been there to design like once.
I should revisit sometime because I have like this urge friend like we tell me I should visit.
It's weird though, like with public schools, I feel like when your year goes, like the culture like of the school at that time goes with it.
Yeah.
Because like when our school, our year went, like all the teachers basically retired.
Really?
Like most of them, and then like it was just like two people.
I miss it.
Because the weird thing is like for the 6 years I went to Red Farm, like every one of these years like it rained on the kind of carnival, so it was always like quite a depressing and stuff. In years 1 year, 2 year, 3 year, 4 year, 5 year, 6, it always happens to rain on that day for some stupid retarded reason. And, like I mean at least my carnival was actually somewhat
It's
decent.
like how can I be respect responsibility?
That's not
This happening every year.
At least they actually like put effort into making it crack all these sick bumper classes and like bouncing classes and stuff. I'm actually impressed.
Cool, that's not bad.
It's somehow.
In our school, we only have like multicultural food, which is pretty good, but just like not as amazing. Like the thing is, people in my school don't like no one like people in my school they don't even respect their own teachers because like basically people in my school talk shit about teachers. I'm not joking.
But like that happens in every.
That happens in every school.
Yeah, but
It's pretty much expected.
but my school like just doesn't look a lot.
No. My school is like if a teacher doesn't let you use a computer in class and play Minecraft, it's bad.
Yeah, pretty much.
No, that's like the stupid thing.
Oh, no,
And the
no.
smart people, if the teacher lets the students go in the computer and play Minecraft, they're bad. And
What?
then there's always some.
What? No. Okay, no. Our school is just like if they don't teach, they're bad. But
No, but there's people who want to just play games.
no, even like
You know how extreme people at school are. So, you know, like this kid from my class. Like,
why is he not
in
there?
the first week, he went to the prince, like he went to like the guy who like organizes like these
He
subjects
will
and
die.
stuff. He told him he wants to switch
He
classes.
might die.
You know why? He doesn't
Why?
like the
Why?
English teacher. So he said, I don't like the English teacher. I want to switch classes. But it seems like he's in the same English class as the people in science class and the PD class. So it has like his schedule is
No.
And then when like on the first day, like, I was hanging out with my friends. My friends already told me shit about their own teachers. I don't even know why.
You're in
It's actually insane how like
Where's he going?
people are so
Well, I mean, if you take that to the national scale, that's like what the US is. It's 100 people
Like it's,
hanging about.
no, like our teachers who teach.
So fines that talk
even
that's cheap
most
on
of
my
the
own
teachers who
just
teach,
most of my friends do.
generally teachers
Yes, really.
like at least like some teachers are
Behind their back, you just do it all in front of them.
basically like
Because I'm not that
if they teach as a child, they're very good.
Yeah. That's what the smart people think.
Yeah, but then like if they teach and they let you go, that's like even better.
It's just like
But if they teach and they're chill,
and like a lot of people say things kind of
most of the time they can't be chill because people are like,
it's like we're talking about
Yeah. No, by chill you mean like by chill it's
I don't even know why. Why do you?
Oh god, oh god.
Like,
When you seems like such a
Yeah,
just
what
oh
do you-
no,
Oh, okay, sure.
Wow,
she doesn't say anything bad. But like they do when
Really?
He's actually just more slightly more retarded than most.
That would have been both of them.
He didn't play. He didn't come on.
Like they,
It's like on Friday. Yeah, but he didn't come today.
like even the people at that pro view were talking like,
About 6.
they generally quiet.
What is that
They generally quiet when they like,
I do tennis.
if they do like,
Oh,
English study.
I don't know about this.
No, I'm
I do
referring
like
to we're just like top practice.
Sport is dodgy. It's always
Oh. We don't
Yeah,
know.
that's how I like it.
This was yeah. I was gonna slightly better.
Yeah, Edmonds can't get out of this thing either. One of the private school trips. One of the private school things. Imagine going to private school.
Imagine.
Yeah, I don't know. Where will I send my kids? Go send them to Murray Farm. It's actually somewhat decent. Primary school is already kind of. I'm done with primary school. But primary school's actually not that bad. Just go to Murray Farm. Do
you think it's reasonable to go to a school in year 7 and change? Because that's like a weird, like you're in a weird stream.
Yeah.
It's kind of like
But you don't like you go just for yourself.
yeah.
Oh, I'm pretty sure like one of my
One of my friends
who went to James first. One of my friends told me like he went to like Japan, and he never came back.
That sounds great. There was one person that came to me and like, our sole purpose is to go to campus and it's like we don't like our current school. I'm like, what school is that?
I'm not getting James first.
Take it.
Dumb shit.
Like, I'll take it.
Like,
hello there.
like the year 7 mentality is I want to be the very best. I want to gain James first. But after like 2 years, your mentality is I don't care if I get like 7 B's and like 1 A.
Honestly, so when I went back to Singapore, I think I had like because there's this test that you take in year 3 to go to the gifted thing. Yeah. So I just went to
Oh, yeah,
for year 3.
Oh,
OC for year 3.
Just to, I mean,
I
I
mean,
can't
we
get
should
into
get
it. I'm getting
Look
good
at
at
this.
school, right?
Look at this.
Yeah, just for guys.
I'm not one of oh god, yes.
I know this is looking into a tipping point. That's actually good.
Most of the time now. He wins.
Fun,
Easy. Leon's broken. Yes, you don't lose this. You cannot lose this with Leon.
Come on, you better get that 1 like 10 to the 1,000.
No, he's a 9.
Yeah.
He's like on 9 or 10.
Oh. What are you guys playing right now?
Oh, you want to join?
Maybe I can join, but I'm not that good.
It's okay.
What's the what kind of level is what
I think it's like 500 bucks legendary pound 6.
well you still have
Legendary pound 6.
I got one.
It's like 500.
how do I join?
Come on, 4 hands, 4 fingers, 4 fingers.
So you're playing with 500 trophies
Come on.
Yeah, I guess.
using
I'm using my
Oh
phone.
my
I'm
God.
using Leon, so.
Jesus.
Leon.
Yeah, he's using Leon.
I think it's gonna be I use Leon. I like
You need to go,
Right,
I know. I know.
Transcend.
You basically have no choice.
Oh, I have like stars on this
I could also ascend instead.
Go!
I think I'll transcend.
What's the difference between that?
Look how many shots I hit. Transcending is just ascending, but you die tons more.
Yeah.
Yeah.
And you lose everything.
You lose the stuff you get from ascending.
I gotta jump.
From transcending, which is like stuff you get from ascending. Oh, so,
Wow.
but also you start like jumping again from the extreme. bottom. Yeah. And
Like, that's
not
another
just
one.
like the not just the half bottom.
You usually don't have a
You jump really close to the ends, yeah?
Yeah.
She doesn't kill the bubble.
I want to say that.
Oh yeah. Doing
Sure.
Wait, how many do I get from this? 334.
You just pay for it. Oh,
this game looks funny.
What do you do?
Oh my god, the glitch.
That's a root. This is stage 1 now.
Yeah.
This is stage 1.
Yeah.
What's the first
I
one?
play one game and then
Okay. What? Oh, you take it. What to get? Carnival. Wait, that's a lot. Yeah. Oh wait,
What? I would have printed solid. Not really.
wait, hang on.
Wait,
What?
do I have it, my friend?
Wait, how do you get
Yeah,
that?
I can add you.
Why does that so
You the
Why is the
Oh,
percentage
okay.
change?
Why does everyone
Oh,
else
that's not high. Up and down. Well, why was I?
Huh?
What
That's
was
what I was clearly superior.
it's just like
I think most of us is to get control and how to unlocking
What's
class.
that? That's
I couldn't even play games on my
effective
phone.
assault. Your
Oh, what? There's two guys.
Okay. How many of those you get?
World War.
Yes. You just said you'll get more because even the door is strength check.
We have Daryl, which is the best World War in the world.
Frank.
Frank, the wall breaker.
Yes. I don't know what's on it.
Yeah. Last time we had a game. I think it was when Frank, Rose, and Shelby.
Just start getting the ball and walking out. And when one dies, just
Somehow, neither team scored. Neither team scored a single time, even in overtime. What? Yeah.
Okay.
Okay. 37. I do. Yeah, I do. No. Are you done? No, I wouldn't practice. Although, like, when I'm not in the app, they don't do anything. Yeah, because then the thing is that if it is like, I mean, okay. Okay, and then I did it basically. What?
Oh, what?
Oh, yeah.
No, we all died.
I go on like here. Ooh.
It's taking forever.
Yeah, I'm level 11, man. Speed. Speed.
Yes, we speed.
As long as
Let's get the sound once. The
graphics are kind of disgusting because you can see a death spike, you can see like
No!
remains. It really like creeps you out. I swear you got, but like this game is encouraging people to eat dogs. It's like maybe you should make the dog remakes actually look somewhat appetizing so people start eating it.
Yeah, man.
Yeah, man.
I guess. Oh, that's true now.
Because he's
Alright,
not
get it
getting
time.
Then it's like, alright. That was done.
I'm going to eat.
Oh. Like, I think like every time the student resets,
That's
people
so much.
try to go on and like, and then say like 4 seconds pause or something, right? And it's not like, it doesn't even have to be like,
Why do people have egg space? It's such a weird angle.
Yeah, like right now it's not like that.
I can only tell like once a year. But yeah, that's pretty much right.
Oh, yeah, I think
Estimating vertical height is a weakness.
I gotta like
Okay, I'm funny. Okay. I can't be yeah. Yes.
we can have
I think so. You ask that. Guess not fair. I don't keep on. We should be able to we should go today. Like we should agree from the I'm going to get my life on my mind for 2 hours. Yeah. Hour. It's the same thing. Checking it highly safe.
like high cross.
Like it's like yeah, 60, I don't know.
Right? I could be able to figure out. If you yeah.
Yeah, you definitely talk about that. They're definitely right. Yeah. Sure. I'm not going to see how far to jump. How far to like you just say something. You say something. But you have colors on like. That doesn't count. Actually, well, how much is it? You see, like, that is definitely. And it's small one meter. I think we're missing one. We need you're the right combination of speed and soreness. We need the other.
I probably like walked up this.
Wait, but he's not an age group. He doesn't have any age group. It's like 2001. Like younger. 3 years long. Yeah. I'm super cool. You want to join my boss? You want to have the right combination of strength, speed. Yeah, but my combination of strength is even small. We need someone like us. Then what else is stupid? I don't know. What we need another strategy. Yeah, but people like I want a small speed. Yeah, people not going to. I don't know. I don't know why. Yeah, I wonder why. Yeah. Couldn't be that all that I did. Yeah, so I'm very nuts. According to the thing on like the average athlete for like 60 years old, just like 18.6 inches. That's like it's like that's like no, it's 25. 20 would be. No, it's 52. But that's not.
We always try to take as many people as we can. But it's probably thinking wrong with these. Yeah, they didn't do that. They sit out of the half, like they take a half like they don't eat it. What is that? You like 68. Look, 40 there's another side of this table there. Like you make this a square table. That is not that's pretty good. That is not. That's pretty good. The biggest game is like my bigger. Yeah, exactly. You don't get you don't buy it. The biggest piece like yeah, it's like if you should somebody made like a huge long pizza, it's not being you buy it. But the biggest commercially available pizza still. I mean, like people are just mental making basic things. I'm pretty sure I sound like some of the making American 60s one and not fossils. So really big thing. And when you my own people. It's like 3 months. My wheel was not long. I would have been worried about my enemies. Because I was out there. Well, they are here. Now they are here. They found my I think how about that? Not the team even man come back to the 60s one of very small. Now the numbers of it, the thickness. Really bad. Russian alphabet is really similar to Russian alphabet. Actually, that's Russian alphabet. So some of the factors are there. Chinese. That is not connected to it. Doesn't matter. Well, I've seen the boys on I mean, Malaysia, they are Malaysians in Singapore. Oh, yeah, true, they are. We should have a lot of Malaysians on Singapore. It's just a sizable police. Yeah, sure. Because like the most common name in my grade, the most common surname is mine. And one of my good friends is like everything. Well, statistically, I mean, like you have good boss. You can check this. What's the most common names that I know boss. I give him a watch. And then last usually like it's in my friend, where his name is Muhammad Ali Akbar. Like on the first day of mine at school, like I feel like his name was born off of something right. Maybe I was like this kind of things I'm really getting anything like it. And everyone started laughing when it sounds like Akbar. I don't know why, but back in yes, we basically every day was that. My favorite person in the world is the kid from Eric. Whenever I see him, it's a different shit. We should change that. What's happening in the world right now? Like coronavirus. Coronavirus will all see. Oh my god, yeah. That's honestly not much news about it. It's just like our and oh look, yeah, this is one. Actually, it could be oh yeah. That was not. Yeah. I don't know why. I never said it was maybe I talk about that. What's recent? Oh yeah. Okay, so that's the reason. Oh. Like they want more. Yeah. I heard this speech and it makes me kind of like think of it. Like he said, like most people don't get to meet their heroes, okay? But I was lucky enough to have this as my parents. I was like, wow. Like, that's like so different from my situation.
like having like stalking people. Like, follow them on Twitter, they have to reply to you. Oh yeah. And then it's like my heroes and my parents. So, like, that's a pretty funny. Yeah. Well, someone who was yeah. You didn't hear that. Oh, the parents are actors. That must have helped. And then they went out to us, so like. My parents are even the Democratic, like, it's not like very cute on my votes. It's like, this person like, and then like, it's sort of like random, like, like, some kind of like, the reason that has like some amount, then the next time is like, so then like, this is and then if you check the all but one of them is you should write it down. Republicans, because like the Republicans were created in like the 1680s, like the first thing. And the Democrats back then were like the first thing. Like the Republicans are actually not evil. Like the Democrats are. Wait, no. It was literally like they were created here first. Abraham was created. Oh, it's the Asians like moved out of the great. Asians like probably the first. We want this Chinese. He was the one who was saying he was out of universal basic. Oh, well, that seems like the law. It's like $2 goes on $1. So I guess the difference between the law and the law. I mean, to get that, they have to tax it. They have to everything about it. Yeah, they were saying tax the Amazon. Yeah, freedom of shares. I like it. Maybe tax like commission. Like you know, like they have like that. Some of like the banks and also they say. Like said, 300 million people. So like in America, rent is it's like cheap. Like how much it costs to rent in like a week? It's like how much? We give me $3 trillion. GDP of America is only like 20 trillion. Like like 4 trillion. Oh, do you know what the next number is? I'm sorry, I don't know if the video is bigger than and then I got I was like, hey, after that is I don't think I'm pretty at all. Like, pretty at really like, the thing like, I think for really, I didn't really like this. Yeah, maybe the issue is where the zip code made not. Because, you know, that clearly all. It's not clear. What do you mean it's not clear? I think I'm one of the biggest number, right? It's always like one number that's one bigger conversation. Yeah, I know, but you have like, most people when they think of that, like they're thinking of like a billion apples, right? But then once you have all the apples, where are you getting the next apple from? Or maybe how about like the biggest number as in like any player? Like, it's like you're talking about large number. Where's the ink gonna come from? Yeah, you got the large number already. How you can add one? Yeah, how you can add one? No, you just have something. What are you talking about? How about like a large number as in like any number of parts that's basically better
It's like the digits on white. You only really need to have 40 digits on white. After that 40 digits.
Me. Like once upon a time when I was like 9, it was embarrassing.
I only had like 5 digits on white. I need that.
What's going to be good?
I don't know if I can just stop.
After 30, you may not go further.
You just make the rest up. No one's checking.
Yeah, that's not one person.
Yeah.
I got another 40
No, it's like the guy now is just watching for your random. They're hanging up. They're just repeating now.
I don't want to just. I don't want to just like base one. 1 0 1 0 0 0 0 0 base one. So just I feel like I thought I saw it. I started looking at it. I don't remember what happened.
So I remember like a lot. He was good at calculating pi. Yeah. That was his skill. Oh, that's why he was called pi. He forget the name. The name of the movie. He was called pi because at school he was like bullied or something, and then he started writing up pi, and then everyone became.
Pretty sure some people
And then he went on both, right?
He's
And
like,
everyone was like, "This is shipwreck."
is it?
And then I remember it was like flying fish. Yeah. Did you see this movie? Okay. You know as much as I do. Okay, and so he was trapped on this little boat in the middle of the sea with a tiger. Yeah. I don't know what happened.
It's not like we remember. Remember he got like, he got on fire. And then like,
When you say that, but he's like,
Oh yeah, the tiger just left. Yeah, that's what it was. It was like that tiger sleep. Yeah, that was like one of the main parts of the movie. It's like. The name of the tiger. Like they were even fish to survive. You know, the fish flew at them. Oh, I literally got fish. It's just a weird movie. I remember seeing it. I don't take those.
basically kind of.
Some movies are very clear. You would probably have Hitman 4. Yeah, have you watched any of the Hitman?
I think what one century.
Yeah, no, so this is kind of, I think the formula. So the story always makes you hate someone. The Japanese see the bad things about them. Maybe they have the Japanese. They just know, yeah, I mean, they make people fly to the death and then they kill them anyway. You know, like it's kind of fun.
You're a Japanese.
Okay, and then the way they make you feel good is when Hitman grabs their face and just punches their face. Like it's that particular action. All the fight is pointless. Okay, you just go like this, and you're like yes.
The one I had one, the one that was like, they made the other jacket or something like that. It was like, I think it was basically the guy like outfit with the and so then some like boxes were coming there like they gave him like hard work like to go to school. And then like he the other guy and the other guy basically talking like that. But my guy basically didn't get any like but I know like also like really like
Well, they fought at the end.
they fought yeah.
Because they look like kids.
Yeah,
Or
yeah.
Hitman.
The kids are the start of the video was like almost fighting.
Oh yeah.
Hitman, classic Chinese nature.
It's funny because it's like you think it's like I think like for some people would be like, man, this guy is just too sad, right? Like he just goes everywhere, he feels like around. This must be so tiring. Like the thing is, like at some point you hope your reputation will precede you, right? But he's like proving himself like in every continent. in China, he has to do all this stuff. And then he has to go to Hong Kong, and then no one respects him again. Alright, but he's like 50 now. So obviously it's a bit harder. But he destroys the Wi-Fi, and then he's back in America, like back to zero. It's like Bruce Lee is his disciple. And he still has to go beat the guy up. Basically, how can you explain China?
He beats things off. Basically.
Like, when you do enough maths, you'll need movies like this to make you relax. There's no thinking what's involved.
I'm so mad.
Pure rage and then release. Rage, release. Yeah. And then, and this is not like great thing, value, or whatever. Well, you can't help but like enjoy it.
Right. It makes you mad. It makes it mean that you should eat something.
He punched in the face over and over again while being grabbed in the back of their head.
They kind of think about it.
It's not funny, like, it's kind of like most of the action happens after the guy being on the ground. So, like, a lot of martial arts is kind of just discovering the optimal way to, like, DPS for, like, hitting someone that's already down.
That's actually how it's like. They call it
Yeah, like it's preemptive stuff. Like that guy's getting up to kick your ass. Like all that stuff he's saying is just to stop you from preemptive stuff.
I can take away my right to something.
This person's evil, and therefore should be eradicated. Given how much of it is a thousand times. Hopefully you won't do that again.
And the guy's like the Robert's got a gun and he's like so dumb. He doesn't like hold it off, he just shoots it. And he doesn't know where the thing is. And, oh man. And then people in the comments are like evil.
Yeah. Be watching development. You have to be involved. Like to not do.
Actually, some of the comments in YouTube are pretty funny. Like, I mean, you know that? Like, it was like this, I don't know if you remember, like, there was that video of and it has like so many views. And I saw the comments there. And that's what I guess. It's like, teacher, what is population? I mean, how? 6 million kids. It's like when you're born. None of this like water crap.
How many retards exist in the world? The number of people who survive to start to these things.
Yeah, thanks.
You have to exist by James Charles, but like some.
Like, then people are like, you guys are doing this, and they're like, oh yeah, okay, it's pretty cool. You do this stuff every day, and you do this stuff every day, and like, oh, really? Yeah, that's pretty cool. They only do this stuff like once every 3 hours a year, and he's like, and then he's like, well, whenever he comes up, we travel with them. What do you guys?
Like to wish them on a very long time.
We need a break or do we?
don't know. I don't want to speak next to me. And then the woman like straight up, we didn't have sex for 6 months. And then the guy just like was shocked and looked at his wife like. I was telling just people that go with me. And then so if he like saw that it. And then so he goes up there, like goes to his and he's like so some asshole looks at my arm with it. And then he looks back and sees the guy behind it. And he's like, this is my arm was not the other part. And then so then like they stood there with it, and then the guy like and then he's just like I'm pretty impressed I'm very impressed with how you covered today. You like that people when you go to and like things that I'm kind of pretty proud of that. And like what you did and he's like there's nothing for us up there they're only and then the I just like it's not really my wife can like okay. I basically drink like 3 quarts of this. I sure drink like a lot of beers. I drink like 4 6. You drink like 6. Like my house is small, so it's not even setting. I think it's not the hard one. Maybe it goes there and often. But then like I think 10 to 6 I just lost my way. They decided to some kind of sound in this thing. Eventually makes the point to see my age-old virus family. Well, I mean, everyone's a good so, like, I mean, so it's mostly a bad one. The way you buy is getting concrete. I did like the wall set. I'm pretty sure it's like the experience of having the regard is things like that. It's just like thank God for money.
What time? Time on the live stream? How many hours?
Live stream.
7 hours and how many minutes?
8 hours, 13 minutes.
Dude. One.
There's only one person left.
I'm gonna challenge myself to film myself for the whole day. And yeah, 24 hours live stream.
Are you enjoying it? Enjoying the math?
Maybe. I was asleep for like 15 minutes.
But you got the first part, right? And then you understood what was at the end. Understand this?
Yes?
You saw last time we did inversion.
Yeah.
So now you have a complete picture of inversion.
Inversions are pretty gay.
So your physics thing starts next week.
Yeah.
When do you have to leave? At 4?
I don't know. I really don't know. I'm gonna ask them. Pretty sure it conflicts with like the thing.
Yeah. But you can still go until 3 on your side.
Maybe.
We'll do less problem solving at the start and split it up.
I have a tip. Next time you make a video, make sure not to say it for children, because you know I'm gonna ruin it. That's against the community guidelines. I'm going to make little jokes and like, yeah.
I see. I mean, it's in some sense, I feel like if you're a child, then it's for children.
Yeah, true though. This video is sponsored by 1488.com.
Alright. You tell the others to come in if you can.
Later. Yeah, I'll got this. Where's your...
like I'm gonna watch it.
I know this is a but we consider like a content to any extent. Because like if you think about both sides of the this is not like I don't know why people still like the second oh yeah, I mean, this is a little bit more updated. And if you can, first donate to like oh, if you succeed in the I don't even know it's okay. Wow. That's actually insane. Like how you spent a lot of time on it. You should try again to I'm not going to finish your library. My library, but your library. I don't think anyone school can. No one in my school can. People in my school are not. People in my school are very dumb. No one really cares. I'm like, ever since James May left, basically no one's smart in my school. Basically anybody else is wrong. I mean, we're going into the team, right? Maybe that was like second, the second person was yeah, I think it's very strong. There's three grades you want to get 10. You have to be pretty lucky too, because you have to know about it. Which, like, I beat James Bennett to get mine. When he was AI, when he did AI, I did mine. I beat him. And I did AI, I did mine. My score was actually better than his. And he didn't get twice, but he still got like sections. He always wanted like 3 or 4. That's how it went. When he did that AI, he only had one. He only got my distinction. Yeah, like he did it was telling me, yeah, what was it? Frank Lang did AI. Yeah. That's well, he didn't but he only got like my yeah. I'm pretty sure that the teacher. Janet was a man originally did the A mode, but the head on math, he actually saved us his dog. He never sent it to like the math guy. And yeah. That is big ouch. That is mega ouch for my boy. What is this? The contest is the AI mode. AI mode? Yeah. But like the AI mode. Yeah. How do you even get it? Because what can you do when you do that? You can't qualify. How do you even get it? Yeah. And they're roughly the same time. Basically, no one else will see it. It's nice. I never often talk about it. I don't even often talk about it. It's kind of sad that now AI mode you don't need to qualify. What do you mean like yeah? You mean like they used to well, I mean it used to be APM mode, but that doesn't really help. How about I have an idea? It's called a balance. How about let's make this thing a plutocracy, right? You put like everybody, every student, every student on a computer. The computer selects a random student out of the different students in Australia. Like one from like each of the big players states, like one from New South Wales, one from Victoria, one from Queensland, one from South Australia, one from right? And they select one from each, yeah. And like they just choose the students, and it's like I'm able to do the higher votes go. I'm pretty sure that's what they do in Africa. I think it's like all equal stuff.
have big concerns, but I mean, in some sense, like in the view of society, like most people would think that's the same thing. Like someone being extremely lucky, someone actually doing those tests, like they probably have the same standing for a lot of people. I mean, if I think about it, like you know, like some things that are said like China, like I bet like Chinese things said it probably only exists like 5 people, and 6 people, 6 capacity this whole time. Even with the 5 people, it's probably better than like everybody. China's like consistently. The only countries that are somewhat comparable to China are South Korea. US like longer Korea, Japan, Singapore. Even I'm pretty sure most Russians can also do it. But like the IMF started as like using like Soviet yeah. They also say people like the IMF. You know IMF is not a and graduate kind of stuff. Some countries like Western Africa, like the big example, right? They're just like they only sound like people, like they're only people from place to be on one spot, even though like it's good. The population of each country choose the 5 kids with the highest IQ. On the next number in the seat, 1, 2, 3, 4, 1. What's the next number? A, 6, B, 7, C, 69, or D, not enough information. If you chose D, you are correct. Well, things that like working with people I mean, my school had like all of us like from my school, I did like the biggest program. You guys do it? The base how you pay for it is basically like yeah, that's a good personality. Oh yeah, no, the biggest program is your verbal, numerical, abstract, spatial, and that was some reason I got introverts. Is there any other way to do things? Actually, apparently there's a personality type. Or what? It's called conscientious. Like do stuff that you said you're going to do. What the hell? That's the thing. That's not a test. Do stuff that never said they'll do. I'll do the stuff that you said you'll do. I remember I once did a 16 test. I did this test, and for some reason, I got 90% now. And they give like lines. Introvert is like basically go to a party, like you already do. If everyone's introverted, like for someone to step up to be if you go to a party, what would you do? 8% same like 4 I wouldn't do that. If for some reason a reincarnated as a force to come to and he doesn't eat it, and if you don't come to the party, you'll be fast. So therefore you come to the party, you see that's watch around the world. What do? You stand in the corner and have us off on beat this one. You find anyone you can be a challenge by you can't leave. If you leave, everybody in the room will be gassed. Because you guys are partying in the gas chamber.
Yeah, that's like, you get the look out.
Yes, definitely.
like they have like we have like 4 things. And there's like 2 different combinations, 2 different but I feel like like things that classify other people. Like they don't necessarily you just use 6 hours concepts. Too much talk. Too much information as well. So yeah, maybe I'm using one of these. Wow, I spent a lot of money. Yeah. You should actually send this to publish. I think I would publish. Really? You know how to do that? I don't know. Just maybe go to like something like this, like publications. Like maybe it's going to like a school. Actually, I have this experience with this public that we go to like oh yeah. Yeah. So I went to the guy that was like he's like, would you publish a book? And he looks at it. And he's like, yes, I would. And then took the book and he's like, oh, I'll send you all the paperwork and stuff. Okay, cool. And then it's like a month later. I'm like, hey, okay. How's the paperwork going? And he's like, oh yeah, I'm getting to that. Okay. It's been like almost 2 years. Alright. So I feel like I have to like sell this myself or find like an actual company. I don't know what to deal with that guy. And I'm not gonna like sue him. It's too old. It looks like just genuinely forgetting all the time. Is that national joke? Is that national joke? Alright guys, let's go. I have an idea. You don't like doing my company, right? Maybe you can make a website and maybe you can sell our books then. But just look at the AMT, right? The AMT does that kind of stuff. I don't think the AMT will take yours because they only take like the like.
AMT doesn't publish curriculum.
Oh yeah, true. Pearsons make that. Like, they write their own books so that it also doesn't work.
Yeah, because publishing papers is much more of a jip. Like, you send your paper to the journal editor, right?
What's that now?
And then they wait for like a year, and then they like say fix this, and then it takes you like 4 years to submit like an article. Like it's just ridiculous. Now it's probably better to publish online.
I think the
But
best
then once
chance,
you get it published, you get nothing.
I think the best chances
You
you have
can't
is
even
probably
do your own article in the journal.
Yeah.
You know, like you have to like have your own.
the best chances will be with DK.
Actually, we recently got a paper published. Oh, it's like after so many years.
What is it?
Oh, it's this thing on Lie algebra stuff.
Linear algebra.
Oh yeah, it's similar.
Similar. Maybe you could,
Alright, let's go.
you're definitely not going to. I think well, maybe you could try Scholastic. Does that work?
Alright, so I guess what I want to do is I want to talk about 2 of these exercises or something, which I maybe you thought about. And then I want to do 5.6, which is an application of inversion. And then we're ready to go. We're really ready to hunt problems, solve them with inversion. Okay?
I have an idea. Is this what's I call open textbooks? You create an account, you put a textbook on there, and then in the book you ask them for like to donate some stuff, money.
Yeah, I mean, if anyone wants to help me publish stuff, I'm really weak in marketing right now. It's like maths. That's not like it's not really much else. Anyway,
Can I try to be your advertising? Can I do advertising because I'm a commerce student? And then everybody gets commerce students.
Yeah, you could, and I will reward you lavishly.
Nah.
Okay, so
You do. If you guys can echo, then you
okay,
should.
so the second question is kind of interesting, right? So it says take 2 points that are not inverse to each other, right? And you want to find a circle that goes through those 2 points and is orthogonal to the inverting circle. Yeah. Okay. So like if you're thinking like why are they not inverse to each other, it kind of draws your attention to that, right?
Yeah.
Like if they were inverse to each
Then
other,
you just find a circle with those.
then any circle that passes through them would be orthogonal, right?
Yeah.
Does that make sense?
Yeah.
So that's like, I mean, that's a pretty important thing, I guess, because so they make it not inverse to each other, right? Okay, but there's still only 2 points. There's still only 2 points, right? So you can still invert. You can invert one of the points, right?
Okay.
So if you invert one of the points, because 3 points make a circle, right?
Yeah.
So you can invert one of the points,
And then
and you have the circle going through those 3 points.
and then if it goes through the 2 points, then
Oh, then the next one also be.
Orthogonal.
Yeah.
Oh right.
That makes sense.
Oh, okay. Yeah.
So basically, if they are inverse, then it's orthogonal, yeah.
Yeah, and
And if they're not inverse, just
invert
invert one of them.
Yeah.
Okay.
Yeah.
So you can get 2 different circles.
Wouldn't it?
Yeah, you could either do P or Q, yeah.
You have to like prove they're not going.
Is W part of the circle?
No, but if but then
Yeah,
it'll be the same.
locations a bit
It'll be the same circle even if you invert P or Q.
Yeah, they can't be collinear here because
Yeah.
What is the omega?
If they're collinear,
What's
then
the
they-
omega?
they-
What's omega?
Wait,
What's X?
it can't be that.
yeah. So if Q is on the same line as OP, yeah,
Yeah.
that's a good point.
That's
then
a
it
good
can't be.
It can't be done.
It shouldn't be able to be done.
Oh, no.
No, you just
No, it's impossible because if it goes through the same line,
Oh, then you can't have a circle that goes through
It's
the.
either
Yeah.
invertible or it's.
Because the circle will need to pass through like 2 points on.
And if it does work, then those 2 points are inverses.
oh, so that's interesting. So if you take P and Q in line with O, right?
Yeah.
Yeah, this book does have these problems. We've noticed them over and over again.
Or so just if they're collinear, then there's no solution.
If the collinear,
Yeah.
oh yeah.
Wow. Yeah.
I think that's clear, isn't it? So if,
Wait, is it taking the inverse of P or taking the inversion of P or Q gives you the same circle? Because the orthogonal circle would go
Yeah.
through Q and then it would be
orthogonal is it's invariant, right? And in that line it is X twice. So it would have to go through the other one, yeah?
Yeah.
But then if Q is somewhere on that line that's not there, right? It can't go through the circle. It can't be on the circle.
P and Q are part of the circle, so I'm going to omega.
They're not inverse to each other.
Yeah, non-inverses. What the hell?
Yeah, so I guess we've solved the
that's
problem.
another thing.
Yeah. So
That's
the
like
actual
circle.
problem.
Yeah.
So if they're in a line, then we'll stop.
Yeah.
If they're not in a line, we can make a circle.
Yeah.
By inverting one of the points. Interesting. Okay, can you see the similar idea solves 3 as well? Like
Where what
is not.
P is not on 2. There's 2 circles. So there's the inverting circle and then there's the other 2 circles. Yeah. And P is not on these other 2 circles. Okay. Find a circle which is. Oh, actually, well, we don't even know. We don't have a name for the inverting circle. Yeah. So there's just 2 random circles. P is not on them.
Yeah.
And you want to find a circle with P on them that's orthogonal to both each circle individually.
That means you can invert from either one.
Would you set one to be the collinear? Like set one to be the one that you can invert around.
Yeah. Yeah, you can invert one with respect to one of the circles.
Yeah, and then you can make another one.
Yeah, then you can so you invert with respect to both circles, right? So you can make P1 the inversion with respect to W1, omega 1. P2 is the inversion with respect to omega 2, right? And so then P1, P2 makes a circle, hopefully, if they're not collinear. And it's orthogonal to both, right?
Yeah.
Because it contains it's invariant. Yeah. But the problem is, what if they're collinear? So is there a way to?
Is it okay to
Yeah. So what if the centers of the circle and the P are collinear? That would make them collinear.
Yeah.
Yeah.
It'd be funny if you invert onto the other circle, the center.
Yeah, but that's just like you have to invert.
Yeah. That's kind of weird, you know. Yeah. I guess we're like this is what happens
It's good to see these things, but otherwise, the logic is never really quite complete. Yeah, so sometimes it's impossible. Oh wait, hold on. If they're collinear. Yeah, you can't get them. Yeah, you can't get a circle to go through 3 collinear points. So that's just the end of that.
Yeah.
Okay. Yeah, and then there's other exercises for you to do. We can go through them next week. So that was just like 2 and 3. They're pretty similar. There's 1 also. It's pretty easy. You just have to have like some time in this room.
Yeah.
4 and 5, I never really looked at, but I think like when you appreciate the inversion, you like the concept, you'll naturally want to do the exercise. They're kind of nice. All right, so the next thing, feuerbach's theorem.
Feuerbach. Ooh.
Yeah.
Feuerbach.
Yeah. So this is like
Feuer.
I don't know if you remember this, but like we started this book from chapter 1. Okay. And back at the end of chapter 1, it said like we're gonna prove this theorem called the Feuerbach's theorem by inversion or something in chapter 5. Okay. When do you ever say that in chapter 1 and actually do it? This is happening right now. Like the promise that was made. It's like a year
Who the
ago.
hell would call a kid Feuerbach?
It was like last
It's
second.
probably 2 names.
Yeah, but
Everyone now.
a box in a foyer. Why?
Box of foil.
A box in a foyer.
Ah, yes.
That does not make sense to me. But okay.
Is that how you spell it? Feuerbach?
Alright, let me spell this. So
I used
we're
to
up to
think-
5.6 now.
It's just like how you used to think that Muirhead is actually just a hell of a mule, but I was wrong.
You use the actually keys.
Oh, it's tiring. Okay, so so I think you actually know the theorem. You just don't know that it's called Feuerbach. 5.6. Oh. Is it Feuerbach or is it Feuerbach? Feuerbach.
Feuerbach.
No, it's 1 name.
I mean, it was like this theorem was so cool or something. They wanted to name. So what is it? It's like it was like the 9-point circle is tangent to the in circle and the x circle. And it was kind of so cool that they wanted to name like the 9-point circle like the Feuerbach circle or something like this. What was they saying?
Why Feuerbach?
It's cool.
I mean, so there's lots of ways to prove it apparently, but one way. There's a lot of ways, a lot of references. I mean, it's pretty cool. People might want to prove it lots of different ways.
Yeah.
The unit circle. So the
Yes.
unit circle named after some guy can do it.
No, not the unit circle. The 9-point circle.
Named after somebody called 9 points. Why? Who has a sand at 9 points?
Okay, so here to do this, we might have to review a little bit about X circles and in circles. But if you remember, the main point about X circles and in circles in terms of the theory was just the length of the tangents.
Oh,
Yeah? Like,
Tangents.
you have an in circle, right?
Yeah.
It touches the triangle
Yeah.
and it makes equal tangents.
Yeah.
It's like the theory is just to figure out what those lengths are in terms of the length of the sides. So if we remember that,
I don't remember.
yeah, we know that.
Something like that. Something to do with like
So a semi-perimeter minus the side length. Remember that?
yes, semi-perimeter minus side. Yes.
Okay, so wait, I want to read this comment because I like historical comments, especially when for some reason the book is already pretty old.
Published by the MAA.
Where's this historical comment? Oh, it doesn't say.
I drink too much apple juice, my stomach is hurting.
Eat chocolate. Replace the flame with that chocolate.
I need it's not that bad. But if I need to
Then increase the pain. Let's try.
increase the pain, or more embarrassingly,
If you're a man.
Okay, so let me try and draw this diagram, okay? So let's find a pen that works. So it's like this. Okay, so kind of like a slanty obtuse triangle. Yeah?
my God, this is
Extend that line. This is A,
I go with tilted side.
B, C, yeah?
Oh, that if I get it.
Because we're going to encircle X circle, yeah?
And you draw the midpoints of A, B, B, C, and AC.
I've drawn the circles first. Right, let's see.
N circle, X circle.
So in circle touches letter X. X circle touches somewhere a bit higher. Call that like
Okay, there should be infinitely many X circles.
There's one per
Really?
side.
I'll call it XB, yeah, because it's XA. It should be XA, yeah.
XD.
X, because it's opposite side A, yeah. Like X. A.
The one with the X on the inside.
Huh?
Oh, it's fine. Okay.
Yeah.
Well, what with the X on the inside?
That's all makes sense.
What do you do about the X on the inside?
Huh?
What with the X then?
So the X is the point where it touches the. Oh yeah. That's a good point. Maybe we just call this X because we're not going to do any on the other sides, and then
okay.
we need something different than that.
Okay.
So maybe this is little X, that's big X.
Yeah.
Angle
Little
IB,
capital X, big capital X.
IA is equal to 90 degrees.
Huh?
IB, IA is equal to 90 degrees.
Yeah.
IB.
What?
It's just the side.
Just half of the straight angle.
Oh yeah.
But IV what?
IBIA. So the angle between.
Is IBIA is by definition
ICIA.
one half of a heterosexual angle.
Okay, so then by symmetry, there's this. There's another
Yes.
tangent. So this is a tangent to both circles. This side length, right?
Yeah.
So there's another thing that's tangent to both circles. It's like the symmetric version, yeah.
It's not a circle, right? Oh, that.
Yeah. It's like you know what I mean. There's like another common tangent.
Okay. So, yeah.
That's an epic tangent. That makes like a completely new triangle. With the same X circle and the same Y circle.
Let's see how these are labeled. So this is labeled B1 and C1. Okay.
So A1, B1, C1 is just basically a different triangle, but with the same in circle, same X circle.
Yeah, it's like BC has it has the same in circle.
That's pretty sick.
Yeah.
That is some epic stuff.
Okay.
I'm impressed.
And then maybe we'll just take a moment here. I guess it's kind of annoying that B1 looks too close to the midpoint. It's not meant to be the midpoint, right? It's just wherever. So the midpoint's maybe like here, okay? And we'll call it B prime, yeah? And the midpoint is therefore here. Here.
Midpoint of AB or AC.
Okay, diagram's not great. There's a midpoint here, A prime, yeah.
Wait, midpoint of AB or AC?
Huh?
What's C1?
Midpoint of AC.
AC.
AB, I mean.
Oh, okay.
Oh, wait.
Okay.
Why is that so far off? here, right?
Yeah.
Okay. Is that everything in the diagram?
Well, we only really need these 2 points to make a 9-point circle.
Yeah.
So nah, not bothered.
Okay. Let's see. Yeah, so I think the labeling is like this. The B1C1 intersects the blue lines, okay? And they have names. B triple prime and C triple prime. Yeah.
Oh, God.
Oh, maybe it's double prime then, sorry. Alright. C triple prime. Double prime. Okay. Alright, before I draw anything else, I think the other stuff is just for later stuff. Let's see what we're trying to do here, okay? Yeah. Okay. A circle with. Okay, so we're trying to prove that the 9-point circle is tangent to both of these two things, yeah?
Yeah.
For a start. Okay, so remember what the 9-point circle was, right? It was, well, we know the 6 points were pretty easy to remember. It was like the midpoints.
Speed of altitude.
Yeah, so.
And midpoints of the vertices to all center.
Yeah, so B prime, C, A prime, C prime, yeah? For this argument, we only need these 3, okay?
Yeah.
But when we can use the orthocenters to say something else later, okay? So we only need to know that the midpoints make the circle, okay?
Yeah.
Good enough.
Yeah. Okay, so what's the claim? The claim is, if you look at this circle, with diameter XXA, okay? XXA, yeah? We might have to prove that A prime is actually the center of that circle, okay? But it's not going to be too much harder.
That's not too
Okay.
Because I'm pretty sure XB would be equal to XAC. I know that.
XB equals
XAC.
XAC.
Yeah.
That's just like something.
Wait,
I proved it once.
Yeah.
Oh, we can just mess with using the
Okay, so this circle, okay, with diameter XXA, yeah?
Yeah.
It's going to be our inverting circle. So that's like the omega, yeah?
Oh, okay.
Okay, and the claim is if you invert the 9-point circle with respect to that circle, okay, it turns into B1C1, the line. Okay.
Oh.
Yeah.
So that'll prove that it's tangent to that.
Yeah, because B1C1 is tangent to both.
Yeah. Oh, I see.
Then therefore the 9-point circle will have to be tangent to both.
Yeah. Oh, okay, yeah.
Yeah.
Okay.
That's kind of cool. Huh?
Inverted, so you inverted about A1.
X.
So it's not like it's kind of like it's not completely trivial, but like once you know what you're trying to do, I mean it's kind of routine, yeah.
Yeah.
So it claims also that. So you got to read if you're reading the book, you kind of got to read it backwards because it just starts the calculation and you don't know what you're doing. But like, I think what you're trying to show, like something you can show, for example, is that like B1, so the midpoint here under inversion goes to B double prime, I think.
Oh.
And then.
Wait, is it a tangent?
Huh?
Is it tangent? Isn't that like invert to itself?
Oh no, B double prime is where the blue line intersects the red line.
Yeah.
That's a bit confusing. That is actually confusing.
Did I label the tangent point?
Then what's C double prime?
Diagonal lines.
Oh, okay. Yeah.
And then the C prime goes to C double prime, I think. Yeah. Okay. So I mean, they should go inside the inverting circle, yeah, because they're outside.
Yeah.
And what it's saying is actually it goes to B double prime.
So
Yeah.
A prime C double prime times C
Yeah.
prime.
So basically, you have to so at the very basics of it, it's like A prime B prime times A prime B double prime equals
Wait, what are you like?
the diameter, the radius squared. Yeah.
Which radius?
Uh-huh.
Oh, the radius of the
Yeah. So XXA. Yeah.
So basically just a geometrically
Yeah.
interesting.
I write it in red as well.
XXA squared.
Yeah, because X.
It's not the time.
Wait, no,
That's
no,
like-
XA1, XA1,
On
XA1.
two, yeah.
On 4.
Yeah. Even after on your school, yeah. Not
Is
really
it just
long.
XA1?
This is epic.
Okay. So that'll motivate a lot of the calculations. I mean, can you see, for example,
So if we prove that, we just start.
yeah,
Yeah.
because then
Two
you know it
points.
goes to a straight line because they're both circles. It's a circle that passes through the center, right? So it goes through a straight line. Yeah. And
It goes to a straight line.
so if 2 points, if it goes to, so if you know two of the points on the circle goes to two of the points on the line, then you know the whole circle. is
Yeah.
going to
Yeah,
hold
so
on.
you just have to prove that like 2 points.
Yeah, so you just have to prove these two things,
Oh, okay.
or you can prove these two things. Yeah, you don't have to use these 4 points, but we only know these three in this situation. Yeah, we could do the orthogonal things as well. I think there's an exercise that asks you to show where the other stuff goes. Probably.
Wait, on my computer later.
It probably won't be later. This might be. Okay. So it'll help to find some of these lengths, right? I mean,
It's chasing.
Wait, C double dash would be.
C double dash is where A1, A prime, C prime meets B1, C1.
so we got some obvious lengths already, right? Out of the 4 things or the 6 things up there, right? A prime, C prime, and A prime, B prime is obvious. Yeah.
Yeah, it's half AC.
Yeah.
Yeah.
So we got that. Let me write that down.
Wait, it's half one.
So A prime, C prime is just it's parallel, yeah. It's like parallel to that side.
Oh,
so
yeah.
it's just B on 2, yeah.
Yep.
A prime, B prime is equal to C on 2, yeah.
Yep.
Okay. So that's that part done. I think XXA should not be too hard. XA. Do you remember, like, we know the length of XB, for example? Like, if we can, so the length of XB is like the semi-perimeter minus
Minus.
So we go to minus AC.
minus AC
Yeah.
minus B.
Yeah.
So this is S minus B.
Yeah. Yeah.
Yeah, good.
There's nothing S minus C.
This thing here is S minus C.
No, that can also be S minus B.
S minus B.
Yeah, XIC is
Oh, is that also S minus B?
Wait, why?
Yeah, just sure.
Wait, why?
So I mean this whole tangent thing, right? Is equal to this whole tangent thing, yeah?
yes.
And then this part here is equal. Wait, so
Oh yeah, and that part that's equal to the BXA.
I mean the whole tangent thing is meant to be the semi-perimeter. The whole two of them is the perimeter. That's,
Yeah.
That was one of the lemmas we learned.
Yeah.
In X circles, yeah.
Yeah. Oh, cool.
Yeah. So this length is S.
Is S and minus the B is the,
Yeah, because
I see.
I see.
Oh, then you prove that A is the center.
Yeah, and so this whole length here is A, right?
yeah.
Yes, that's
A minus 2B minus 2. Onto that. Yeah, that one. Minus.
So what are you saying? We got X A, right? Equals to
A minus 2.
A plus 2B minus.
A plus 2B minus 2x.
So that'll be B minus C.
Yeah.
Yeah, B minus C.
B minus C.
B minus C. Oh, okay.
Hold on.
So we prove that B minus C squared on 4 is equal to.
Yeah, it is B minus C.
Wait, why?
So it's
You got
so
A-
this is A plus B plus C.
So you have BC is the whole length of BC is A.
Yeah.
And then you have XB and XAC, S minus B.
Yeah.
So you just subtract.
Oh.
So we need to
B minus C. So what's B minus C squared on 4 is B squared plus C squared minus 2BC, right? Divided by 2 on 4 divided by B divided by B on 2. Divided by B on 2 to get the length of A dash C.
Why? We have C over there.
Because that's what we need to prove.
Yeah, we need to find that.
Yeah, so we can like assume that it works and see what like it's supposed to be.
Yes. Okay. That's it.
But it's kind of annoying to do. It doesn't look nice.
Alright, so the next part is not quick, but it's not like it requires one observation. Okay. So what are you looking for? You're looking for A prime C double prime, right?
Yeah.
I told myself how to bad.
So great.
Maybe maybe it's more visually convenient to focus on A prime B double prime
Okay.
because that's more obviously parallel to the base. Yeah.
Oh,
Yeah,
it
it is.
parallel stuff.
Wow.
Because similar.
So then, like, I think it becomes a matter of finding the length of this.
Oh wait, and then
What?
wait, that's not that hard, right?
What?
You just,
What's parallel?
what? It's just midpoint.
Because it's the midpoints of the
Do you mean A prime B double prime? A prime.
Yeah, A prime B double prime is the same as the A prime B
double
prime.
is the same as A prime B. Oh right, yeah.
So this is okay. Parallel. Oh, I should draw this one.
Oh yeah,
There
parallel.
was another point that was labeled. Maybe I should have labeled another point.
Are we flashing this? Wow. It's basically like three pairs of parallel lines, anyways. Don't think about it. Don't you dare think about it. Because you find like IA and all this shit. So it's
Not even as prove something using inversion by code back into proving
I invented a new form of math bashing. It's called
Oh, okay. Sorry, there's another point that's kind of helpful to label. This S is the intersection of the red and black, so the BC and the red line.
Well, that's important. BC
Well, I guess it makes you pick.
I mean,
it helps you pick the similar triangles.
You want to
right?
find the
oh god.
So this length here is basically the same as
SBC.
BC1, right?
SBC1, yeah.
Like if you know what SA prime is, right, and SB, right, then you can find. So if you can find SA prime, SB, and BC1, then you can find A prime, B double prime, right?
Yeah, no.
What you did, I know, because XA
S.
XA B
Well,
is
that's
A
not
minus
right.
S minus B.
SA.
XA B, which is the same as BC1. Oh no, it's my bad.
There's some symmetry thing with S because S is. Oh. So can you see that if we can figure that out, it'll be the same for the other one?
Yeah, sort of. Yeah.
It's just harder to see its parallel on an angle like that. So maybe we can try to figure out what C1 is.
C1.
It's like a reflection of the other.
I mean, this is basically reflection.
It's just a reflection.
C1 is a reflection of C across the line AS.
Across I.
And you said reflection has something to do with inversion, right? Because like the fat baby thing we saw at the line.
Fat baby thing, yes.
Yeah, we drew the two circles. One really small, which looks like the head, and one really fat. Is the fat chubby baby.
Slice through the head with the line.
The true size of fat chubby baby. So,
Oh, by the way, this also shows that A prime was the center of the circle. Right?
Yeah.
well, it's AISIA collinear. Seems like it is. AISIA. Because like it looks like we can apply the chubby baby to it, except this time the baby is decapitated. So yeah.
Hey, what?
Because the last time like Michael drew a diagram, it looks like this chubby baby. But like, this time it's like it's a circle with center I and a circle with center IA. Except this time the baby is decapitated. What?
What's collinear?
AISIA.
Using the fat chubby baby theorem.
What's collinear?
AISIA. Looks pretty sure it's collinear.
AIS.
Using the fat chubby baby theorem.
What's I? Oh, I is that all?
Yes.
Okay.
AII is
Wow.
Well, the fractional derivative theorem is actually pretty useful. I shall name the theorem the fractional.
Oh, okay. So can you see by symmetry? So this length is C, right?
Yeah.
By symmetry, this is C as well. Yeah.
If you just reflect BC across
the
IA,
line.
you get B1 C1
Uh,
because they're just tangents.
Oh,
so that means this bit is this whole thing is B, right? AC, yeah.
And
And this is B minus C.
Other one is B minus C.
Oh,
C
wait,
B1 is B minus C.
We've seen that
wait, the whole thing is big.
Just
Yeah,
the
yeah,
AC is B,
AC.
yeah.
Yeah.
And then this is the same as that.
Yeah.
Oh,
Oh wow. Okay.
oh, I see. Yeah. Oh yeah, they were
Okay, so that's B1 C, and then
we have okay.
so what's B?
So we have one of the three things we
Very.
Yeah, we just find the S relationship with the other stuff.
S relationship.
The relationship with S.
I see us like cold.
Well, S is actually quite special. It's basically the center of this diagram. It just stands for. You should just label it N to make it stand for neck, but alas, it's not. N for neck.
The baby has no
The baby is decapitated.
precisely.
would it help to try to know what S? Like, I mean, we kind of know what it should have to be. So we need the ratio. Like, what do we need this to be? We need AB double prime, right?
Yeah.
To equal.
A prime B double prime.
Let's see
What that?
B minus C squared divided by B12.
Well, that's good.
Oh, C.
So didn't you mention that A prime X is equal to S? No crap, I'm retarded. The point is S. The point is S.
Oh yeah, you want it to be equal to B minus C.
Like,
Yeah,
two
divide by 2B.
on 2B.
From 2B.
X. A.
Sorry.
Diagram is really misleading. It's really screwing around with me because like A prime B double prime looks like a tangent, but it's not.
Yeah, but you can't even use that.
That's really screwing with my mind. Makes me reconsider everything I see.
B double prime is like this.
Wow. Warrior box theorem.
Yeah, I think I see how they're doing it, but I remember doing it another way.
Another way.
Basically, you want the ratio to be B minus C on 2B. Is it?
So A.
Because you find BS, we know as A dash, and then we have ratios.
Yeah.
Right, so we're trying to find CS, and then that's the same thing.
Minus CS, yeah.
But,
When if you find like
Wait, how does if you find BS, you know, yeah. Yeah, if you find CS, you can Pythagoras to third side and then you know.
Pythagoras.
Like if Pythagoras third side you find CX, which find SX, which find Q. There are other ratios and stuff. Oh, I mean, no.
Yeah, the diagonal is
Just,
really misleading.
Oh, you just find it as long as you have ratios. But getting BS is better than getting
How obvious is the statement? S divides. We're trying to do one.
The ratio.
The ratio thing. Yeah. So if I read it more carefully, I probably would have noticed. Like, it's a theorem. Yeah. So like, because S, we said S is collinear with IA and A, right?
Yes.
And but this is the angle bisector, right?
Yes.
So we know how the angle bisector splits the base.
Oh yeah. Oh,
You call length
good.
from both
Yeah.
sides.
So the angle bisector
Sides.
divides the base in the ratio
Sides.
Yeah.
of the other sides, yeah? And in this case, it has to be that way, yeah?
Yeah. Yeah, and that's the reason why it doesn't have to perpendicular.
Yeah.
Yeah, and I remember we proved it because we said the bisector was the line, like it was in the book, it was like equidistant from the sides.
Yeah.
So the areas have to do something
Yeah.
nice then, because the heights will be the same. Okay, so then the ratio is B is to C, right?
Yeah.
So then you have a formula for the point.
Yeah. For the point B S. Yeah. Which range
S.
it down.
So BS is is equal to, let me just write it. AC on B plus C. CS equals BC on B.
AC on B. Yeah.
So if you add them, it should equal 1. B, it should be equal to A, right?
It should equal to A.
Oh,
Yeah.
Oh, well, should I have written AB?
isn't it AB?
Yeah.
The AB.
Yeah.
Okay. So
Now
that
we go back. This one BS and SA. BS and SA. BS and SA is to C. BS on SA dash. BS on SA dash.
SA dash is
so you can find SA dash now.
Yeah.
it's A on 2 minus that.
So SA dash
It's A
what
on
is SA?
2 minus that. A on 2 minus 3.
Okay, I don't understand.
SA.
And then what did not work?
Yay.
Why you back on one?
So it's CS minus a on 2, yeah?
Well, yeah. A on 2 minus B.
You get a bunch of cool stuff.
CS minus a on 2. So BA, so A outside of, so A B plus C. 2B
Stacks.
minus
How many do you get?
B minus C. Okay, so this is equal to A on 2 B plus C, B minus C, yeah? Okay.
Let's say it's equal to.
Yep.
Yeah. So figuring out SA prime is pretty easy. Okay. And then SA prime on SB is a key ratio, right? So we have A prime B double prime on B minus C, yeah, is equal to SA prime on SB. So SA prime is this, yeah? So A on 2 B plus C, B minus C, on B on SB, which is A plus C. So it's AC on A plus C.
Really?
B plus C. AC on B plus C. Okay.
Oh, the first is a bit tough.
You can cancel the B plus C.
Did I do something wrong?
I think we batched way too much. You probably made a mistake somewhere.
A prime B double prime on that equals SA prime on that.
Right.
Offenship of this thing is really cool.
You cancel the B plus C.
No. I just typed it.
Yeah.
Wow.
What? Because on search it keeps
Oh yeah, you type
Yeah, so this gives you
And cancel the
A prime B double prime, right? Equals B
Cancel the
plus
B
C
plus
is
C.
cancel,
Cancel the
A's
A's.
cancel,
That's it.
this is C.
And that's correct.
And so they get B minus C squared on 2C, yeah?
I think she retrieved this. I think that's correct.
Huh?
I thought it was 2 but I think that's correct.
Yeah. Hey, we got it.
Okay.
So that's true.
We're done. That just cancels with yeah.
So when you times that by that, you get.
It works. That's why I remember it. Because I could.
And then something similar for the other one, yeah?
Yeah, something similar for the other one. So same for every single side by side.
So yeah,
Why would you ever translate?
Because I get these souls, and these souls are a lot more powerful.
so do you see, so is it clear that now that the 9-point circle is tangent to all of the X circles?
Yeah, that's okay.
You just use different,
Yeah.
you gotta use different circles though to invert.
Yeah. Well, because so basically we proved it by because if we invert it,
You get the red line, which is tangent. Oh, it had to be, see, like it had to be a line, a straight line, right?
Yeah.
Well, I guess we didn't know what we were inverting about, but we needed to get something that was tangent to both circles. And this is pretty much the only thing that's not like.
This theorem is obviously specific. I don't think it's really useful.
The word
It's
useful.
cool though when you want to use it like once.
It's like super specific.
No, but see, like it kind of
You don't really use 9.7.
like it has the purpose of relating all these concepts that you already know together, right? So that's useful.
Like so small.
Like you knew the angle bisector theorem, you knew all these similar triangles and incircles, and this relates it together, yeah? So it makes it harder to forget like where things come from.
Past that point.
Okay, so with A prime, C prime, right? That's
Do you know why algorithm is
Number 100.
Do you know why algorithm is called algorithm? It's a square root. Function of a hash. Yep. Yeah. Backwards. Yeah. Yeah. Nice.
Can we at least name the similar triangles for the other one? Just to
What?
so we got A prime, B double prime, and S, right?
B double prime S is similar to
So that's and then B S C prime C1, right?
Yeah.
So what's the other similar pair of similar triangles?
It's like A prime, C double prime,
A prime C double prime S.
yes. And what else though?
Would be similar to something.
Yeah, with this, yeah. Oh, I was trying to figure out what it was, but I couldn't. Yeah, it's kind of funny. Yeah,
Common vertex should still be S, right?
unless it's like,
It's symmetry. Maybe not.
Well, I guess you get
no,
this similar
Yeah,
triangle.
isn't it? Yeah, CSP.
You get the one. You get a weird, like a kind of a different kind of similar triangle.
Oh yeah, okay. So they're not like
rotation.
rotations, they're just inside.
So this one's kind of flipped, right? This one's just parallel line inside, yeah.
Yeah.
Which one?
So A prime C double prime S is similar to C B1S.
Yeah,
CP1, okay.
because of the parallel.
That's
Oh,
congruent.
yeah,
That's
okay.
congruent to BC1.
Oh, so it's not, yeah.
It's the same triangle. Is it?
Yeah, same kind of yeah.
Oh, so they're just.
And they're congruent, like, that's what it's going to be.
So
Oh, one's just on the other side, yeah.
Oh yeah.
Well,
That's a lot of bash.
It's not that much bash.
I'm going to forget that proof very quickly.
Yeah, but the thing is, once you know what you're trying to do, you can reproduce it.
And will there ever be a time where I'll ever use this?
Okay, so there's some comments here. Okay.
I ever use it?
Yeah.
So in fact, the circle inverts the incircle, and the first X circle. Oh yeah, so I forgot to mention this. Yeah.
Oh wait, no,
Wait, what? What do you mention?
Yeah, I forgot. Did I mention this? Yeah, this is important, guys. So, like, did I say this already? So, the circle with A prime the center and X A, yeah, is orthogonal to the incircle and the X circle.
Well, that's cool.
Yeah. Oh, it's orthogonal. So that's important, right? Because you have, like, if it's orthogonal, it fixes them. Yeah. If it didn't fix them, you'd be tangent to the old thing, not the new. Right. Yeah.
Oh, I know why. Because like
That's our innovation for.
you apply the chubby baby
orthogonal. Yeah.
like 3 times.
I should have emphasized that a bit more.
You apply the chubby baby theorem like twice.
So the tangent would be like CB, right? To the X and to X.
So you apply the chubby
Yeah, so
baby
the orthogonal just means the tangent passes through the center. Yeah.
Yeah.
Oh, yeah.
Yeah.
And
Because like the chubby baby
oh,
theorem.
they do because the tangent's just basic.
The tangent's just
We define. Yeah. Yeah. So that was part of like a really important thing. I forgot. I don't know if I said it. I went through it at some point, maybe in my head.
Chubby baby theorem.
Oh, we get it.
Okay, so that makes that's important. This okay. Keep going. I'll wait for you to come back.
What are you doing?
I need your toilet.
You good?
So there's an unnatural delay between this and this super cool punchline thing at the end.
The chubby baby theorem. Most epic theorem. Very useful. So we did
Oh shit! Are you alright?
Yeah.
Scared me.
That's not the first time happened today. He bumped his head like 7 times.
It's not my head. My head's fine.
Probably like a gajillion times while playing poker.
Yeah, so there's another thing that's interesting out of this. I'll wait for him to get back.
So we did complex smash. We did
with all
we did the inversion thing.
Yeah.
with all the center.
Oh,
we
Pell's
didn't-
equation.
'cause we
Pell's
didn't-
equation.
Yeah, we did Pell's equation, but the thing is, we only have 15 minutes, so
Screw it. Let's just do it because Pell's equation is interesting.
Hey, but do you not want to know the author center thingy and how it relates?
yeah, we did the
I'm more interested in Pell's, but like sure.
We did the pills before. I think.
Yeah, but
yeah.
like,
So
we
the
can
last thing here, okay. The interesting comment is if you instead of having the midpoints, right? You think about like the author center, so the perpendicular
Faces.
yeah, the base, yeah. So you can have like what was the claim? So you have the feet. So you have the author center with the three vertices of the triangle, yeah. And then that gives you so quite a few triangles, yeah. It's like A B H,
Yeah.
B C H,
ACH.
yeah. And what is it I'm trying to say? Do they all have something? They have the same 9-point circle.
Oh.
Wait,
So
what?
one circle.
Which ones?
Uh,
Yeah.
Yeah.
That makes sense.
Which ones? You mean like A B C
Kind of like
A
similar,
B C because A B Y C one, right?
The midpoint.
Orthocentric points. So
Yeah.
it's like if
Yeah.
they have the same. If they all pass through the same perpendicular basis.
Yeah.
it's
So
also
the
same
midpoints become the midpoint of the office of the
Yeah.
altitude.
Wait, can you say?
So they have like so if we took the author center, right? And the three vertices of the triangle. There's the four things, right? If we took three of those things and made a triangle, okay, then the 9-point circle of that triangle should be the same as the 9-point circle of the original triangle. Let's see. Because the feet of the perpendiculars.
Is that the only game you have? Dude. How many games do you even have? How many games do you even have? I also like
I played Roblox, I played Apache Radar.
Oh yeah, because remember how the 9-point circle was defined?
Oh yeah.
It was like, hey, was the 9-point circle defined like this? It was like the midpoints, the feet, and the midpoints of the author center to the feet.
Wait,
So
on
the vertices, the vertices, right?
Yeah.
So then, so three of those points are on those other triangles.
Yeah, well, yeah, the points are the same. Like for each of the different.
Wait, what's this? Is this still the?
Yeah, so he's asking why the 9-point circle is the same. So is it? So yeah, if it's the midpoints, feet, and the midpoints of the vertex to the author center, right?
Yeah.
Is that right?
Yeah.
So if that's the case, the midpoints of the author center to the side is on the triangle.
Yeah, and then the other two stuff, the other stuff are like
Yeah. So you get three of the points that you need to define 9-point circle in each one of those triangles. So in particular, like if you have like H, right?
When I'm double jumping
Like if you got H somewhere, the feet of the perpendicular to AC, like for example, ACH, yeah? The feet is on that triangle, yeah? Yeah, that's one point. The midpoint of this is on that circle, right? Yeah.
And the midpoint on the other one.
And the midpoint on the other one, yeah? So that's on its 9-point circle will go through those 3 points.
Yeah, and
Which has 3 points in common with all the others, yeah? So that's crazy, right? Because there's four different triangles, yeah?
that share the same 9 points.
But they all have the same 9-point circle, okay? But they obviously have different in circles and different X circles. So there's like this one circle, this tangent to 16 circles, okay?
Wow, that's pretty epic.
Yeah,
But guess what? I can name a circle that's tangent to infinitely many circles. It's called a unit circle.
Okay, incidentally, the
Like, can you
9-point
name
circle...
it infinitely many?
Incidentally, like
Can't name
no,
it.
it's like, but none of those circles are like your friends.
Yeah.
Like these are like the guys who grew up with. It's like these are the guys who grew up with kind of like this other guy was tangent to all of them. Okay.
Why is it for the canon?
The 9.
It's like a
the
weird
16
tangent.
tangent circle.
It's like a weird friend network. There's one guy which is friends with everybody else.
Okay, so incidentally, the 9-point circle determined by D and F, which are the intersections of pairs of opposite sides of the orthocentric quadrangles.
Yeah, we will do a whole. Yeah. Oh god.
Yeah.
Yeah, I did that with that, and then
Okay. In other words, the four triangles ABC, BCH, CAH, ABH all have the same 9-point circle. However, each of these circles has its own set of 4 tritangent circles. So tritangent just means X circles and N circles. Thus, the orthocentric quadrangle determines a set of 16 circles, all tangent to that one circle.
Okay.
Yeah?
Yeah.
That's all. That's what we just said. Oh, and that concludes the inversions. There's some other things with inversions, but like I think those will be better covered later, especially when you're doing like year 11 and 12, when you're doing more like calculus. Some of these functions kind of look more interesting in that
kind of
context.
weird.
Like exponential.
Some things that are so abstract
And the exponential
geometry
functions
can
really
help a lot. That's actually weird.
Huh?
Like some abstract concepts like inversions, they're so abstract, yet they're so useful. How?
Yeah. Well, I guess that's the other side of it, right? Because in the easy stuff you specialize, yeah. Then you find your idea in the special cases.
I'm like algebra actually
Because
makes sense, but like
you know everything about the special cases. But in the abstract, you can also generalize, yeah. And generalize is like another way to find solutions because there's nothing else to do. There's only some things you can do.
Complex. We make humans made up complex numbers. Algebra's always been there.
Alright, if someone can you guys help me erase this so I can see how far we can get into Pell's equation? We only have 15 10.
It's a fundamental law of the universe.
9 minutes.
Algebra.
9 minutes Pell's equation.
Whoops. Pell's equation.
So we're gonna have to obviously continue it, and it's ironic that we're continuing it into continued fractions.
I thought it was a
Shit.
To be continued fractions.
I thought it was a continued fractions.
So yeah, we're gonna do Pell's equation without talking about continued fractions.
Oh, okay then. Yeah. Alright.
What's the continued fraction?
Oh, it's like the 1 on 1 plus 1 on 1.
Oh, right.
Oh no.
Okay.
Yeah.
That retardation.
And then it goes on and on and on.
Oh, sounds fun.
That insane.
And there's like a pattern to how it goes on and on. Or rational.
Yeah.
That insane retardation.
Okay, I don't exactly.
I see.
Let me drink that. That's
Easy.
me. I need that. I need that to live.
Did you see this?
To live.
Did you see the swastika Jewish
Alright.
that?
Okay, let's start with Pell's equation. Okay,
A
you know what Pell's equation is?
X squared.
Let's do like so. There could be an integer here, yeah.
Oh, this
It's a weird hyperbole.
This square free
You
integer.
have to get 3,000.
It's a weird.
Okay.
It's a weird ass hyperbole.
Alright, guys. So
Looks like X.
the thing is with Pell's equation, okay.
Yeah.
So I mean, it doesn't have to be square free, but I mean, the things which have squares in it, you can just put into y, right? So you can assume it's square free. I mean, I'm not totally familiar with this equation. I'm learning it too, but it's not. I mean,
One.
so
Why?
one of the things you could do before you get into the theory, right, is like guess a solution. Yeah.
Yeah.
Okay, and that actually worked quite well for a lot of the Pell's equations. You just got to get like you have to guess a solution, and then you can actually use this one way to generate other solutions.
Yeah.
Okay, and it's actually pretty easy. So
3 and 2.
So 3 and 2 work, yeah.
Y is equal to 0, X is equal to 1. So
3 and 2 work, yeah. Yeah, so the trivial solution will always work, yeah.
Yeah.
0 and 1.
1, 0.
So you can always find a positive, minimum positive one that works, yeah.
Yeah.
So that breaks down when you get to like 13, I think. So this number here, yeah. If it's, and I think it stops up at 13,
What?
29, 61 or something like
What
that.
do you say?
What? They're
So-
like the continued fraction, like
Let's
the
have a look. So I wrote this down.
divergence of the
So
of root 2.
That is
yeah,
weird.
it's 13, 29, 61.
That is weird.
So I mean, the other numbers, I don't know what the other numbers are, but I remember like they were pretty small. So you might run into something that's not small, but like most of them are going to be pretty small. Okay, the first one that works.
Yeah.
But 13, 29, and 61, I think 13s is in like the 500s. Okay, so you got to be careful of stuff like that, right? Because it could 13 looks just like 11. Okay,
Well, if it's like
29 gets into the thousands.
And
Okay.
61 gets in 10 of thousands.
and the 60 gets into the billions.
What the fuck?
All right. So like, yeah. So you can get unlucky, and like maybe some tests will try to make you unlucky.
I find the minimum solution to x squared minus 61y squared is equal to 1. Oh, hell no. Can't we do the other job?
Yeah. I mean, I think you just got to be familiar enough with Pell's equation to want to relate things to Pell's equation. You know what I mean? That's pretty much the problem solving part. But the actual equation solving part, well, so there's this cool little thing. See, if you have like, so in this case it's root 2, right?
Yeah.
In general, it's root D or whatever.
And then
If
you
you
have
have
a continued fraction.
3 plus, so I'm not going to mention continued fractions here.
It's equal to 1 plus root 2 squared.
Okay. So
Or to the end.
yeah, so anytime you take this to the n, yeah,
1 plus root 2 squared.
okay, it's equal to, you know, like a plus b root 2, right?
Yep.
So then a, b is a solution.
Oh, that's cool.
Yeah.
That's also a perfect square.
So that generates solutions. You can try some, yeah?
It is.
Dude, that's insane. I know, right? This is actually insane.
Yeah.
What about 3 minus 2 root 2?
Yeah, so 3 minus
Why is
2
it
root
plus
2.
and not minus?
Oh no, it's plus because you want it to be positive.
Oh.
Okay. And the minus is important too because it's just a difference of squares, right?
Yeah.
Like when you consider that a thing, yeah. So can we try some? So for example, if we square it, yeah.
3 plus
Plus 2.
it's equal to
9
9
plus
plus 8
12.
plus 12 root 2.
12 root 2.
17 plus 12 root 2.
Yeah.
17 squared is 289. 2 times 12 squared is 288.
It works, yeah.
Yeah, that is insane. That is actually
So-
insane.
I think it's always increasing, so it should give you infinitely many solutions, right?
Was it 17 squared? 39. Oh, cool. Yeah.
But then again,
Yeah.
are there solutions that are not in the form 3 plus 2 root 2?
Oh, this is easier than continuous.
Or all the,
Well, yeah, but we haven't proved anything yet. Yeah?
do all the solutions have to be in that form for x squared minus 2y squared equals 1?
I think so. In the end, we have to really go through it to be sure, yeah.
That is bad.
But do you know why? Like, can we at least verify that they're all solutions? Is that obvious?
Induction?
Yeah, in that.
Oh yeah, I suppose.
The induction just means do this properly, yeah. Just do the n equals 2 case properly.
Yeah.
That's really what induction is.
So suppose it's a solution, and then when you modify by those things.
Yeah.
Yeah.
So the way that this is a solution, right, is basically because 3 minus the 3 plus 2 root 2, right?
Yeah.
Times 3 minus 2 root 2
It's equal to 1.
is equal to 1, yeah?
Names.
Like that's what it means for that to be a solution.
Yeah.
Yeah?
Oh,
So for this thing to be a solution, right,
so
Yeah.
just go.
you have to do 17
Conjugate.
minus 12 root 2, right?
The conjugate.
Yeah?
Wow.
And that has to equal 1, yeah? Okay? But what is that? See, this is all positive, yeah?
Yeah.
So when you square it, everything will be positive, yeah? Okay, how do you get the negative 12, right? Yeah? You just make this 2 negative. Does that make sense?
Yeah.
Because that means every time an odd power of that comes up, you get the root 2, yeah?
Oh, wow.
Yeah, and every time it's even, you get the integer anyway, so it will still be positive, yeah?
Okay, that makes sense.
So that means if you're timesing by that, you're really just timesing by the conjugate squared, yeah?
Yeah.
Does that make sense?
Yeah.
And you know that's 1.
Oh, right. Yeah.
Okay? So that works for all n, yeah?
Oh.
Okay.
Good night.
Good night. Yeah, like we usually have a buzzer before we say that. It's like buzz, buzz. People
So
waiting at the door.
No, but x minus b y squared equals 1.
Do you want to try that?
I'm pretty sure the lowest solution is like 2 and 1.
Please good minus.
2 and 1. Yeah, 2 and 1.
Oh,
And then you
yeah,
just
you have to start with non-zero. Yeah.
and you read it, you get a jump with 2 1.
So before we we found the solution, but we didn't prove they were solutions, right? Now we proved that these are solutions. We haven't proved that they're the only solutions. Yeah.
Suppose it's not the
Okay,
suppose
so
it's not the only solution.
I'm not going to be able to do that today. Okay.
What?
What I can show you is how they're related So it's funny. It's like we're relating to the continued fractions, but what we're really doing is showing why continued fractions are important in the first place. Yeah. Okay. So what are the steps? Oh yeah. So what we want to do. So like we have these things called continued fractions, right? And they generate a sequence of things. Basically, you want to show like if x and y is a solution to this equation, then it's a member of the sequence of things for root 2. Yeah? Yeah?
Yeah, that's root 2.
But we don't actually have to phrase it in terms of continued fraction. We can actually phrase it in terms of best rational approximations, which kind of is more natural. Yeah? Because kind of like, what are you doing here? When you put like, when you solve for root 2 here, right? Like x and y, it's kind of like x, it's like, you know, like x on y kind of thing. Right?
Oh, I think
it's like,
yeah.
Yeah. Yeah, so there's like a bit of like, let's see, what do I have here? I'll lay out the steps so that even if we don't finish, we have a plan, yeah? So what we want to show is, we want to show solutions x, y, yeah? Are sort of...
You like dark chocolate a lot.
We finished 2 blocks of mint chocolate.
You
best
You get mint chocolate with
rational approximations.
best. Oh yeah, true. Because of something similar to A, no question 4.
2.
Yeah.
Question 4 was so hard. But now I think I might have an idea how you do question 4.
Which ones did you do?
I think I did 1, 2, 3, 5, 6, but I'm pretty sure my answer to this question 2 is really dodgy. I think I got them all wrong.
Guys, it's 9 o'clock. So people are waiting downstairs.
My mom is.
Yeah.
My mom is also.
Probably because it's school tomorrow.
School tomorrow, but I'm just still asleep.
So let me just write the steps. Okay?
It's Sunday. I mean, normally, even if it's Monday, it's not school.
I mean, no one cares about Mondays. It's just Monday, right? On Monday, you just like. You people in my school don't even care about school at this point. They just like.
So basically, we just need to show. Okay, there's like we have to prove a lemma that says if. So root 2, but we can do root n. Yeah. If our fraction x on y, yeah, is close enough to root 2, yeah, then it has to be like the best rational approximation. So we have to define that, okay?
Yeah.
So
make it a value epsilon.
Oh, like. Yeah.
So 1 on 2b squared. If this is the case, so then x on y is best rational approximation.
What those be?
It's y squared. Yeah. So basically, see what best rational approximation kind of means is like if you have like, it depends on the denominator, right? Because if the denominator you're allowed to be as big as you want, then you can always get a better approximation, right? But the point is like, so for example, so you have a sequence of numerators and denominators giving you like a sequence of approximations, yeah?
Yeah.
Yeah. And the denominators are always increasing, yeah? So what that means is if your fraction, the denominator is smaller than like say Q2, right? Then it's not as good of an approximation as any of the things. Like the approximation here will be better than that.
I think this is like the Fibonacci. Like in the Fibonacci.
So I guess what it means for a sequence to be the best approximating sequence is if you have a rational sequence and the denominator is increasing, right?
Yeah.
Then any other fraction, yeah, whose denominator is, say, let's say for example, say the denominator y is less than qn, yeah?
Yeah.
Okay. Then if it's less than qn, then it's not as good as an approximation as any of these things before Pn or Qn.
Oh,
Yeah.
so you take the
It's-
best one from.
Yeah, I guess all we actually need is it's not as good as Pn minus 1 or Qn minus 1. But
I'll argue more.
but can you see how like
Wait, is
you
it,
have to bound the denominator, right? Because
Wait,
if you
does it
let
have to be better than Does P1 on Q1 have to be better than
yeah, I think that's a good question. So I'll play it safe and say it has to be better. So if the denominator lies between Pn minus 1, Qn minus 1 and Qn, right?
then Pn minus 1?
Then this is a better approximation than any fraction that's got a denominator between these two.
Yeah.
Yeah.
Oh, this is like Fibonacci.
I wish I could have. This calculation is actually not too hard. Okay, and if you know the definition of this, you'll get there. But your parents actually want to go. Like this is probably an issue. Because you have to go to school tomorrow. Okay.
Yeah.
But I can make this up. Maybe if I have time, I can just make a video and send it to you.
All right.
But anyway, this is going to be continued no matter what, because then I have to show that continued fractions are the best fractional constant. Okay, and then therefore the things that come out of the continued fractions are the solutions.
Yeah.
Okay.
Continue fractions. Yes.
Like, will your parents buzz up, or they actually just wait? Yeah. Okay. I better stop.
I think my phone's on.
Yeah, your phone is. I didn't even charge it.
The phone dead and phone full sauce. Wow. One day, I'll invent a new system of equations for David's equations. It's basically x cubed minus d x cubed is equal to 1.
Maybe that's already been not got these.
Oh crap.
Wait, what got the one?
But then again, like x squared is kind of special. Because,
You can factorize it without any. Oh wait,
Yeah, true. You can factorize this one because like it's actually just like x minus y root 2 and stuff.
All right, yeah, 60.
Oh,
Jesus Christ.
Oh,
Or 20.
yeah. And I think Martin like used to on 10.
Oh my god.
But 10 what? FPS.
What?
He caps at 10 FPS on
Oh,
my phone. And it's like, it looks laggy as hell. Like, it's 20 looks smooth, but. No, 20 looks smooth until you play on 40.
No, I play on 120 and I can't get used to 60 at all.
Really?
Yeah.
What?
I play on 120 on my iPad.
Oh,
I can't get used to it.
I play on 20 cap.
And then it's like pretty good. Yeah, but 120 gives you such an unfair advantage. 120 gives you such an advantage.
Mm.